Good morning, boys and girls, ladies and gentlemen. I welcome you all to the second edition of India's biggest React conference, React India. I'm Ankit.
And I'm Rajat, and we are here to guide you today through the exciting talks that we have lined up for you today.
And also to remind you about our great sponsors, like how commentators talked about Tata Safari, or was it Nexon?
I think it was Nexon.
Tata Nexon in the recently concluded IPL.
All cricket fans should get that joke.
We are live today all the way from Silicon Valley
Of India, which is Bangalore.
Thanks, Rajat, for ruining my Instagram post. Now I can't tag Hollywood as my location. But as you all see, a lot of work went into this that you can't imagine at all sitting at your comfortable homes.
Yes, we started yesterday for the studio over here, and we reached today right on time.
True, everybody loves Bangalore traffic and the jokes about it. And to add on to that, the rains that are showering this place. So, Rajat, how are you feeling today?
I am super excited and super nervous to be part of this event, Ankit.
I think, Rajat, the excitement part you say goes out for everyone who's watching this right now, sitting in their beds or at whatever place you sit at this point of the day and tuning into your Zoom meetings with your mic muted off.
No, Ankit, I'm excited because we have got some really fantastic talks from some really awesome React developers lined up for you today. And that's all thanks to our very, very, very generous sponsors.
But before that, before we go into our learning mode, we want to show you something very, very special that will blow your socks off. So right on your screen, starting in 1, 2, 3. Previously at React India.
Previously at React India.
React India. React India.
and within a couple of steps your application will be up and running. So yeah, that's a great news for us. working group. So this is the first time React team came up with this idea of launching a working group specific to the version 18. It's basically a collaboration between a panel of members of React community and the React core team to help in gradual adoption of the new features in React 18 by the whole community. And it's also hosted in GitHub discussions, which is actually public, so anyone can just follow it and keep themselves updated about the release. This is the first thing which we do when we just get to hear something new and exciting, and then that's what I did. I just googled about out of box improvements in React 18. This is what all came up, and just took a screenshot of it. Well, this is not all the out of box improvements. It's just something which Google shows up when you type it there. So I just took a screenshot for fun. But yeah, now let's look at the actual out of box improvements which are happening in React 18. Automatic batching. We'll get into details of it in the future slides, but yeah, this is one of the out of box improvements which is happening. Server side support for React Lazy. This is also going to help us a lot. Okay, so automatic batching. Before we, I just have a fun quiz for all of you. So please be there with me. Yeah, so we just have a button in, as you can see in line 11, and you have an on-click handler. Now when you click on the button, these are the 3 states which are getting updated. Can you just tell me how many times this app will re-render when the button is clicked? Just as if you really don't have to be accurate, but yeah, what's a simple guess? What do you think? So it will be thrice for each click. Damn, like we have 3 set states, but yeah, thrice, 3 times the app will re-render. That's crazy, right? Now, here is one second quiz. You have the same button and the on-click handler, but I've just removed this set timeout of it. Now, can you tell me how many times the app will re-render when the button is clicked? Yeah, come on. Okay, so it will be just once for each click. So you see the difference. The earlier example also had the same exact 3 states getting updated, and here also I'm doing the same. But the re-rendering is different in both the cases. Well, of course, this is something which we will be expecting, that app should render once when we are doing a set state multiple times, but that is the end state which the user will see. If the app is rendering thrice, there is a high chance that you will have some inconsistencies where, let's say, the counter will get a count is not updated or the flag is. So those are kind of inconsistent states which the user will be seeing, and that's not really a great experience. So the end result should be that, okay, what I see is the final result where everything is updated. So even though I have n number of set states, but the app will render just once. And that's batching. Okay, now, so yeah, clubbing the multiple state updates into a single render is what is called batching. And this is basically done so that to optimize the performance, because you don't really need to render the app as many times set state calls are happening, right? Now, to make this a bit interesting, let's have a real life example as well to have a better understanding of what is batching. So let's visit the grocery shop. Let's say you have to buy n items from a grocery shop. You have a list of n items and you want to buy it from a grocery shop. What do you usually do? It's a very simple, right? What do you usually do? Don't take, by the way, this is just an example, don't take it too seriously, but yeah. What you usually do is go to the shop, buy the first item, return back home. Go to the shop, buy the second item, return back home. Go to the shop, buy the third item, return back home. Well, and you repeat these for n times and then you return back home. So going to the shop n times and returning back home to buy n items, that's really crazy. Now let's relate it to React. Let's say every time you visit the shop is actually a re-render, and every time you buy an item is actually a set state call happening in React. Okay, So if that is something we consider, then oh my god, there are n re-renderers and n set state calls, right? That's crazy. It will just lead, it will just the app will just become really laggy if these many renders happen. But yeah, that's what will happen in React if it's actually rendering every time for every set state call. Now this is not what we do in real life. Instead, what we do is we go to the shop, we buy all the n items, and then we return back home, right? This is what we do. And if that is the case, then you actually have the set state call n times, because every time you buy an item is a set state call, but the re-rendering is only once because you went to shop only once, right? And that's what we are defining as batching, that irrespective of how many state updates you do, you should render the app only once for that particular block. So yeah, now until React 18, only the state updates inside the React event handlers were batched, as you saw in that example where I removed the set timeout. And we had 3 state updates. So that time React was actually updating the state only once, which is great, even though there were 3 set state calls. But in the set timeout or anywhere outside the React event handlers, be it the native browser events or set timeout or fetch, anything, those set state calls will not be batched, and it will lead to that grocery situation where you go to n times the shop and n times re-renderers. That's just basically what is right now happening in React. So that's now solved in React 18. All the state updates are batched automatically with the new root API, which is the create root API. And this is something which is an out-of-box improvements. You really don't need to put any effort to get this. You just need to use the new root API and you will get it out of the box. Okay, now the demo time. This is the fun part of the talk. So, okay. Now I have the same code which I was having in the quiz. We have a button. We have every time you click on the button, this clicked counter gets updated, and every time the app is re-rendered, this rendering count gets updated, right? So this is React 17, and let's see what happens when I click on the button. Okay, I clicked on it. It counter got updated and rendered thrice. Again thrice. Again. So okay, 3 times, rendering 10 times. Okay, and this is what is happening right now for React 17. But let's look at what happens in React 18 with the same example. It's the same example, it's just that I'm using create root instead of React down.render. So let's do the same thing again. Click. Oh wow, it just rendered once even though I have 3 set state calls here. Okay, click twice, rendered thrice. Amazing. It's just 4 times rendering, right? And that's what is expected, and that's what we were looking for. So this is something which is actually going to boost the performance of the apps to the great extent, because it's actually rendering, it's automatically batching those set state calls. Okay. So yeah, but what if you want to opt out of automatic batching? There might be some use cases where you really don't want React to batch these updates. Instead, you want to re-render the app for the set state calls. Basically how it is happening right now in React 17 when the set state calls are outside React event handlers. So in that case, React gives you an API which is flush sync, React DOM.flush sync. And you can just wrap your state updates inside this API, and that's it. React will force re-render the entire tree for the updates which are happening in the flush sync. So those updates will no more be batched automatically. But yeah, this use cases should be very rare. It depends, but yeah, still React has this API if you want to use it. Okay, so we just covered the first out of box. Now let's look at the next one, which is, well, Suspense has already been there for React, but there has been some limitations. So let's look at that. But yeah, before jumping into the limitations, let's just quickly review what is Suspense. I know most of you will be aware of it, but still, let's just do a quick review. So yeah, Suspense is basically a placeholder which you would want to show until a component or its subtree is rendered. That has been the definition for Suspense till now, and it was introduced in React 16.6 in 2018, but with client only support, and that is the limitation of Suspense right now. So the use case, one of the use case which you would have come across for Suspense is, let's say you were loading an editor component on the client side and you start lazily loading it to avoid it into the main bundle, and until you show it, you used to maintain its loading state earlier, but and you show a spinner until the editor is loaded. But with Suspense 16.6, you can actually just edit a component and with Suspense, and Suspense will take care of showing that spinner on the client side, right? So yeah, that was one of the use cases in Suspense. But yeah, now let's look at the improvements on the Suspense, which is more exciting. So yeah. So in React 18, the server-side improvements have been added. That is what we were missing, right? So yeah, that has been added in React 18. The server-side support for React Lazy has also been added. So it wasn't possible to lazily load the components on the server using dynamic import code splitting. But yeah, now it's actually possible with React Lazy on the server side, so on the server side as well. So yeah, but now before jumping into the improvements, let's actually have some discussion on the quick fundamentals. I know that most of you would be aware of it, but yeah, just let's do it, because some of you might be still thinking that, hey, what is client-side rendering, what is server-side rendering? So let's just do a quick overview of it. So what happens in client-side rendering when you type the URL in the browser, and client will try to request for the data from the server. Then the server will try to fetch the data for the app. It will try to send the response to the client. But mind it that till now, the user hasn't seen anything on the page. It is just blank for the user, because there is nothing for the browser to show in the page. So it's just a blank page. And then the browser will start loading JavaScript. And now the content is loaded on your page and it's interactive, and the page is also interactive. So yeah, now user will be able to interact and with the page, and whole of the content is loaded, and it all happens in one shot. Now there is one problem with this, is that let's say you are on a slow network device. In that case, what happens is that you see a blank page for a long period of time, and that's unfair for the users who are actually on slow network devices. So that's add on to a bad UX. So to solve this problem, there was something introduced called as server-side rendering. Now let's quickly look at what happens with server-side rendering and how it is different from the client-side rendering. So client requests the data from the server fetches the data for the app. But does it really send back to the client? No, it doesn't send back to the client. Instead, what it does is it renders the app and gets the HTML on the server. Then it tries to send it, and then it sends that HTML response to the client. So now user has something to see on the browser, because the client just got that HTML response from the server. Though it is not interactive because JavaScript isn't loaded yet, but that's fine. Better than nothing. You still have some content to see on the browser. Then the browser starts loading JavaScript, and after that React starts attaching the event handlers to the HTML elements. Basically, React walks down through the server HTML and tries to attach the event handlers to the HTML so as to make the page interactive. And yes, then the page is interactive. So here you see that the time to make the page interactive and the time to actually show some content on the browser, that time has reduced a lot because users are able to see content way faster than what it was on the client side. So what are the advantages of the server side rendering? It actually loads the website faster and improves the initial load time because you start seeing the content faster. On slow network devices, it of course improves the user experience because you are seeing some content. It's not like you are just seeing the blank page for a longer period. And of course, with this, since it loads the page faster and it has a better indexing, so it improves the SEO as well. So yeah, and that's the reason most of the apps, most of you would have been using server-side rendering for these improvements, for this UX and performance improvements, right? But this has some major issue in React. The way server-side rendering is working, it has a major issue which we might not be aware of right now. We might not have realized, but it is still there, and that is that it has a dependency on the previous step. Now, what does it mean is that every step, let's say you send the response from the server to the client, then you start loading the JavaScript, and then you start hydrating, and then you make the page interactive. All these steps are actually dependent on the previous step. It cannot be started until the previous step is completed, and this actually adds on a delay at the end because if any of the steps take more time, then ultimately your page becoming interactive is actually getting delayed. So to better understand this, better understand the major problem, the issues right now with React or the server side, let's try to actually let's look at the server side rendering when we try to build a Twitter clone. So this is the HTML, let's say, which you get when you are building the Twitter clone from the server. So do you see anything missing out here? Yes. The tweets aren't there. Come on, the tweets should be there, right? The tweets are not there. So since you are building a Twitter clone, so tweets should be there. You get it from the backend in the HTML response, but it's not there. So what happens is that until and unless you have the data for the tweets, which your backend API, which whatever is responsible for you to fetch the tweets, that tweets are fetched, the server cannot send the HTML to the client until then. So that means you need to fetch everything before rendering anything. And what it means is that let's say that the API layer, which is responsible for fetching the tweets, is little slow. So, and you really don't have any control on that. So at the end of the day, what happens is that the HTML sent from the server to the client is actually getting delayed. And that's not fair for the other parts of the app, unless they are getting delayed. So you need to take some hard calls on whether you can remove just remove it from the server side and let it be on the client side. Let me fetch the tweets on the client side itself. But then again, you are hurting the UX. Anyways, because if you do it on the client side, unless the JavaScript is loaded, you really can't see the tweets. And if you are waiting on the server, then again, unless the backend gives you the tweets, you can't really show anything to the user. So both ways you are hurting the UX, right? So yeah, so these kind of components which have a backend dependency, it will delay the time by which the server is sending the response to the client, right? So that's the first issue. Now, after you got the HTML, so now you have the HTML, as you can see, in this first tweet, second tweet, third tweet, right? Now what happens is the browser will start loading JavaScript and the hydration has to start so as to make the page interactive. But there is one issue here, that hydration cannot start until and unless the whole JavaScript, the JavaScript for the whole app is loaded. Which means that let's say the tweets component has some complex interaction logic, due to which the JavaScript for the tweets component takes some time to load. So due to that, what happens is that it leads to delaying the hydration of the entire app, and due to which the page becoming interactive actually, the time to make the page interactive actually increases. So yeah, you need to load everything before actually hydrating anything. So yeah, the JavaScript for the tweet component needs to be loaded before starting to hydrate anything, before just beginning the hydration. So again, this is one of the problems. And again, you might want to think that, okay, let me just and in this case also you can't lazily load the tweets component, because if you lazily load it, and you will have to remove it from the server output, because lazily load is not working on the server side. So yeah, that's the problem here. So you need to load everything before hydrating anything. And the third one is making the page interactive. The way it makes the page interactive. So once the hydration starts, it's not like, the home page is hydrated, so your page is interactive. The notifications are hydrated, so notifications interactive. Doesn't work like that. It will actually work at one shot. Until unless the whole page is hydrated, it will not start. The page will not be interactive. So you need to hydrate everything before making anything interactive. That's how it works. So yeah, it's not like you make the nav bar notification interactive until unless tweets are hydrated. So yeah, we learned about 3 major problems here. The first one is fetch everything before rendering anything, which means you can't send the HTML to the client unless you have fetched all the data. Load everything before starting the hydration. Make the page interactive unless and until the whole app is hydrated. And this all things have one thing in common, which is that it happens for the entire app or it doesn't happen at all. So fetch the data for the entire app or don't render anything. Load the JavaScript for the entire app or don't start the hydration. Hydrate the entire app or don't make the page interactive. So the way the React team actually has solved this is, instead of having these steps for the entire app, they are actually now doing it for the parts of the applications. So which means that now it will try to fetch the data for the parts of the application, loading the parts of the application and hydrating and making the page interactive. All the steps will be for the parts of the application. So in turn, as a result, you'll be able to interact with the parts of the application and not wait for the entire app to be interactive. So let's see how that is solved. So yeah, streaming the HTML on the server. So the way it works is, now the HTML on the server, the response which you get from the server, that HTML is now streamed. So let's say you wrap this component with the suspense. The tweets component with the suspense, because that has the backend dependency, right? So let's wrap it with suspense. Now that means you are informing React that, hey, don't delay the HTML response from the server to the client because of the tweets component, because that is basically going to get the tweets later. So don't block the rendering or showing anything to the client due to that. So React will actually try to send a spinner until unless tweets are fetched, so that the rest of the HTML is streamed and it doesn't wait on this tweets component, which has a backend dependency. And so it will actually send this spinner until your tweets are fetched. As you can see, it is sending the spinner from the backend. So you will get the response from the server very fast, right? Because you are no longer waiting for the tweets to get fetched. And then when you have the tweets ready, what React will do is, once React knows that, hey, the tweets are now ready, I have gotten the tweets, React will actually send the content of the tweets in the same stream. And in addition to it, it will also send a script tag to the client, which basically tells the browser that where to place that content, which is just sent, where to place those tweets. So as you saw that there was a tweets spinner, that section, and that's where the spinner is actually rendering. So that section will be now replaced with the tweets content. So this script will be executed on the client, and that's how that spinner will get replaced with the content of the tweets. And so this is basically a huge improvement, because now you are actually not waiting for the entire data to be fetched at all, and whatever parts of your application are dependent on these API layers, you can actually wrap this with Suspense. But yeah, actually this actually assumes that your data fetching libraries are also working with React. So that is right now the assumption, but yeah, that might take some time. But yeah, eventually that's the goal, that all the data fetching libraries will be compatible with this solution, and so that React comes to know that okay, the tweets are now fetched and now it's the time to send the script tag to the client, and so that the client knows that okay, the script still needs to be executed and this content needs to be placed. Okay, so now let's look at the next. So with this, we actually solve this problem. You don't need to fetch everything before rendering anything. Now let's look at the next one. Wow, React lazy support on the server. So now it means that you can avoid loading the entire JavaScript, right? You can avoid loading the entire JavaScript because now it has the lazy support on the server. So the tweets component, which is actually coming from the server with the suspense, we can actually we can as well load it lazily, so it's not part of the main bundle. So your main bundle reduces to a great extent, and which actually helps a lot because you load the JavaScript faster and you're not blocking the loading of the JavaScript because of the tweets component. So with that, we actually solve the next problem also, that you don't need to load everything before you start the hydration. And the third one is selective hydration on the client. Now this is really interesting. Hydration will not start until your page is interactive, until your JavaScript is loaded for the entire app. But now with the selective hydration, it means that hydration will be starting as soon as the JavaScript is loaded for your app. For the parts of the app where the JavaScript is loaded, the hydration will be starting, right? So which means that you will be able to interact with the pages faster as well, with the parts of the app faster as well. And the interesting part is it doesn't block the browser. So it's not like React is busy hydrating, so you can't interact with the browser. No, it's not like that. In fact, it doesn't block the browser at all. And let's see how does it work. So it happens in small intervals and browser is able to handle those events. That's really great. This makes the parts of the pages interactable because user can actually start as hydration is happening in small intervals for the parts of the application. So user can actually interact with the parts of the application as well faster. And it also prioritizes the parts to be updated. So let's say you have a tweets component which is hydrating, and navbar is also hydrating at the same time, and you actually click on the tweets component at that time. So what happens is React will actually try to prioritize the hydration of the tweets component way faster than the navbar, so you can actually interact with it. It will also make sure that the click event which you just did, it will try to record the click event and respond back to you as soon as possible, so that you don't feel that lagginess when you are actually clicking on the tweets component. And that's pretty great. And also one more thing I would like to add is, let's say when the tweets component is hydrating, and let's say you click on the notifications tab. So in that case, React will actually stop the current process which was hydrating the tweets component, and it will respond. It will just take that click event which you did on the button, and it will respond to that, and then it will resume the hydration or it will come back to the hydration on the tweets component. So that's the way. It's basically that it's basically that once hydration started, it cannot be stopped. It's not like that. It's basically interruptible, and that's great. So yeah, so navbar and sidebar will start streaming and hydrating too, and the React is going to show spin until the tweets components are loaded, which is the end result. And it's awesome because this is going to improve the user experience to a great extent. Because just imagine that you have a web page and you are able to interact with the parts of the web page when the whole web page is not loaded, when the whole JavaScript is not loaded or not hydrated yet. So that's pretty amazing. That will really improve the user experience. So yeah, with this we actually solve the next problem as well, which is hydrate everything before making the page interactive. That's great. And to read more details about it, you can just visit the link which is given below. It has a lot more details to how it internally works. So if you're interested, please visit that link. And yeah, that's one of my favorite threads too in the working group. So now let's jump into the concurrent features. And the best part is that it's opt-in. So you can experiment with several parts of your application to try out the concurrent features. And yeah, I just googled about it when I heard about it, and yeah, that's where I just took the screenshot, and this is all what comes up when you search about concurrency. But yeah, obviously everything is not it's not under the concurrent features, but yeah, this is what it comes, and just took a screenshot of it for fun. So let's understand concurrency before we actually dive into the concurrent features, and let me introduce you to the characters who will help us in understanding concurrency better. So this is Sam, and this is Sam's wife, and they both have to attend a birthday party of Michael, who is Sam's best friend. So Sam's wife is just reaching out to Michael that, hey, where are you? We are getting late for the birthday party. And Sam is like, he's at office, and he's like, hey, I'm wrapping up my work and I'll leave in 10 minutes. And that's what we usually do when we are busy in something. We just say that, okay, I'll wrap it up and we'll leave in 10 minutes. At the same time, Michael tries to connect to Sam. So that's because he's getting late for the party. So now Sam now in this case, what do you think Sam can do? So let's look at the alternatives which Sam has. Sam has basically two alternatives, right? The first alternative is that he can just finish the conversation with his wife and keep Michael waiting till then unnecessarily. And the second one is that he can put his wife on hold, he can connect to Michael and resume the call again with his wife once he's done with Michael. So in the first one, what you are doing is basically you can't attend any other call until you are finishing the current call. So no matter how urgent the next call is, you won't be able to switch to that call unless you finish the current call. And in the next one, they have the flexibility is there that, okay, if you feel that, okay, the next call is urgent, the incoming call which is coming right now is urgent, you can switch to that call and then you can resume the current call later. And that's what is concurrency. Okay, so in simple words, concurrency means the tasks are interruptible. Now, that's what we learned in the last example. Now, let's have a look what happens when the concurrent features are not enabled or we are not using the concurrent features in your app. It's opt-in and disabled by default. Every update is treated as an urgent update. That's the behavior right now in React. So all the set states in your app are actually treated as an urgent update, and React will block the interaction until the rendering is complete or when the UI is actually updating. You cannot actually interact. So yeah, that's how it has been till now. But let's see what happens when you actually start using the concurrent features. You can tell React that which updates should be treated as less urgent. So now there is a way to communicate to React that these parts of the applications are less urgent. And actually, if you think that the urgent updates should be mostly like, typing, clicking, all the user interactions, that those are the updates which should be treated as an urgent updates. Otherwise, all the other updates like showing a list based on some user input, updating some part of the UI based on some interaction, those kind of things actually will be treated as less urgent, should be treated as less urgent updates, because those are not really so frequently needed to be updated. So yeah, those are the areas where we can actually try out the concurrent APIs in the application and see how it works. And updates will be interruptible. That's what we just learned, that wherever we are using concurrent features, those updates are interruptible. So whenever React will be processing some less urgent task using the concurrent APIs, and you just click on a button, then those updates will be actually interruptible, and it will respond to that click immediately, that interaction immediately. So yeah. It keeps the UI responsive during large updates. That's the best part, that you don't really need to worry about the responsiveness of the UI, because that's already taken care by React. Whenever you are using concurrent APIs and you have some large expensive operation going on, or some complex logic due to which you think that, okay, this might slow down my rendering and my UI might get impacted due to this, if you use concurrent features out there, React will be making sure that the UI is responsive for sure, and that's great. So does this remind you of anything which we just learned a little while ago? Okay, so selective hydration, streaming with selective hydration, where we just learned that, okay, hydrations are also interruptible. That also falls under the concurrent features, because whenever there is whenever React is trying to hydrate a component and you click on a button, then it will actually stop that hydration and respond to that button, respond to that button interaction. Or let's say there is some component whose JavaScript is loaded but hydration hasn't started yet, and you actually try to click on that component, then React will prioritize the hydration of that component immediately. So these things are basically falls under concurrency, because these things are interruptible, and based on user interaction also, it keeps the browser responsive as well. You will never feel like, okay, there is some hydration going on, so I can't actually interact with the UI. That's not going to happen. So that's what the concurrent features are. Amazing. Really excited to try this out. Okay, so let's have a look at transition, which is one of the concurrent APIs in React 18. And how does it help? This API helps us keeping UI responsive during expensive updates. Any parts of your app which you think are responsible for slow renders or have some acceleration, we can mark those parts of the app as transitions, so that the UI keeps responsive even when there is some update going on. It improves the user experience by marking the expensive updates as transitions. This helps because when you mark the parts of the app as transitions, some updates as transitions, so now depending on the type of device you are using, whether it's a slow or a fast device, React will decide how to render the UI and make sure that the UI is responsive. So in that way it actually is improving your user experience depending on the device. So yeah. And transitions are interrupted, of course, as discussed earlier, that's what concurrency is about, that your updates will be interruptible. So if it's actually updating some transition, making some changes on the transition, the updates which you have marked as transition, and you click on some button, then those transitions will be interrupted. And that's how the behavior should be, so that it does not lock up the browser. So yeah, that's supported out of the box by the concurrent API start transition. And it also gives you a visual feedback while the transition is in progress, because it tells basically give you a way to provide feedback to the user that, hey, this part is still in transition, so please wait for it till it loads. So yeah. And so yeah, in this case, as you can see, we have an input value and we have a search results. So basically you have an input field where the user can type in the value, and you show some suggestion of countries, basically auto suggestion of countries based on that typed value. Well, by default, both of these will be treated as an urgent update and will block the rendering, and will try to update whenever there is some change. It will actually try to update the states and will block the rendering, so user cannot interact at that time. So yeah, but if you see the second one, the first one is of course an urgent update, because as soon as you type, you need to see the value. The value should be updated in that input field, otherwise it will be a terrible experience for the user. But the second one, the search results, this is actually not as urgent as the first one. It's actually not at all urgent. So if that takes some time to load, that result, the list takes some time to get updated, that's totally fine. And in fact, we use techniques like set timeout, debounce to achieve this, so that these kind of operations don't take place often, and it takes at a regular interval or some interval, so as to optimize the rendering. So now what we can do is we don't really need those kind of set timeout or debounce techniques at all. Instead, we can actually use the concurrent APIs to achieve the same. So yeah, you have when you have a use transition, you get a pending state and the start transition function. So now what happens is that you mark the search results inside the start transition, you pass that into the start transition, and whatever function you are passing in the start transition will be, those updates inside that function will be actually marked as a transition. So and you also get a pending state here, so until unless your transition is complete, a spinner will be shown. so to the feedback. So that's really great, right? So now let's see that and of course, as we are discussing, that we should actually stop using the set timeout or demouse like techniques. We should not do that anymore. So let's see what is really the difference, because right now it might feel like, okay, it's like how is it really helping us? So how is it different from using a demouse or a set timeout? So let's look at differences between the two. Set timeout versus start transition. So yeah, set timeout is executed after some delay. Because it runs in a different event loop, you have some delay. Always you have some delay when that code inside the set timeout executes. Start transition, where it's executed immediately, which means it's synchronous. It's not asynchronous like set timeout, which actually helps a lot. Set timeout obviously will block the UI. You can't really interact with the UI when set timeout code is executing. But start transition will always ensure that the UI is responsive. In fact, all the concurrent APIs will ensure that the UI is always responsive. That is the main criteria of the concurrent features. And set timeout delays the update. So showing the placeholder or showing a spinner kind of a thing until your update is done, you would have to maintain some is loading state, and that will be like an asynchronous code, right? So but in the start transition you already get a pending state because React tracks it for you, so you really don't need to maintain any asynchronous code for that, and that's really great. So yeah, these are the differences between the two, and we should actually stop using set timeout and try out these new APIs when the version is out, when we try out the React 18 version. We actually went through a lot of new things in React, but yeah, a little more of time I'll take, and then I'll promise to wrap it up. Okay, so let's have a look at the next API, which is use deferred value, which is also coming in the concurrent features. So this API helps in deferring the updates. So let's say you have a component which is dependent on some state. Let's say you have a component which is dependent on some state which is responsible for updating the user input. So when you type in that input and the value gets updated, now this component doesn't want to get updated as soon as the state for that input field gets updated, because it has some expensive logic inside it, and if it keeps on updating so frequently, your browser will just freeze. So in that case, what you can do is you can use this API, use deferred value, and what it will do is it will return a deferred version of that state, and you will use the deferred version in that component. And in turn, it will actually defer the updates of that in that component due to this state. So that way, you will be seeing an older version of that state in this component, even though that state is updated in reality, because as soon as you're typing in, the state gets updated immediately. But in that component, when you see the value of that state, it will defer by some time. So that's how it will work. And since it falls under concurrent features, so it will make sure the browser is responsive, and all the things which we get using concurrent features that we will be anyways getting here. So let's take a look at an example so make the understanding more better. Yeah. Let's say you have a username, which is an input field where you type in your username, and of course it gets updated as soon as you type in. And you have a list which is dependent on the username. So this list basically shows you some data based on this username, and it has some artificial delay added to it, and that's why the name is delayed list. So it has some artificial delay added to it, which basically blocks the main thread. So just imagine if this list gets updated on every keystroke, because when you're typing, if this list gets updated on every keystroke, and it has some logic blocking the main thread, your browser is just going to get locked after a point of time. So that's not what you will want. So this is a good use case for use deferred value. We can actually start showing the older version of the username in that delayed list, so that it doesn't get updated immediately. The updates due to that updating username are basically deferred in the delayed list component. So let's see how can we do that? So yeah, this is how the API looks, and this is how you use it. You basically pass that state into user deferred value, and that value you basically pass in the delayed list. So now the delayed list will be deferred due to this API, and the browser will be responsive even though you have this blocking main thread task into it. The browser will just be responsive, so user experience is going to be smooth, and it will show the older value. So it's not going to show any spinner or something. Instead, it is going to show an older value. So to you, instead of until unless the updates are actually applied to this component. The demo, yes. So I have a input box here where I'm going to type, and as mentioned that there is a delayed list where there is some logic. I'll just tell that what I have done there. It's basically introducing some artificial delay out there. With this loop, just introduce an artificial delay so that just to lock the main thread, and based on that username, we just render the items. So yeah, this is what happens. And now let me just show how it happens if we don't use deferred value. That's what we are going to do. Hello, I am here. Now you see I'm still typing, right? But it's not getting updated because the screen is locked with using the use deferred value. Let me just update it here. And deferred username, and now let's try to update it again. Yeah, now let's hello, I am Akansha Doshi up, and just let me just keep on typing just like that. Now you see value doesn't get updated immediately. It takes some time to get updated, but it's not blocking the browser at all. Like I just can type seamlessly, right? That's amazing, isn't it? So yeah, now back to the slides, and yeah, we actually covered so much of it, isn't it? Like we covered all the highlights of React 18, and now what the next step? What is the next step? You don't want to try out this React version after listening to all this. If you are interested in trying out the React 18 version, then it's actually very, as I mentioned, the adoption strategy is going, so you don't really have to migrate the version, right? So yeah, you can just alpha versions of React and React to client. You just need to update the API line change. You just create root API instead of your render, so that you get the out of box improvements like automatic batching, selective hydration, and everything. And the next thing is on the server, you need to actually use the render to pipeable string instead of render to string. But yeah, you can, for more details, you can actually check out the migration guide on the server, the working group, and that will be very helpful for you to migrate on the server side. Okay, so we covered the adoption strategy as well. So what are the next steps? Well, you should try out the alpha release for sure, and major highlights, but there is a lot more things which are coming in before the React 18 release. There is a lot more new APIs which are coming in. So yeah, like you should check out the discussions if you haven't yet. And of course, the React Conf is coming on December 8th. So make sure you don't miss it. You should definitely check it out, and you'll get a lot more details in that. Okay, time for the shoutouts then. I would want to give shoutouts to a few people who have played a very important role in making this happen. So yeah, let's go for it. First of all, I'm really grateful to Manjula for reaching out to me for giving a talk on React 18. Honestly, I had never imagined that I would give a talk at React India. So thanks a lot, Manjula, for giving this amazing platform, and a huge shout out to the whole React India team for organizing this event. I am really glad to be part of this awesome event. Next, I would like to thank Ricky and Dan from the React Core team for the continuous support and guidance. And thank you so much for taking out your time in reviewing the content. Last but not the least, I would like to thank my friend Ishan, who helped me a lot in designing the slides. So yeah, thank you, Ishan. Thank you each and every one of you out there for tuning in on a Friday morning and giving your time here. So thank you so much. It means a lot to me. And please feel free to connect with me and do share your feedback. I will be really looking forward to it. So I guess it's done then. Have a great day ahead. There are a lot of exciting talks happening and I'm really looking forward to it. Have a great day. Thank you. Bye. See you.
Thank you, Akansha. This was such a lovely talk. It covered so many different things that I had lots of doubts about. And I think the people loved your talk. And thanks again for such a detailed and lovely talk. For all the viewers who have still questions about suspense, lazy, and concurrent behavior, please go to the lounge where Akansha will be there answering all of your questions. So please do not forget to go to the lounge. And if you have time, please check on the sponsors booth as well, where a lot of sponsors have come and they are all hiring. So please go crazy there. And we will see you in the next session. So our next talk is Temporal for React, Temporal React for the backend. And this speaker needs no introduction at all. Introducing him would be as useful as having a lifeguard at a professional swimming championship. I'm talking about none other than Sean Wang. Please put your hands together for Swix. He has given blockbuster talks on React and Svelte. He is not only a GitHub star, but one in real life too. And his live coding skills are of no match, where he could build from scratch React or hooks. And if you thought this was enough, he has also written a fantastic book, the Coding Career Handbook, which I can't recommend enough. So please give it up for Sean at Swix.
React and
Hello, Sean.
Hey, can you hear me? Hello?
Hello, Sean.
Yes, can you hear me?
I can hear you.
Awesome. How's it going?
It's good. I think it's time for you to go live.
Okay. Do I just share my stuff, my screen?
Yes.
Okay. Sorry for the wait.
No worries.
All right. I'm going to share my screen, and okay, just let me know if you can't see or I am doing something wrong. Just let me know because I am flying blind right now. Do I start? Ankit, are you there? Looks like you are. Okay. All right. Sounds like people are okay. I'm looking at the chat. Am I audible now? Okay, Yogesh. Hopefully that is better. Yogesh, anyone? Yes? Yeah. All right. Awesome. Screen is visible and audio too. Thank you so much. And I won't look at the chat all the time, but I'll check in. But hi, everyone from Seattle in the US. It is 8 p.m. my time, and we'll get going because I have a lot to go through with you. So I'm promising to show you React for the backend. And what does that even mean? Because React is a front-end library. This is actually the result of a blog post and also how I found my way towards the company that I currently work at. So really excited to be here at React India and to be invited to share this with you. So the inspiration for this talk comes from Guillermo Rauch, the creator of Next.js. It says Temporal IO does to the backend and infra what React did to the front end. It was the first to point this out. And I'm very annoyed because I wish I saw it sooner. Some important caveats is that we're only currently going into beta and will only be generally available in 2022. And that React for the backend is an analogy, not a design goal. So there will be differences, okay? And it's just an interesting inspiration for me. So the way I'm gonna start this off is with crabs. Everything evolves into crabs. If you look at all these crabs, they all kind of look the same, but apparently they have different origins. And there's a scientific term for it called carcinization, where independent creatures, because of all the shaping evolutionary pressures, actually all evolve the same shape because they're solving the same problems. And I think that's a very interesting analogy for React and Temporal and a lot of other complicated operating systems that subsume a lot of complexity for you. So I really like these memes. Convergent evolution is not uncommon, especially when species have similar selecting pressures in their environments. Wired, everything is crab. And I think that everything is crab is kind of the everything is React type of view. Especially when you've learned React, you start seeing it in a lot of other systems. So I'm going to explain the story through the lens of 3 major companies, Uber, YouTube, and Amazon. And in particular, I'm going to go in progressive ideas of components, architecture, and time. So I'll tell you a little bit about each of these as we proceed. So part 1 is going to be components. So I really am entertained, especially those of you watching live and later on on YouTube. I'm really entertained by this idea of having like a full stack clone. You see these like clickbait thumbnails where you'll see like a 4-hour tutorial on how to clone Uber. It's typically how to clone Uber's front end, and they don't really do the back end part. But if you think about the most important and valuable part of Uber, it's searching for places, pricing, it's matching, it's pickup, it's drop off, it's rating, tipping, payment, and email. And that's the same user journey throughout the whole thing. And that may last minutes to hours and hopefully not days. So a naive implementation would have each of these, like let's say each of these are managed by different teams. A naive implementation would have system A talking to system B, talking to system C. The problem being that each of these, every time you make an API call, your chance of failure and losing someone along the way is exponentially increasing, right? Because you just multiply your SLAs. And on top of that, that's just the happy path. What about all the changes that can be made along the way? What about the new user innovations? What about all the refunds that you might need to make? So that's a very complex system already as you build it up. And you imagine spreading that out over tens of thousands of engineers. That can be a very interesting system to build. So typically, whenever these clones are made, they're kind of like half-drawn horses. Like they're very well drawn on one side and like kind of half-drawn on the other side. Actually, because these things tend to be front-end. I'm getting a request to maximize my screen. I'm not sure why someone says that is. I'm guessing. I'm gonna pause here. Does anyone who's like the tech side? I noticed this too on my own screen. Like I'm in some kind of like vertical box. I'm good. Okay. Yeah. Okay. So in practice, these companies, including Uber, actually have a giant hairball of services, and it's very complex, and there's not much organization to that. And I think it's an interesting way to think about this when you really think about how we used to organize our front ends, right? In the jQuery era, we used to organize like just kind of randomly, like event handler here, change handler here. And it was just kind of all over the place and not much of a framework to organize things. And it only took React to really well define and popularize the component idea. And I think that could be an interesting analogy to apply to the backend, especially when I see this. In particular, the three main lessons I learned from React is that you have a component and rendering separation. So the component is authored by the developer and the render is authored by a core team. Correctness is ensured by functional programming or virtual DOM, and a view is your function of state. And programming model, you want some kind of simplicity and familiarity where you say it's just JavaScript. So that's a very interesting idea. The other thing I always point people to is that this is an not very well known repo called React Basic. It's actually on the React.js organization on GitHub, where the React team, Seb, who's the tech lead of React, actually lays down how he looks at React without the trappings of React. And I think if you're very interested in learning the principles behind React, you should be all over this page, as well as Dan Ibramov's PR to this page. Okay, so but let me summarize it for you because I have my own perspectives. What React did for front-end programming was it introduced all these things: deterministic renders, local state, reducing boilerplate, composition, side effects, all this so far. And it's really shown, right? Like if you look at the last 5 years, it's just really outpaced the development and popularity of all the other frameworks, including, by the way, things that they think are non-core. So the React DevTools from Brian Vaughan actually has over 2 million users, which is insane. It's not part of the core code, but it absolutely helps in React development, which I think people don't give enough appreciation for. So everyone shout out Brian Vaughan for making amazing DevTools. I have 3 other talks that you can check out. So I'm not going to go into details on what React did and my thinking on React. So I did talks in 2018, 19, and 20 on different aspects of React. So you can check them out on my YouTube. The second story I'm going to tell is about architecture. So the first story was about components. Second story is about architecture. Let's go into that. Let's build YouTube on YouTube. I guess most of you are watching this on YouTube. So again, there are tutorials. I actually searched like how do you live stream, how do you build YouTube? It's pretty funny. And you watch them and you come away kind of a little bit unsatisfied. There's an upload process and analyze. Actually, so there are some YouTubers who worked at Google who actually interviewed YouTubers and asked them how it worked. So there's the process. You upload, you analyze the video, you split it up, you process chunks in parallel. That's an interesting one. Stitch it back, notify subscribers, and then you have captions and so on and so forth. And there's a lot of processing in each of these steps. It's actually a very interesting and complicated distributed systems problem. And then you have to implement all these other, sorry, I have all these, then you have to implement all these other interesting features, YouTube Premiere recommendation algorithm, and then you have to scale it for 30,000 videos, 30,000 hours of video uploaded per hour. So that's a lot of scale to process. This is a very interesting problem actually with one of the customers that I interviewed, Descript, which is actually a startup that I use to process my audio for my podcast. What they do is actually a very similar process. Every media encoding process is very similar. You have some source video, you transcode and split it up into multiple sources, and then you may have to stitch it back up again together. And a lot of this is actually done with a very patchy process of like queues and Redis caches and some persistence in MySQL for state, and then something patchy. It's very hard to test and it's very hard to migrate. And especially when there's some production incident, like it's very hard to debug as well. My favorite quote about this is that distributed systems turn every outage into a murder mystery problem, where sometimes you're both the victim and the murderer. So I really love that logic over there. And I think this is basically us as programmers rediscovering the 8 fallacies of distributed computing again and again. Particularly number one, whether that we assume that the network is reliable because it works on my machine. Why should it not be reliable? And I think that's just where you start to realize that every single system that you ever want to produce in production, from now and forever to the end of your time, you will always want to do retries and timeouts, right? You always want to put it in front of, you want to persist it. You want to say, if it fails, you want to retry again. You want to have exponential backup so you don't DDoS yourself accidentally. And you want to put it on a queue. So, for example, you can buffer between like high peaks and versus the available resources on your system. So it's a very, very interesting idea. Even in a serverless environment where I used to work at AWS, we would be recommending structures like this, especially for dead letter queues. So what I showed you here was only for the happy case, and this is don't forget to handle the unhappy cases. And AWS recommends spinning up a second SQS queue. The problem is that this is for a simple, A to B direction, and in a production system, it looks more like this, which is a real life system, and it starts to get really unmanageable because it's hard to reason about the complexity, and it starts to explode every single time you have more systems interacting with each other, right? And then think about testing this. You can't. You have to test in production. Okay, so how do we solve this? I kind of gave away the answer here. You centralize your state. You centralize your application state, and you have a single system that tracks it. Essentially, you turn the distributed system back into a monolith, and you distribute the individual parts of the work that needs to be done. So that's what we call choreography versus orchestration. If you want more resources on this idea, you can check theburningmonk.com, which is one of the best blog posts I've ever seen about it. But this is a general idea. I don't claim any expertise in this thing. I discovered this and I realized, hey, doesn't this look like components to you? Doesn't this look like a central renderer? Doesn't this look like a random hairball or jQuery? That looks pretty interesting, right? Okay. That's the other thing I want to talk about is also like controlling things with code, right? Like, so here in this hairball, it's very hard for you to understand like what is the overall experience that I'm trying to offer. But over here, if I want to say like, okay, if I want from start to finish, I want you to time out within 20 seconds. I want to set it declaratively as part of my code, as well as I want to set my retry policies. For example, if I want to set like you only try once, I'll give you 20 seconds maximum. And once you try it once and you don't succeed, you can fail and take some other path, right? Or you can say, I'm going to retry up to maximum of 5 times, and I want to have a linear retry, no exponential back off. I can do that too. So you want some kind of declarative model to impose on time and reliability. So I think that's something that's really interesting as a design goal that you cannot really get if you piece things together haphazardly. Okay, so here's the ultimate comparison. This is the simplest I can make it. If you want no framework in vanilla, you have, if you want no framework on the front end, it's vanilla.js or choreography on the back end. If you want a framework, it's React on the front end and orchestration on the back end. So you want some kind of orchestration as well. All right, last section is time. I'm actually doing pretty good on time, it looks like. So this is where we get to my part, and this is where I'm presenting Temporal in relation to React. Temporal is the open source microservice orchestration platform for writing long-running workflows as code. Why I care about microservice orchestration, that's just because that's the term of the day, but I don't really care whether it's micro, macro, nano, medium, I don't care. It could be serverless functions, it could be a giant monolith. At the end of the day, if you're crossing service boundaries and if you're calling separate APIs with any chance of failure that has any chance and that has a life beyond just a simple request response, you're going to need some kind of orchestration platform. So it's in use by a bunch of people from Coinbase to Snapchat, Descript, Checker, HashiCorp, and I just had Netflix and Stripe actually present in a recent community meetup. So pretty happy about that. As an open source project, it's got quite a lot of success, and I think the company that's trying to maintain and support and host that should hopefully do pretty well as well. There are 3 parts, 3 products to what the project is offering. It offers an open source server. It offers a dev tool for you to inspect the server state, and then it offers SDKs that are idiomatic. And I think that the main thing that I want to really pitch actually is here. So the elevator pitch is that the most valuable mission critical workloads in any software company, think Uber, think YouTube, think Checker, think Netflix, whatever, are long running and tie together multiple services. Because this work relies on unreliable networks, you want to standardize timeouts and retries, which you just saw, and you want to offer reliability on Rails. Second, because this work is so important, you must never drop it. You must log all progress so that you can resume if you ever go down again. Third, because this work is so complex, you want to model it with business logic. You want to model business logic with general purpose languages, and then you want to reuse, test, version, and migrate. So these are, notice that I'm not prescribing any solution. These are just design goals. If you feel like you want this for your system, you should start thinking about how to provide it for your engineers and your team. Okay, so the programming model, these are all like the workflow systems out there. Temporal is not the first and probably won't be the last. But you see something that's very interesting among all of them. That's a stark difference, and this is actually one from one of the big clouds, the big three, where this is actually how you write workflows with them, and this is kind of how you write workflows with us, and this is what we call workflows as code, in the sense that you should use just idiomatic programming languages. Otherwise, you're going to end up writing an abstract syntax tree inside of your JSON, and that will require you to reinvent the entire universe of syntax tiling, testing, libraries, everything, because you refuse to use a general purpose programming language. Okay, so what does a workflow look like? Workflow is just a function. So just like in React, a React component is just a function, and workflow is just that as well. And then you can call it from outside, from something embedded inside of your app. I'll try to show you that to you later on. So I can say, if I want to say hello world, I can say workflow.start world, and I'll give that as an argument, and I'll return hello world. So that's a very simple workflow. An activity is how you interact with the outside world. Here in Temporal, we insist on a clean separation of state management versus your external side effects. So you can think about it as an effect or event handler from React. So here we're going to charge an API, and from the workflow we're going to call that charge API effect or event handler. And this is just run in a regular Node.js environment. Okay, so and finally we have to host it somewhere. We have to host it on some scalable worker service. And so I'm going to register my workflows and my activities and have those things running. So I think I may want to do a little demo here. So if you want to check it out, actually, I think you can go to temporal.io/ts. And I think there's a Git pod thing that you can spin up and you can follow along. So here I'm going to show, I think, what is going to be hopefully my, I have to make this. I was playing around with something else earlier, so give me a little bit of live coding going on. Okay, no, I need to show 8088. There we go. Okay, so all right, I'm ready here. So here I have a little script. Let me see if I can. Oops. Let's see. VS Code, don't fail me now. Okay. Okay, all right. And so here I have a little script, and I'm just basically mocking an API call, and I'm calling an example, and I just have a immediately invoking function here. So let's just see how this works. I'm going to call it. So I think it's yarn ts node source activities ts. And it's just going to invoke and call this function. Nothing special. I'm just showing you how I mock an API, right? The problem comes when, for example, I have .random more than 0 error. Okay, so I'll run this and hopefully it'll error, or maybe I'll get unlucky and it will just always succeed. Oh, see, so sometimes it errors, and when it errors, I want it to retry. It's very common, by the way, to only code for the happy path and forget to handle the error, right? So then you have to put some try catch over here, blah, 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 a lot of work, right? What if you did not have to do that? And what if you had a declarative error policy? Right, so I'm just going to export this function, and I'm going to drop out into the temporal environment that I've been working under anyway. So I'm going to orient you a little bit to the hello world example that we have when you start up with us. So it is going to be, you saw an activity. An activity is just a function that operates in Node.js. And workflow is a simple. Here's simple workflow. I'm calling that activity, and here I can set that retry function. I think I'm going to do that. I'm going to say let's say back off coefficient of 1, something like that. All right. And then it's going to be registered in a worker. So I'm going to start spinning up that worker, and then we're going to see how that activity starts up. So yarn start watch. Okay, and then here I'm going to say, man, this is live coding remotely. I think this is really funny. Okay, yes. I think I need to do some live debugging. There we go. Sorry. Activities. I changed this last minute, so this might be tricky right now. Okay. I think I don't want to risk this because I feel like I didn't test this well enough for you to. Okay, I wanted to show you that this thing could run, but yeah, I changed this last minute, so I think I shot myself in the foot over there. But we can live debug in the Q&A after this session, so that I don't waste your time. Still, I can actually explain quite a bit without that anyway. Don't worry about that. I'll go fix it later. Okay. I'll just pretend I showed you some working code. And anyway, the hello world will be fine. You just click it. Okay. So, but then you can start to do some interesting things because I control all the retries and timeouts, and I persist every single state, and I set timers to wake it up again. So why don't I expose that timer API to you? So I can just say, for example, let's say I want to do installment plans. I can charge your card once. I can sleep for 30 days. I can sleep this function for 30 days. It doesn't tie up my resources because I sleep and then I wake up again and I carry on and I charge it again, right? If I want to make a subscription, I can just go and say while true and just loop infinitely until I can actually until I cancel that subscription, right? I can cancel from the outside. So this is a really fascinating thing to do anything long running because I can just basically scale this infinitely. And while I want to do subscriptions, why don't I want to send information in? Sure, I can do that. I have an API called signals where I can define a signal and saying like, okay, this is when I get new information, I can update the amounts that I'm charging, and on the next billing cycle, I can start charging that new amount again. So it's a very interesting. This is where, by the way, it starts to differ a little bit from Temporal, from React, because React doesn't have any concept of signaling into a component. It just has an idea of context. And there are libraries like MobX that might actually help you horizontally insert state, but we are not going to go there. Okay, so again, just to recap on the 3 axes that we care about, React has a components plus renderer separation. Temporal has a workflows plus orchestrator separation. In terms of correctness, we have functional DOM and event sourcing, which I think I'm going to try and show you later on. Programming model, we have just JavaScript versus workflow as code. Like we want to not use JSON YAML as syntax. Okay, finally, the part that I was trying to build up towards was how are you going to write one-click buy? And I think the Amazon one-click buy button was worth billions to Amazon. And I really was inspired by this from Joel Spolsky, who actually talked about the one-click buy idea. Joel Spolsky is the founder of Stack Overflow. And when Jeff Bezos wanted to implement one-click buy, the big unlock was actually that you have to accept purchases right away, but hold it somewhere in the backend and set a timer for them to change their mind. And when they change their mind, you can sort of to cancel, or if nothing, because there's a lot of people who put things in the shopping cart online and then they walk away. It's a very interesting behavior. I know because I do it myself. And that's because you're not really sure and you're just kind of like putting it there as like some sort of bookmark. So one-click buy actually helps people get over that hump of spending their money. So again, I'm going to try valiantly to do that tutorial, to do that demo. The reason I'm more confident in this one is because I don't actually have to change any code, and I didn't change any code. So let me change back to this one. I'm bravely trying to do this this live demo. Okay, so basically I'll show you that demo and then I'll try to show you the working code behind it. And this is inside of Next.js application, so you know it's full stack. So again, just clicking buy now, it's gonna pop up with that timer. And once that timer expires, it's gonna convert to a purchased flow, right? And that's the kind of experience that we want in a one-click buy purchase. The problem is you can do this easily in the front end with a set timeout, but obviously if I just click buy and I close the tab, then that will go away, right? Ideally, you actually want the durable timer to be so persistent in your backend that you can click purchase in one side, in one machine, go to a different machine, fire it up again, and then click cancel, right? And it should work. So that means you have to implement the one-click buy on the back end, right? And obviously, if you buy, I can cancel it as well, right? So that's the idea. So here, let's actually have a look at the code that goes behind it. And by the way, this is on the demos. I need to get out of the Zen mode. There we go. Let's look at the code. So it's in the Next.js repo. Okay, so for those who are familiar with Next.js, you have pages with API routes, right? So here I have a few API routes. I have the start by API route, where the only thing I do is basically I receive that buy information and I say, all right, I'm going to start the one-click buy workflow, right? And the one-click buy workflow is just going to have the item ID. Obviously, you can send in more information if you want. That one-click buy workflow is going to be right in here, where I'm going to say, for example, I'm going to kick out that buy, and I'm going to start that condition, and I'll say like if the purchase has been canceled, I'm going to go ahead and cancel that purchase, or if it exceeds a 5-second timeout, I'm going to go ahead and check it out, right? Check out the item and actually go through with the purchase. And I'm setting up signals and queries so I can send data in to cancel it or to query the state of whether I've canceled it or not, right? So those are all quality of life decisions. And ultimately, when I send cancel, I can just signal the workflow externally as it's sort of long running. So this example happens to take 5 seconds for demo purposes, but you could equally take 5 days. The default timeout for workflow is 10 years because we really do not care how long it takes. That's how confident you have to be in your systems. Okay, and that's the demo. I'm so confident because I don't have to code in front of a live audience. It's fantastic. So I just want to recap the thing that we covered for you. We covered 3 stories of three companies, Uber, YouTube, and Amazon, when we learn things about how to organize our code with components and on a large scale, how to organize our systems. And then finally, the importance of dealing with time. So again, and they all have to do with React, right? They all have like take a similar form with like the crab analogy. There is more that I could not fit into this talk, and I would love to go into detail with you in the Q&A in terms of like, there's analogies across all the different little benefits and design decisions of React that have reflected APIs in Temporal, and I would love to share that with you. And also, I think that ultimately the thing I want to conclude with you for anyone looking to build developer tools and design systems for increasing productivity, you want to let people who aren't X do X, right? Webflow lets non-coders do make websites. Canva lets non-designers do graphic design. Netlify lets front-end dev do DevOps, and Temporal is helping backend devs do distributed systems. And I think it's a very interesting analogy, and I am looking for other ideas, other companies, other frameworks or projects that let non-X do X. I think that's a very interesting idea. Okay, so I'm going to leave it there. I think I finished within the 30-minute window with 2 live demos, one of which did not work, but I'm going to retry again until I succeed, and that's very much the message of today. Thank you very much, React India. I'll see you on the Q&A or Twitter. Who's the MC? Let's see, Manjula, Akit. Thanks, everyone. Wow, even with a failed demo, people are still very nice. Don't change your code before you give a talk. Ankit, I think you're muted. I'm not sure if I can hear you.
React India.
Go to the Q&A, but Ankit, I really think they cannot hear you.
to the lounge area, and there would be a table name of your name on the table.
React India. React India.
Next up is cracking the concurrent mode with Sudhanshu Yadav. Sudhanshu is no stranger to us all. He has single-handedly written a React-like library that does not depend on virtual DOM at all. You all should check out that code after his talk. So today, Sudhanshu will be teaching us all about concurrency. How do we do it in our applications? This will go perfectly well with the first talk that you all saw. About Sudhanshu, he runs a YouTube channel, Internals, which deep dives onto the tech mysteries which remain elusive generally. So let's welcome Sudhanshu Yadav.
Hello, React India. I'm very excited to be here. Today, I'll be talking on internals of concurrent mode. More on my mental model to date by implementing all the concurrent features for Brahmos. To give more context about Brahmos, I built a React-like library as a side project which support all the React APIs, including the new concurrent APIs which will be coming. On outside, they look exactly same, but they have a different trending pattern inside. And Brahmos kind of uses its own version of fiber architecture. In this talk, we will not go through much on the concurrent feature APIs, but more on what enables concurrent mode and what are the complexities behind providing those declarative APIs. By the way, there will be no concurrent mode coming in React even. It will be more of a incremental concurrent features, but once you are fully utilizing concurrent features, your application will be in kind of in concurrent mode. Work at Prophecy as a front-end architect to check them on my GitHub profile. I'm also an internal fanatic, and I love discussing the internals of the lab. Hello React India, I'm very excited to be here. Today I'll be talking on internals of concurrent mode, more on my mental model toward it by implementing all the concurrent features for Brahmos. To give more context about Brahmos, I built which support all the React APIs, including the new concurrent APIs which will be coming. On outside, they look exactly same, but they have a different rendering pattern inside. And Brahmos kind of uses its own version of a fiber architecture. In this talk, we will not go through much on the concurrent feature APIs, but more on what enables concurrent mode and what are the complexities behind providing those declarative API. By the way, there will be no concurrent mode coming in React 8.1. It will be more of a incremental concurrent features, but once you are fully utilizing concurrent features, your application will be in kind of a in concurrent mode. About me, I'm Sudhansu. I work at Prophecy as a front-end architect. I have authored a couple of OSS tools. You probably like to check them on my GitHub profile. I'm also an internal fanatic, and I love discussing the internals of the library I use. I like making theories around it. You can follow me on Twitter, and you can definitely check out my projects on my GitHub. So let's first try to understand why we need concurrent mode, what it means for a React application, actually in any application in general. So the first important reason why concurrent mode is there is to provide better perceived experience. Now, most of the libraries, the rendering libraries, try to make their rendering engine fast. And while that should be the top priority, but it's not enough always. If those performance improvements are not noticeable by user, does it make any difference? If user can't pursue your application to be fast, no matter how fast your application, like a rendering library is, it doesn't matter. So React basically concurrent feature tries to give the declaratives API to write app with a better perceived experience. Now, the current patterns available for writing application, like writing application with a better perceived experience, the problem with those patterns is they have a good context on the application, but they don't have a complete control on the rendering library, because the rendering part is being abstracted by the library itself, so you don't do the DOM manipulation manually, right? And because of that, the lot of heuristic or choices we make doesn't hold true for all the use cases. For some different network connection, for different resource available, it might be fast. For some, it would be not that accurate. And concurrent features, more specifically fiber architecture, which is the core of concurrent features, it tries to utilize all the resource available effectively. It allows patterns like suspending, interrupting the render, deferred rendering, partial hydration, and all of this without making the current view inconsistent and keeping the whole view responsive. And because it gives capability of a background rendering, it involves asynchronicity, and whenever there is asynchronicity involved on rendering something, it involves a lot of complexities like race conditions, merging state, rendering sequence, etc. And it's very hard to orchestrate your rendering with all of those corner cases. Concurrent feature hide all those complexities inside the library and provide declarative APIs like suspense, suspense list, transitions, use deferred hook, and basically you can give a hint to provide a rendering sequence, and library will internally take care of all the corner cases. So definitely concurrent feature opens up a lot of door for better pursuit experience. But let's understand what enables concurrent features. So the first one is a time slicing, basically the fiber architecture. To understand this, let's take an example of a small React application, and here you can consider each of this node as a component, and though it is a small, let's consider that each of this component takes some amount of time to render. Now, how generally it will work is basically like, let's say whenever you do a set state on a component, it will trigger re-render of that component, and then that component will trigger re-render of its children, and it will its children will again call the re-render of its children. So it will happen at one go in a synchronous way. And once you know what all changes are there, you commit those changes to the actual DOM. Now let's try to visualize it on the frame timeline. So you have heard of maintaining 60 FPS, and what it means is basically like you have 16 millisecond between two frames, and not even 16 millisecond. It depends on what browser is doing at a time, and so it can be less than that as well. And in that limited time, you have to do multiple things. The browser has to do multiple things, and because JavaScript is a single-threaded language, all the things need to happen on one thread. And there are a lot of different type of tasks. You have a JavaScript task, which is here would be rendering that component, and you have a browser task which handles layouting, the painting, controlling, like giving the feed, taking, basically listening to the input of a user. So all of this need to happen on one thread. Now, if your JavaScript task is big and it is spanning across multiple frames, what will happen if a browser task comes in between? It has to wait until your JavaScript task is done. This will create like a experience, bad experience of basically you'll see some frame drops, some janky behavior where like you type something and it is coming after some millisecond. So to solve this, what time slashing does is basically like you have this big chunk of work. Instead of this big work, break them into a smaller units of work. And with this, whenever there is like a browser task in between, they can easily fit between those smaller unit of works. Now let's try to visualize it on again on our component tree. So you made a state change, you did a state change on a component. Now consider this dots as a unit of work, and this unit of work internal will be calling the component render and also doing some bookkeeping. In React terms, it's a fiber, basically unit of work. So you process a unit of work and then you check that whether you need to yield to browser. If no, then you process process the next unit of fiber. You keep checking that whether you need to yield to browser, and until you have a till you have a time, you will keep processing your units. As soon as you have to yield to the browser, you will stop processing your unit of work and give the control, basically like a schedule your next fiber, next unit of work, and give the control back to the browser, and let browser do their own stuff. Once browser is done, come back to the scheduled work and process your units, and keep doing that until everything is every unit of work is finished. With this, what capability we are getting is basically like we can interrupt our rendering now. Instead of like a big task, we have sliced it into a smaller task, and a browser task can fit in between. And with this, once like you know all the changes, you commit all the changes to in the commit phase. And if you see this is basically turning your synchronous rendering into async rendering. Basically like now it will finish after some time. You don't know when exactly the whole rendering and commit thing will get finished. So that create a problem, basically like because it can be interrupted, and another task can happen in the same time. So things can go out of consistent, like things can become inconsistent. To solve that, we have a background rendering. So now to understand that, let's consider we have the same React application, and you make a set state on the top level component. Now instead of making the changes on this tree, let's call it as a current tree. And current tree is basically the representation of your actual DOM. It maps one-to-one to your actual DOM. So instead of making changes on your current tree, you create a new tree called work in progress tree. And this is a tree where you will be making all the changes. So how it will happen is basically like you will clone the fiber from the unit of work from current tree to work in progress tree. If there is any pending update, you will process that fiber, basically call the render method of it, and then whatever the rendered children are there, you will compare it with the existing children on the current tree. If it matches, you will clone the fiber from the current tree to work in progress tree. If it doesn't matches, you create a new fiber. And then you will process the next fiber. You will keep doing that until like all fibers are processed, and you get a new state. And till this point, you can see like your current tree remain consistent with the what is shown to the browser. Even though rendering is happening, your current tree is not impacted by that. So basically everything you are trying to do on work in progress tree. And in work in progress tree, once all these changes are done, like once the render cycle is done, once you know what all changes are there, you commit those changes to the actual DOM. Now, once committing those changes to the actual DOM, now work in progress tree is the more accurate representation of the actual DOM. It has one-to-one mapping to the actual DOM, and your current tree has become stale. So what we do is basically swap the current to work in progress tree, and swap current and work in progress tree, and we keep the previous current tree just to avoid garbage collection, and also like in the next rendering cycle we can reuse some of those fibers. So basically doing some performance optimization there. With this, the benefit you're getting is basically like you can interrupt your asynchronous, your rendering in work in progress tree, and you can start a new rendering again, like if there is a high priority update happening in between of your rendering is happening, you can interrupt, you can easily interrupt, and you can restart things. But because we are doing it on a different tree, and things are happening in async, a lot of async thing can happen together. A lot of updates can happen together, and there are different type of updates and all of these updates have a different priority. For example, browser task has the highest priority, and then basically the updates on the component from the input or animation or interaction feedback, all are high priority, and all of them need to be flushed synchronously so that the user gets the feedback as soon as possible. It would be a bad experience if user sees the input after some millisecond. And there are updates like updates inside timeouts, API calls, lazy loads. All of these are lower priority updates, and this can be deferred and also can be interrupted by like a high priority updates or any other updates in general. So this type of update can be interrupted. And there are different APIs which React provide to manually marking an update as a deferred or a sync. Basically, you can say use deferred, the transitions. You can also say like you want to flush some state synchronously, etc. Now, because the deferred updates are happening lazily, not lazily, basically. It is happening in a deferred way. What you want is the application should reach to a state where it should be after some period of time, but it should reach so basically the eventual consistent is a core outcome of concurrency. So to understand this, let's see an example of UI where you have an input with a table with many cells. Now, in this input, whenever you type on that input, you filter and update the tree. So there are two things happening here. One, you have to show whatever user has actually input on that like a input element, and also like update the table. The user input should be updated as fast as possible so that there is a feedback, fast feedback happening for the user for a better pursuit experience. But the table rendering that can lag behind, because while user is typing, probably they might be typing a many characters, and every keystroke the table will be changing. So user is expecting table to change, and it can lag a little bit behind. So there is one common technique which we keep doing to solve this thing is basically debouncing. But here with the concurrent feature, instead of debouncing a rendering, we defer a table rendering. And what it means is basically like a debouncing is actually delaying a problem. It doesn't actually solve that problem. So basically, when you type and you debounce something, you're just saying like, okay, execute something after some millisecond. And what will happen if after that millisecond, while the table is rendering, user puts a new input, user entered something new. So it again, like there could be some frame drops at that point of time. With a deferred rendering, it's a different. It's basically like you keep trying to render a table as soon as possible. You don't have to wait for some millisecond. Whenever there is a keystroke, you just try to render the table. But there is a difference. There are two types of states here. One is a synchronous update, which is basically the input change, which is flushed synchronously. But the table change is deferred update, and it can be lag behind, and it's fine if it lags behind and it comes a little bit late. But at the end, eventually the table will become consistent with whatever user has typed. So you get the exact value on the table as well. With this, what benefit we are getting is basically like for a fast system, the update can happen fast. You don't have to wait for table, like you don't have to wait for 200 milliseconds for all the users. With debouncing, which you will have to do that, even though like it has a fast system and it can be done within 5 milliseconds, you spend 195 milliseconds just for waiting for something. With this deferred approach, for a fast system, it will render as soon as possible. For a slow system, it's fine if it is if it lags a little bit behind. The next pattern is a transition, and if you're following React content features, you must have heard about transitions. And transitions are mostly declarative way of defining a deferred update. So basically it's like a saying your application is at state A and you want to bring it to state B, and between this transition these are the state changes. So you must have seen a hook called use transition. There is a new start transition method as well, which is a global start transition on like import from a React, which is more of a global transition. And all of the updates triggered within a transition, all of them are clubbed together. So basically like in a transition you say like this all changes will be there, and it has to go on one transition. And transition also have this timeout, like because you mark transition, and these are the deferred update, right? So deferred update can be interrupted by high priority updates. So there could be a chance where transition never happens at all. So you give a timeout that at least after this much time the transition should finish. And you can have also like a multiple transitions within a same event cycle. You can trigger two different transitions which updates two different things, and each of these transitions will be running on their own universe type of way. So two transitions doesn't impact each other, like they run independently. And any update you can even do like a call the same transition again and again in the same event cycle, or and whenever you do that all the state changes are merged together. This can happen even, let's say, while transition is happening, you clicked the button again, and then the same transition is merged with the previous transition. Now definitely like this concurrent features are good. They open a lot of possibilities, and there are a lot of good APIs. But let's try to understand what are the internal complexities, because these are quite tricky to implement. There are a lot of corner cases around it, and the user land, thinking about the user land from the library perspective, it's quite tricky. And in this section, I'll be talking more toward my experience on building concurrent features for BrahMos. A couple of, like most of them kind of relates with what React does, but there are a little bit deviation. So just to know that that here it's more of the complexities I faced and how I solved it on BrahMos. So the first complexity is that your update on a deferred update can become stale if it's get interrupted by like a synchronous update, and not just synchronous update, like a new deferred update can also make your previous deferred update stale. So there is a good chance that you get some inconsistent things. Not good chance, basically like that's what library try to solve. And the other type of problem is basically like because things are happening asynchronously, and if they are updating, or those updates are mutating the same reference, it can have side effects like the states, this dot state in a class component is shared, right? So if things are mutating the same reference, it can have some side effects. Now to solve the stale problem, what I did in BrahMos is basically have a timestamp to know which update is the latest, and always go toward latest. If deferred update is latest, go toward that. If something is on the current tree is the latest, dump the things on the work in progress tree, and again use the deferred, again use the state set on the current tree. And basically, this to solve the mutating problem. We don't apply the states on a set state call. This just at that point of time it will just create a update queue, and those states are applied lazily during the render phase. So with this, what you get, like what type of rendering you are doing, and you can revert something back. And if you just do the change at the point of set state call, it would be tricky to revert the mutated part. So the other type of problem which happens because of this asynchronous rendering is that low priority updates, transitions, or any deferred update can be interrupted by some high priority updates. And there could be a chance where the high priority updates are happening very frequently, and because of which low priority update never gets a chance to finish. And basically, the low priority updates can starve. To solve that, what I did is basically like keep a retry count on low priority, basically all the deferred update, and as the retries count increases on the deferred update, we allocate more time for it so that they can finish their processing. And for transitions, it's simple. Like for transition, you can define some timeout, and at least after that timeout, the transition will happen. So transitions will not starve because of low priority updates. And the another important idea behind is basically reuse the work as much as possible, so that you don't have to do the same work again and again, and you don't spend time on the things which is not required. To do that, in BrahMos, and this is a slight deviation from the React's fiber architecture, they always do the updates in the work in progress tree. But in BrahMos, what I do is basically like do all the synchronous update directly in the current tree and reserve the work in progress tree only for the deferred update. With this, how it works is basically like, let's say there is a deferred update happened, and something is in progress. In the middle, one synchronous update happened, and it updated the current tree. Now, once you finish the synchronous update, you come back to the work in progress tree, which was doing the deferred update earlier. Now you again check like the updates which are done on the deferred tree, whether that has become stale by the update on the current tree. If not, then you can reuse those work which are already done, and if it has become stale, then you dump the things which are done on the deferred update, and you pick from the current tree. But basically, like you don't dump the work which you have done on the deferred like work in progress tree if it is not required. The other interesting thing, and actually the most interesting part while working on concurrent features for BrahMos, was the scheduling, and it is very tricky. The reason behind that is basically, as we have seen, that after processing some fibers, we yield to browser. Now, if we yield too less to the browser, our like execution will happen faster, but the browser will become janky. And if you yield too much to browser, what will happen that execution, like the browser will remain responsive, but your execution will become slow, like the overall time will become longer. The problem is that how do you know when to yield to browser, and also like how do you know when the browser will be done doing its work, and so you can schedule things accordingly. Now browsers are working on APIs like is input pending and scheduler API. and basically like is input pending says you there is some input pending, and there is a point where you should yield it to browser, and with a scheduler API you can schedule in a different priority manner, and browser will internally take care of executing those tasks, so you don't have to manually worry about it. But until that is there, let's see how I solve it for BrahMos. So in BrahMos, what I did is basically have concept of a slots. Basically create 5-minute slots to process fibers and process as much as fiber in that particular slot. This is kind of a similar with React. They also yield to browser after some time. They don't yield to browser after every process fiber, but yeah, this slots and why 5 millisecond? Because like let's say you have a 16 millisecond for 60 FPS, equally dividing it becomes 5.33, and because you want to leave some space for when you're yielding to browser, 5 was a good heuristic. But it works much better than the other scheduling techniques like set timeout, execute first. If request ideal, execute first, use that, and if timeout, execute first, use that, and ignore the other. With this, what we get is like during the frame, we get some more breathing space for the browser, and we let browser to do the job. By the way, these slots are not constant to 5 millisecond. This can grow, or can shrink as well. The slot size basically can increase based on how many times a deferred update has been retried. If it has retried multiple times, then we increase the slot size so that it has more time to process the more number of fibers in a given slot. And also the slot size can be decreased. So for example, here whenever we are near to the frame, we reduce the slot size so that we don't end up eating that particular frame. And the slot size can even increase beyond the frame size. It can increase up to 2 frames. And basically the idea is you control the FPS based on how much resource is available on the browser and what type of task you are executing. If your deferred update is taking too much time, you reduce of FPS to make like the deferred update complete. Otherwise, like it will always be in a hanging state. And for us, and most of time it depends on the resource available as well. For a faster CPU, the FPS will always remain higher because the deferred update will happen faster. For a slower system, the FPS can reduce up to 30 FPS. So basically, the idea is you can dynamically control the execution, like FPS based on the execution speed. The other problem I faced while working with transitions is that transitions are async, and there could be multiple transitions in queue. And transitions, because they are async in nature, they can have race conditions, and updates on one transition can become stale by synchronous update or any other transitions update. The other thing is basically transition can be nested. You can start transition inside start transition, and you can also compose transition. Basically, like there could be two start transition, and you can wrap it with another start transition. You can kind of like do all nesty stuffs with transitions. And the other problem is the transitions can try to update the same state. And in React right now, like the end goal is basically running all the transitions separately, but React for now is merging lot of transitions together, like whenever they update same state, then it is merged together. For a global transition, it merged together. On BrahMos, I went ahead with simple ideas, basically like two transitions will always run independent to each other if they are triggered from a different start transitions method, and if multiple transitions are started from same start transition method, it will always be merged. And multiple transitions will be kept in a transition queue instead of like trying to render all the transitions together, in which case we will have to maintain like a multiple work in progress tray, and state sync will become a nightmare. So and transitions are deferred update, so it's fine if it lags a little bit behind. So basically we keep the multiple transitions in a transition queue and process one transition at a time. And if a transition times out, we move that transition from a transition queue to a synchronous update, so that transition can finish synchronously. And for the nested transitions, at least on BrahMos, what I followed was basically always respect the leaf level transitions. For the parent transition, only the states which are directly under that transition, only those will be under that, like a parent transition. Now, there are many more things, and if you read about it, like you can go through React 18 working group. You will see a lot of discussions around this corner cases and the APIs which they are bringing up. After reading those, you'll and actually the doc is also a good place where you'll have a good understanding about what concurrent mode is trying to bring up. And after reading all of this, you will you will respect the React team for what they are doing. They're trying to solve one big problem, which is to provide like they are going towards some good direction, which is providing a better pursuit experience for user. And on a grand scheme, that is what matters. With that, I would like to thank you. Thanks for having me here. And let's catch up over this conference. I'll be available today and tomorrow. So let's catch up. Thank you. Thank you, everyone.
India. React India.
I'm really, really sorry for all the technical challenges we faced in the last talk. Hopefully, this will go very smooth. This has to go very smooth. And the cracking the concurrent mode talk would be available on YouTube. You could go and watch there, and Sudhanshu would be available in the lounge till later also, so you can go there, watch the talk, come back with any doubts, and Sudhanshu would be here to help you all. Right. So with that out of the way, let's hope for the best. Next talk is better UX in React using SVGs and Framer Motion. And I want to welcome Rohan, who is the speaker. He works at Microsoft and he transforms code into beautiful animations. In his spare time, he likes to check out different design systems and environments which run JS. I think he has literally taken to his heart the quote, find what you love and you will never work a day. And now he works 24/7. Okay, everyone, please give Rohan a huge round of applause virtually and start sending encouraging messages on the chat. It fuels us. Thank you. Over to you, Rohan.
Thank you so much, Ankit. So we have around 30 minutes, and in the next 30 minutes, I'll be driving around something around a couple of polls to post out. I'll just publish them, and I just wanted to know the answer from you guys. So here it goes. So the first one, and here it goes, the second one. So feel free and go ahead and check out this poll and just answer one of them. So according to that only, I'll be driving a bit of the session. So some questions and answers we'll be talking around. Okay, I see a lot of people are here, devs and both. Cool. And a lot of Iron Man fans as well. Okay, great. So we will be doing something with Iron Man SVG. I have like modified it a bit for the talk. But anyways, let's get started. So hey everyone, this is my exact reaction right now. Oh my God, I'm speaking at React India. I am super energized, but a bit of nervous as well if my code doesn't work, but hope for the best, it works. And what I do, I'm a front-end engineer. I mostly write around JavaScript stuff and CSS stuff. I work with Microsoft currently as a UI developer. So I am a customer facing role. that is with the Microsoft customers. So I have a team with designers and developers. So that collective called as a UX team, and we have designer and developer where designs and developer convert that design to the accessible and elegant UIs. So it's kind of combination of both the design and devs, and collectively bring out the UX as a great thing to the users basically. So whenever the requirement comes in, the UX there are various processes of UX design they do, and what as a dev we get is a prototype or a wireframe, something like that. And interestingly, we have that so many components in there, but interestingly we also have images in there. Sometimes there are various formats of images that everyone confuses as which one to use. And in this talk we are gonna explore about SVGs, and we'll compare with the normal images like PNG or JPEG images, and we'll see what benefits SVG images provide us. So this is gonna be around 30 minutes. So 30 minutes, like you can order a pizza and till my talk finishes, like you'll have it on the go. So let's move forward, and this is what we are gonna cover overall all around. So we are gonna look at what and why SVGs. We are convert SVGs to SVG components, that is SVG React components using SVGR, that is a tool, open source tool. We'll be exploring that SVG component a bit and modifying it a bit, animating a bit, and using some props as well, and bit of frame of motion if we have time. But let's move forward. The first and foremost thing that we have to answer is what is SVG. So we see different images in all over the websites, but some are PNG, some are JPEG, and one format is SVG. So this is a Wikipedia definition that tells it is a vector-based image which supports interactivity and animation as well. So whenever we design something in tools like Figma or Adobe XD, we typically do with this kind of vector images actually. So whenever we export the images, what we get is collection of vectors. So we'll see that as well. So moving forward, I like to call SVG as images on steroids. So we have all the features of images, as well as we have something extra on top of images. So what are the things that are extra that coming with the SVGs? So we have image, and we have these are limited. Some I have just noted them. There are many benefits of using SVG over a JPEG or PNG image, but these are the top 3 things I found out. Scalable. So it can be scaled to any size and diminished to any size. When we convert it to the React components, it have a small size compared to JPEG and PNG, so it is having a less performance issue when you are using it in your website. Suppose you have a large image and you are loading it up, and your code and every HTML component is everything loaded, but image is still loading. That's a really bad user experience. So we'll see that how SVG contribute to that thing as well. And the last and most important thing that entire talk will be revolving around is modifiable and customizable. SVGs can be customized and can be modified, and with the help of that only, it helps us to achieve many dimensions of animation or customizing image as well on our websites, website or whether app, whether it's React Native, whether it's anything, like SVGs are too good. Let's move forward, and like I don't have much of this presentation kind of thing, so I have much more on the side of code. We'll be just going into VS, and we'll saving it. We'll seeing what is coming in the browser. It's just like a trial and error kind of thing, and hope it works actually. And I'll just see that if there are any thing on this, everything is going fine, right? Okay, so we have a couple of designers that who 12% of the people are both designer and developer, and I hope they understand the collaboration between the designer and a developer. And as a developer, we're a bit lazy. We take the components, everything design, and we just plug in our website, and everything works. We don't have to think much, right? So in terms of design, we have to think about, but in terms of design, we don't have to think a lot. The designer are great, like, creative people. So moving forward, I have something known as image tag and SVG comparison. So let's move into the code side of the things and look at how entirety of the thing work. So the first thing is I have this my Figma file. So I have created a small SVG Ironman component. This all like SVG are coming from Akansha. That is a great website to have it. So there is no place to link that here as a link. So I'm just giving them a shout out. And these two things, that is a smiley and a sad reaction. I don't want to be my Ironman to be sad, but just for the demonstration purpose, we'll be taking this as well. So when you see our design, you'll see that it is a collection of vectors. And that what SVG gives us. It allows us to export this image, this particular illustration as vectors, collection of vectors. So whenever we go out here and we click on export, we have a couple of options here. You can see PNG, JPEG, PDF, and SVG. So the other options are not much modifiable. Once you export, you place it, and that's done. You can't interact with it. You can't change the color of it. Although if you have that inside a div and you are placing that, although you can change the background color, but you can't change the component and things inside it basically. So what I'll do is I'll go ahead and export this as SVG component, and I'll place it at in my one of the images folder that I have in my VS, and I have this Ironman SVG editor. And looking into it, it looks a bit weird that you only have parts and everything other that is not a bit of understandable. But believe me, this is the one of the very nice thing that we have in our SVG. So everything you get is a kind of vector, so you can modify pretty much anything. So what I'll go ahead and do is I have a component like 1 and 2, and I have an app component. So what I'll do is I will just call this one component in my app component, so it renders on the screen. And in this one component, I have two things. First and foremost, the Ironman SVG that I am importing at directly as an image, and one is as a React component, like it converts the SVG as a HTML component and it's rendered on the screen. So let's comment it out and look at the difference what it has offered to it has to offer in the browser. So I'll go ahead and comment it out, hit save, and I'll go to my browser. Yep, here it is. So if I inspect them, what I get is, let me drag it a bit. Yes, if I inspect them, this is my image tag, right? If you see this image tag, this is just coming as an image tag, and we have just placed it as a source item. Going forward, what if I want to change the eye color of my Iron Man? And what if I want to change the color of the clouds of Iron Man? For doing that, we have SVGs. So if you see, everything is considered as a different element. So you can go ahead and suppose I want a bit of darker cloud, and you can go ahead and mark it as black color, and it will give us a black bad weather cloud. And here we can't do that much. It is coming as a as a whole element, and we can't go inside it and modify it. And power of SVG, you can select any of the element and modify any of the things inside it. That is like, I hope that is clear, and the power of SVG is too much. One point to note here. Whenever we have designers and developers design, suppose a designer is giving me this component and they are listing out this particular cloud as in the color of white, and I place it in my website and I don't feel like, okay, this doesn't look good actually, and I want to change the color of it. What I do? I go to the designer, I tell him, buddy, please, change the color of it to, to white to black. He tells okay, or he tells okay, I'll do that. See, again, export the SVGs and give me, and I place it. I feel that, what if the color of cloud is red? I want to really visualize it, how the sky looks with the red clouds. So I again go to my designer and tell them that I want my cloud to be red. They tell, okay, I will do that. They again give me the SVG like as a PNG or other image options, PNG, JPEG, or anything. I come to my website, place it, and the red cloud doesn't look good. Again, go to my designer, and this goes on. This goes on. So there is process that goes off. Like you change this, they change it, it comes to me again. I want different thing in my image. I go to them, they again change it, and this kind of bit of frustrating and time wasting. And as a designer, I also always want to be friends with my designers, so they give me brilliant designs as well. So this problems is also solved by SVG, as this is coming as a React component, like HTML component. We can modify each of the element by our own power, like using HTML or React component with the CSS styling or anything. So let's move forward and have it on the screen, the different thing. So this was kind of a comparison between why we should use SVG, because we can modify it, why we have images. The images also have different purposes, but here we are talking about SVGs, and we are going to customize it. Let's move forward. So I have my image as a SVG. I want to convert it into a React component. How I do that? So we have an amazing tool known as SVGR. There are other tools as well, but I like to use this one. This is my personal favorite. So you can go to this website known as SVGR by Greg, and you can just drag it out and find out what is the process to convert it. So there are major 3 processes that is there. You have your SVG image, you run this CLI, and you get your React component, and that is just matter of seconds, like not even minutes, just a matter of seconds. You just run this CLI. There are other options as well. You can you can integrate it into Webpack tooling, and you can have it as CLI. You can run it as the packages, anything you can do. So it is not limited only CLI. But in this talk, what we'll do is we will run through the entirety of CLI basically. So what I have done is I have installed this package out here just to save time. In my package.json, if you see here, I have this particular in the dev dependency as a SVG CLR. And what I've done is I have written a script that is, okay, this is run SVGR when I run this. So whenever I do npm run this command, this typically takes the image that I have exported from the Figma, and it just converts it to React component, and drops it to a folder known as SVG components. So that's pretty much of it. So what I'll do, I have a Iron Man like SVG here. I go to my command line. I do npm run, and that is known as SVGRC. And what it'll do is it will run a command npx CLI. And if you see this, in my SVG component, I have my Iron Man Rust syntax like that. Once it's finished executing the CLI, and I will have my entire React component right now, as you can see. Now, what we have done is we have converted our SVG to a React component. And once we have our SVG in our React component, you can imagine the power of it. You can do pretty much everything that we do with the normal components. We can have everything as a props. We can use our states. We can have our lifecycle hooks or React hooks, everything in place. So this is the main use of converting it into a React component. And now what we're going to do is we want to pass props and just have this smiley display based on the conditions. So let's go ahead and do that as well. So for example, I go to my VS. What I do is I go to my app. So I'll comment this out. That was a comparison between SVG and image, normal image. And I'll just uncomment my 2 component. And let's look at what 2 components has to offer us. So in this 2 component, what we have is I have this Iron Man SVG that is coming from SVG component Iron Man that I just generated, right? And it's the full-fledged pure React component. And what I'll do is I'll pass a prop as a mode, and that says that, okay, Iron Man, just be happy, and our Iron Man will be happy. So what I'll do here, I'll go ahead and I'll see one thing is I'll just save the Iron Man component, I'll go to the browser. Let me find the browser if I can. Yep. So now this is coming as a React component, SVG component basically. If I have, yep, it is coming as a SVG component now. So what I'll do is I'll just go ahead and play with this SVGs, this vectors basically. So this is my sad Iron Man vector. I'll just copy this D and I'll go ahead to my Iron SVG because it's my React component. I can modify it now. I'll search for it and I pretty much find that vector that is responsible for that sad face actually. So pretty much what I'll do is I will just write here my props. If props dot mood equal to happy, I guess it was capital H, and here comes JavaScript strictness. Okay, so I'll just render. If my props is happy, I'll render this particular path. And if it is not happy, what I'll do is I'll just render an empty component out there. So, yep, now we have this as a turn-in operator. Now I go to the browser, and what I have in the browser is both the things because I have not taken this as mode, I guess. Okay, I have this. Good, very nice. I go up and I have these props and I am passing these props as a happy and it's coming here and the name of the props is mood. I go ahead and mood.happy. Everything is fine. I do the same thing with the sad face one as well. So I just copy that path here and place it out here. And once I have that, I will just have a blank component if that is not the thing. Okay, so something is wrong here. I guess now we are good. So I'll tell that, okay, render this path if my mood is happy and render this path if my Iron Man is sad. That's the pretty much thing. So I go ahead in the browser and see that, okay, I have, I guess, exchange of it. So I'll just, the path actually. Yep. So as I'm passing my mood of my Iron Man to be happy, as a happy, see the power of thing. We are actually modifying an image and inside element of the image telling me as a happy. And let's and just be sad today and we get the sad face as well. And similarly we modify happy, we get the happy face, and similarly we modify the face to sad, we get the sad face. So this is how the components work. Now when you have suppose I have something like nobody passes anything, right? So I'll go to my element component and you can have everything I told you that you can have in your React components basically. So I just import my prop types coming from prop types. And okay, so I have my prop types. I guess it is a default one. Prop type. And mood to be, I want, if anything is not passed, I want my Iron Man to be happy. And if it is not passed, as you can see, I haven't passed anything. It is rendering as Iron Man as happy. And that is what I want. Now, moving forward, the last thing. We want to animate this particular, smiley. So the Iron Man doesn't look good, just the static, just to the static face. So I want to modify it. Now what? I go to a website known as Framework Motion that allows us to give production ready library. So what I'll do is I'll import this and I will have this motion. I'm also new to it. I have recently explored it and just banging around my hands around it. So I'll go ahead and import my motions. Oh, I haven't used this prop type because I haven't used that like types of it. Anyways, let's move forward and have my motions like transport, translate, and other things like that. So if you have ever used style components, you might having something like this where we import and I go to my this particular component. I say that I don't want a path, and we get pretty much everything. Now I have this as a motion of path, and now when I do this, I can pass any props that FrameMotion supports, and one of them is animate. And let me bring a predefined animation that I just tried it out, and find it out quite interesting for the smileys. So I have this particular thing. I'll just go ahead and animate out here. That's it. So what it does it basically, it's this animates is coming from Tremor Motion, and what it does it will scale to the y starting from 0.5 to the scale of 1, again 1.5, and something like this. And I want to the transition to of have a duration of 2 seconds and repeat it of infinity. Let's look to our Iron Man. Does it have any interactivity now? Not yet, because it's a smiley face and we are put that in the sad face. Let's go ahead and put that the same thing in my this path as well, and I'll convert this to a motion dot path. Okay, so now I go ahead and I see my Iron Man smiling nicely, right? This is how we can do. So if I go ahead and in my two component, I do okay, Iron Man, just be sad for some time, and this becomes sad. This is what I has to offer for you guys. So what we did, we converted an SVG to an SVG component, and we look into how we can use SVG tool to migrate that SVG into SVG Figma component. Oh, sorry, React component, and the power of it, we can apply any of the React things on that particular component, be it animation, be it states, props, anything. So the key takeaway is, whenever you can use SVG, just use them and just convert them to a React component if you have time, of course. And there are certain libraries as well, icon libraries that have this particular set that we just pass a prop and get the image. Like suppose we have Iron Man is smiling, we pass the prop as happy, it smiles. We pass prop as a sad, it just be sad. So that's it. And thank you so much for joining in. I'll be in the long section for some time. If you have any question, we can connect there as well. And Ankit will be, I guess, taking over this session. So yeah, let's make the web creative again. Thanks.
Thank you, Rohan. That was a fantastic talk. And as again, I see people have been enjoying your talk. So don't forget to go to the lounge and hang out with Rohan. Ask him all of your animation doubts. If he doesn't say, ping me, and I'll make sure that he answers your questions. Thank you. Thank you, Rohan, for being a sport. See you all in the next session
Thank you
in a
so much.
jiffy. Thank you.
React India. React India.
Hello, everyone. How are you all doing? I hope the lagging issues have improved a lot. So the next talk is how communities helped me in becoming a 13 years old web developer. The next speaker is someone I could relate to a lot today. I got up so early and I got into a just like school. But unlike me, this little champ here is on a path to leapfrog all of us in technology at such young age. So please put your hands together for Pulkit Singh, who's going to inspire us with his journey of breaking into web development while in school.
Hey folks, yeah, Pulkit here. So, like, first of all, welcome to this session on how communities helped me in, becoming a 13 years old web developer, right? So, let's, before getting into it, let's have a short intro about me. So, currently, I'm working as a community evangelist at QSphere, like, moreover, it's a part time job kind of thing. Plus, I'm the founder of Programmers Universal Group, my own community, and hopefully, I have been part of 100 plus communities with various different roles and stuffs like that, right? And yeah, like, uh, uh, talking about my tech stacks and all, I have been working with web development, DevOps, and some part of AI ML stuff and as well, right? So yeah, so directly get into our topic now, right? So how it all started, this is one of the first question that everyone asks me, like whenever I have my session, or maybe I'm like talking to someone who is new to me, right? So basically it's like someday I was just searching on Google, and like I'm not sure what I was searching, but suddenly I got to know there is something known as code to learn competition, that's gonna held in as in Google for all the teens who are currently working with block programming and all. So I got started with it. I created an app, I submitted there, it was an app that helped students to concentrate on their studies while they are learning stuffs and all. So I made that, and I don't know what was the result. Yeah. So after that, like once I was done with all the block programming and stuff, I again, I was just googling because I got some curiosity in it, right? And then I got to know there is something known as programming language as well, right? So from there I started with Python, and moving forward to it, I suddenly got a question in my mind that the browser I'm surfing on, and like I'm googling on and stuffs like that, how is it working, and how the websites are coming on my on my local device, right? So through that I researched a lot. I researched on like what is internet. I even researched on how our browser works, like basic client servers and all, right? I studied a lot about it, and again one of my key parts of this was googling. And suddenly, like while I was googling only, I got to know there are something known as communities as well in this tech world, right? So through that I got into some of the Google developer groups, right? And through that I got to know, like, apart from HTML, CSS, JS, there is something known as React as well, something known as Angular, like many frameworks and all, right? So I started with that, and it was like now, whenever I was getting into any tech stack, I particularly joined some of its communities, so that at least if I want some mentorship, or if I want some help from anyone, maybe while I'm working with JS code and all. So at that time I won't be suffering from having no mentorship and all, because I will get directly help whenever I just put up my questions, maybe on Discord server, wherever like the channel is, right? So it was like I was just going through various texts, and I was just searching, and I was just exploring the stuffs, right? And suddenly, I got a chance to be a part of Google community platform as one of the youngest community leads. I became one of the event ambassador, yeah, like youngest event ambassador at deeplearning.ai, right? And through that it was like uh, I was having my own brand, like my face is my brand. And like it was like now something very different. So how now, let's talk about how communities helped me in it. So first of all, as I mentioned, I would directly get some mentorship, and even help I stuff and all. So through that, this was the first part. Then second one was that I was, I got even some opportunities from there. Like even I did one of my first internships of full stack web developer through getting in connect with some of the peeps in communities only. So if I talk about what are the benefits of communities, like when you join them and like what you will get from it, so it is like you will get to learn through not just talking but getting help from others, right? Plus this one, that is job opportunities as well. Like while you are networking with peeps, you may get a chance that you would get a chance for maybe interview and stuffs like that. Like maybe the people who are there who would like your profile and maybe they are interested in you, right? So this is one more thing. Then apart from this, as you can see, I'm a speaker here right now, right? So through that you will get your own personal branding as well. Like even here we are even here we are a community because like we are interacting with each other, right? So this is the main thing, right? And apart from this, it's moreover like when you get into communities, the plus point is that you will get exposure to learn from like different mindsets as well. Because just talk about like I'm on a Discord server and I've joined a VC and there are around 20 to 30 peeps, right? And we all are talking on maybe React, right? So at that particular point, we are maybe just talking about like any topic on React. And at that particular point I won't be having just one to two ideas on it, or maybe one to two explanation on it, because there would be 20 to 30 peeps, right? So at least 20 peeps would answer on that, and I would get not only from a particular mindset about that particular topic, but I will have more exposure to it, right? Additionally, again, one of my key part was here googling, right? So at that particular point as well, like maybe you would have seen that someone recently got a job just by adding googling in their skills, right? So I'm not sure it was real or not, but yeah, it's really a great skill to have as well. And the plus point here comes again that communities, it's not like when we talk about community, it's not at all like you may think that community should have a logo, community should have a maybe Slack or Discord or any stuffs like that. Then community should also have their socials, their website and stuffs like that. It's not really like that. Community, like when I tell you what is community, community is a place where people can interact with each other, right? And like uh, learn something new and learn from different perspectives, right? So this is the main thing. And maybe if you want to have create your own community, it's not necessary to have a logo and stuff like that. You can maybe just have your Twitter profile, you provide some contents on React, and it would be like you are pretty much like extremely active on Twitter. You are putting up content on a daily basis. People would be joining you there to check your content. Additionally, they would be interacting with you there. Like here's some of the plus point, that is like people are gonna interact with you, right? And additionally again, that part, job opportunities would come. And the last part is that you would even having your own notes ready. Like instead of like while you are maybe going through any of the courses on any of the online platforms, and then you would create your own notes on notebook and stuffs like that, right? But when you create your own content, you would get your content ready, right? Like your notes ready, which can help others as well. And here, even here, you are creating your own community, your own circle, where people would referring your notes, and and at some point it may even help them out, right? So like it was like that. And let me just check out the chat section once. Hello, hi. Yeah. Yeah, so like is there any questions as well? Like I'm pretty much, like really excited. I was really excited about this session, and additionally I was even, thinking of having more on discussion based session. So like if you have any questions or maybe anything like that, I would really love to, have part of as I mentioned, I've been part of 100 plus communities, right? So like if I want to include the main one, or maybe you can include React India, then my own PUG, CNCF Navi Mumbai, TFUG Chandigarh. Don't take it as a another question. Did your friends also started because of you? Yeah. So even they started recently only, right? So it was like that. And talking about my friends, it would be like, like you can say that at the starting I just got into it, right? And then I was just learning, and I wasn't much active on communities and all, right? But then like suddenly when my achievements came out in my school as well, then yeah, like my even friends started, DMing me to help them out to get started with it, right? And yeah, that's how it all like how it got started. And currently I have, like, hopefully I have mentored around 200 plus peeps through hackathons. So yeah, that's all.
That is some mind blowing knowledge Pulkit is dropping, and I think there's a lot of difference between everyone I know and Pulkit. He is part of 100 communities. I think at that age, I just had 100 WWE cards, and so
Super
thank you
excited to
everyone
be back
for
at React India.
and if you
Super
have
excited to be
specific
back at
please go to lounge area where Pulkit will be available. And next up, we have a talk from the very cool Sanket Sahu. It's I'm going to invite him to his own studio where I'm standing right now, and he'll show us some very cool stuff. So, which I'm not going to ruin the surprise. So keep watching. Sanket.
at React India, and last time it was in Goa, but yeah, this time remote. So I want to start the segment by asking this question: don't you miss Visual Basic from the 90s? So for those who are not aware, Visual Basic used to look like this. We used to have like toolbars on the left, and you could actually get an empty canvas on the right, and then you could like drag and drop something like say a button or input box or some text area. Or if not Visual Basic, at least Adobe Flash from 2000s, it was something similar, but we could do a lot more with Adobe Flash too. Or maybe you're not that old. So to give you the context, maybe the design tools you might be familiar with something like Figma or Adobe XD, or something as basic as Paint and Brush. So you straight away get to the canvas and do your thing, right? So I want to ask, like, can we do that today? So let me introduce myself. I'm Sanket. You might have seen me talking about Native Base on Twitter. Native Base is a UI component library for React Native and web. And I go by the Twitter handle Sanket Sahu. And yeah, I also co-founded this company called Geeky Ants. Great. So my mission might be a bit heavy word, but yeah, my ideas usually revolve around build things, be it native base or some. Can Visual Basic or Adobe Flash happen today? If not, what are the roadblocks?
what's holding us back? So I think there are two reasons. The first one is that these old like visual builders like Adobe Flash or Visual Basic, they used to work for specific screen sizes. We didn't have like a lot of different sizes of screens, but today we have like screens from something as small as like watch and goes like way to the large screens, like it can be TV of 150 inches. And also we have like diverse languages, platforms, and frameworks for each of them. We have like Apple's ecosystem that works on Swift as a language, whereas Android works on a different set of tools and languages. And then we have web. So we have like a mix of those things. So it's really hard to build something like one single thing that works for all the screen sizes, for all the platforms and everything, right? So if we solve these two problems, then probably we can get there. So why am I talking about all these in a React conference? So let me put it this way. So React is more like a platform that's on top of say JavaScript, and it's widely adopted. People are using React as the default thing to build their mobile apps, web apps, and a lot more than that actually. Then we have a set of dev tools on top of it. It can be, say, UI library like Material UI or React Bootstrap, for example, or the set of tools that Apollo provides, for example. So these are like the dev tools that's built on the platform. And there was a time when we didn't have React, we had JavaScript, and then React took some time to mature the ecosystem with the dev tools. So we are slowly moving and building things on top of like platforms, that's dev tools. And now we are entering a phase of like no-code tools and low-code tools that's built on top of these things. So platforms, dev tools, and then comes like no-code tools and low-code tools. And we have like great examples like say Framer, for example, the most famous one, which is based on React itself. And then a few other tools like AppGiver or something. So these are like great tools that uses React's ecosystem to give something like low-code tools or no-code tools. So, and why is React so suitable for to build such low-code or no-code platforms? I think there are two reasons. The one is definitely it's declarative, that whatever is represented in the UI, you can actually code it in a very similar way. And the second one is the multi-platform vision of React Native, which is amazing. I'm not sure if you've gone through the latest article in the React Native blog, which says that now React Native is going beyond just mobile apps. So we have React Native Web, which is used by like all the great companies like Uber, Twitter, and I think even Flipkart uses it. So React Native Web and the suite of the, like React Native targets, there are many. It goes beyond web. It goes to like TVs and other platforms as well. So the multi-platform vision of React Native is the thing that can happen. Let's have a look at the community around like the React Native's multi-platform vision. The first one is definitely Expo. Expo is working really hard. They have like iOS, Android as a target, and now they have been experimenting with web for a long time, and now it's pretty stable. Then at the Next Conf, which was I think last month, you might want to check the talk by Fernando Rojo. So he has used React Native with Next.js, and he's the sole developer, and he scaled his company from 0 to 10 million. So that's some validation that we all need, right? So yeah, that's one thing. And then there's another company doing really great with the suite of like tools around. So Modules is a great company. They have like Stitches.js, that's a CSS and JS library. Then we have Radix, that's a UI component library. And then they're going to build a no-code sort of tool on top of that. And they've already built it. It's called Modules. But it's specific to the React ecosystem. It doesn't, I'm not sure if they might be working on the React Native side of it as well. And then we are working on the same lines, we have built native base version 3 with the mindset of having it to work on all the platforms. So it's mobile first, definitely, but it works on web as well, and it works really well. We had to build like underlying tools like React Native Aria with React Aria from the Adobe team, so to support accessibility on different platforms for native base. And yeah, native base is one of the developer tools, and now we are going to build things on top of it. So if we look at the ecosystem that we are trying to build, so we have the UI component library, which is open source. Then we have some template screens, like 100 template screens that we just announced. Then we have the builder, that's the low code no code tool based on native base that works on all the platforms. And then we also worked on something called BuilderX and API Beats. BuilderX is we are pivoting BuilderX to native base builder. So yeah, this is the entire ecosystem. I want to say that the future is exciting. We have a ton of things coming in, and now React is going beyond the browsers with the help of React Native. And yeah, a lot of great things are happening in the community and in the ecosystem. So yeah, the future is exciting. I think that's all from me. If you want to get connected, feel free to follow me on Twitter, and my DMs are open. Yeah, thank you so much. Bye-bye.
Thank you, Sanket, for that awesome pitch. And it's time now for another panel discussion. It's just me who has been speaking and making jokes, but now we have a full panel that that you will really enjoy seeing. It's about architecting a front end, and I'll just see you in a minute.
React India.
Hello, everyone. Welcome to Architecting a Front-End panel discussion. We have an amazing panel for you who will be going over all the ways that you can architect a front end. And I hope that you are watching this with popcorns, because this can get quite heated too. So without waiting any further, let me invite our panelists one by one on the stage. Please welcome Kamlesh, Rajesh, Ankita, Nitish, Ritesh, and Vihang.
Right. Hello, everyone. How are you all doing? It's oh, that's nice. Firstly, a big thank you, I think, to the entire React India team for getting us together on a discussion like this. Uh, and we've had some wonderful talks to begin with for the conference, from the one on UX, on Framer, the concurrent mode one, and what was new into React 18. And probably this discussion is something which might be a little more wholesome for everyone, because when you talk about architecting a front end, it isn't something that maybe you can discuss as a whole within half an hour, or like in a span of maybe even a few days. It's something that companies, people, engineers go on for weeks and months trying to perfect. So here on our panel, we've tried to get people, engineers, architects who've worked at companies doing different things, having different products, right from a payments integration to an e-commerce company to an SD, a PDFs company. Doing more, I'd like to start with introducing everyone one by one, and probably they can introduce themselves and talk about what they are doing at their work right now, what they're doing at in their personal projects or anything like that, right? So we can start first with Ankita. She is an associate architect at Tribo, and Ankita, you can go ahead with your work or whatever recently you were working on these days.
Sure, Nitish. Thank you. Hi, everyone. I'm Ankita Masant. I'm an associate architect at Tribo, and I'm currently working on Tribo's SaaS product called Hotel Superhero. Apart from breaking and building web applications, I also like to write articles, and I have written a few of them on React, JavaScript, and GraphQL. Looking forward to having a great discussion on architecting front end. Thank you.
All right, thank you very much, Ankita. Next, we have Ritesh. Ritesh, over to you.
Hello everyone, I'm Ritesh. I'm the web team lead at PS PDF Kit. Currently, I'm working on a PDF SDK that you can open in the browser and see PDFs or different documents using it. Apart from that, I also work on projects where I mix my creative side with the tech side in my free time.
All right, thank you, Ritesh. Uh, then we can have next with us is Kamlesh. So Kamlesh, can you go ahead?
Yep. Hi everyone. I work at a platform front-end team at Razorpay, where I lead primary focusing on two things. One is DevTools infrastructure, and the second is design system. Recently, I'm
All right, I think that is quite visible with your nice background that you have for everyone. That's really nice. Then we have our fourth panelist, which is Rajesh. Rajesh, can you tell us something?
Hi, I'm Rajesh. I'm a UI architect in Flipkart, and today I completed 1 year in Flipkart, and I've been working right currently ad hoc basis. I work on performance issues and making some roadmaps for how to avoid those performance issues altogether. So this has been my primary responsibilities in Flipkart.
All right. Thank you, Rajesh. So about me, I work in the front-end engineering team at Myntra uh, on the web and a little bit on the native side as well. And yes, most of I think our work with along with everyone is with what we're discussing in the conference with React, with architecture, and which was one of the reasons why we thought having a panel discussion like this will probably be useful for everyone, so that we get an entire holistic picture of what maybe other companies are doing, things like that, right? Probably something that you can take from this and try and apply in your daily workplace of sorts. Maybe people here will give you an idea of what they didn't do in their workplace or did in their personal projects, and that can be a hint for you that okay, maybe we can try this. So in all, I hope in the next 25 minutes, it's very useful and helpful for everyone. So we shall get started, I think. So our first sort of discussion, which I'd like to ask everyone, which is a very an open-ended sort of a question, is what is the purpose of a good architecture that you have on your app? So a number of times a backend architecture is very defined. Like people know that okay, there's a database, there might be some async queues and things like that. But if I have to define what a good architecture is or a purpose of a good architecture is, and second, even after you've defined something, what would be your metric for a good architecture? That yes, my architecture that I planned 3 months back or 5 months back was good. So let's see, we can start with Ankita. What's your view on this bit?
Yeah. So for me, the architecture is something that enables you to iterate faster and consist and sustain that iteration for a very long time. Right, meaning in Flipkart, we already, meaning even before way before I joined, like we have an architecture called as multi-widget. So basically, it's like widgetization, which many companies do. And with this thing, like it enables even hundreds of developers to work parallelly and not stepping on each other's toes and shipping their features. So one way for me to uh, measure the efficacy of architecture is number of uh, features shipped in a month, or like we call it as widgets, right? So how many new widgets we were able to add very easily at initial stage, that was a metric. But as you evolve, right, that metrics also has to be evolved based on your domains. So you just have to measure your agility in whatever terms you can. And on top of that, maybe we also have to build some custom toolings and stuff like that on top of this.
All right. Ritesh, would you like to add to that?
So to me, front end, the sole purpose of front end architecture or is to make things simple and predictable. So when you are working on a small application, it's not that relevant, but as the application keeps growing, it's very important that things are predictable. And about the metric of whether, if you want to know that your front end architecture is working, the best thing is ask a fresher who has just joined your company what they think about your front end architecture. I think that's the best metric you can have.
Okay, fair enough. I think we have a lot of freshers or people who are in their first couple or two in this conference. Maybe they'll be able to relate to this bit a lot more on how their onboarding to their tech stack was.
And Google about architecture in general, you'll see a lot of tutorials explaining how you can architect scalable, maintainable, flexible backend architecture. Okay, unfortunately, many of us think that front-end architecture is about placing a component at some particular place in your project. I think it's not only about that. You also have to take care of other things. For example, let's say you're building a feature, it should be very easy to convert your business use case to your view layer, like components, error handling, etc. Or even data layer should already be very well abstracted out from your component. And if you want to push a small fix, it shouldn't be that you have to do this at multiple places. It's going to take days. Given the complexity of web applications, it is very important that you architect your front end properly. Otherwise, even a small fix is going to ripple throughout the project, and it is going to take days to push this to production. So like for example, let's say your business comes and tells you that now you have to change the number of room nights that you can allow to a particular use case. Okay, you don't have to go and change at multiple places. There should be abstracted the utilities, and even validation should be abstracted out from your components, so that you have to change it at one place and just ship it. I think it should be that simple.
All right. Kamlesh, have you had any similar view at Razorpay or in your previous places, or what are your thoughts on this?
Yeah. So at least to me, I think front end architecture is something which is like, so in front end we have so many pieces and there's no defined way that, okay, this is the right architecture or these are the things that you always need to build an application. So which also has a upside to it that you get to choose what works best for your use case. So at least to me, front end architecture is something that you choose right pieces of things from the ecosystem which fits your team and your use, and make it safe. Like they don't have to mess their head around, okay, today I have to write a new workflow. How do I write my unit test cases? How do I write my commit messages? How do I test my code? How do I give my product managers or designers a way to see that whatever they had asked for is fulfilled or not? So it's about how to abstract out all these pieces so that the developers in your team can focus just on shipping features and not messing their head around, okay, what should I pick from this set of tools from the ecosystem?
All right, fair enough. I think we've got nice contrasting views. More or less, it's pretty much everyone has agreed to the onboarding part of it, plus the speed to ship a new feature. People we can then also next come to how much of business or how much of which is like an important thing which companies end up discussing is you might get read about some latest library on Twitter or something, but you need not implement that in your day-to-day sort of work, right? So whenever a feature is given, which can be either a POC or a full-fledged release, which we've targeted for like another 6 months. So how does your architecture differ if it is a POC release versus whether if it is a full-fledged release? So for POC releases, for people, it can be like a quick form that you want to put out and you want just some metrics, and a full-fledged release can be touching multiple teams. So does your architecture differ in such a case, or you have a constant view throughout? So we can start, I think with Ankita. Can you have your opinion on this? So if you have a POC release versus a full-fledged release, does it differ in your architecture patterns and your thoughts, or designing everything?
So I think, POC you're doing for some part of your application, or you're doing it to see if this feature or if whatever you're trying works out for your use case, right? So it is okay to, like assume some parts of the application and just use the boilerplate that you already have or the libraries that are already available to, like only work on this focused piece of POC, and assuming few things. But when you're shipping a full-fledged architecture, you cannot assume things. You should be able to build it from ground zero. So I think, when you're building a POC, it is okay to like just focus on that particular piece and experiment things. But when you're doing it a full-fledged release, I think you should do it properly from ground zero.
All right. Anything that you'd like to add, Ritesh?
So I mean, when you're working on a POC, the most important part is how do you prioritize, because you can't take care of everything. You have less time. You just want to prove that okay, the concept works. So you need to prioritize, like whether you want to focus on how the application is working, whether you want to focus on performance, because once it's approved, then you can go ahead with spending more time and fixing all those issues that you have. So quick prototyping is very important sometimes, and you have to make some define the scope and define the priorities in that case.
Fair enough. So I think in general, probably I think companies or people or engineers do tend to follow this, that a POC is more with the ship fast sort of an approach. Of course, it doesn't mean that you have a poor design in place, but probably give more thought to it after an idea has been validated. Then we'll probably also come to the more tech sort of a thing of this discussion, the tech part of it, that when you're designing a new application, how do you structure it? In terms of what is the thought process that goes behind various things in the structure of the application. Things like, do I make it a desktop only, or do I split the app for desktop versus mobile? What sort of folder structure do I follow? Do I follow one flat structure, or do I follow a monorepo sort of a thing? So in what cases, if you guys have come across this, what were your decision-making points that you did? So we can start probably with Kamlesh on this. That what was your decision-making point for your folder structure, or for, how do I break this application down to start with?
At least for me, what I've at least observed is that if we put too many opinions or too many restrictions in your code bases, it slows your team members' productivity. So if we if we say that we want to make our product our developers more productive, and we should simplify things for them, I would say we should have clear set of maybe some well-defined boundaries, but still have room for flexibility. So just to share a recent, or let's say sometime back at Razorpay, there was a time where the team was still growing. It was in early stages. This was a time when I had joined. At that time, we were like, fine, we are a team of 20, 25 people. So it made sense that, okay, there were a few products, and we thought, why not bring them under one monorepo, and then which will enable us to have predictability across what's going on across teams. And then also have some set of like utilities or some set of common services abstracted out in the same repo itself, and then get rid of like publishing it to npm repo and everything. But then soon, the moment we started growing and the team exploded, it was not the right choice, because it instead of like increasing the velocity, it kind of decreased everyone down and it slowed everything down, because every team has a different kind of culture, or how do they work, or different kind of practices that they follow. So what we thought was that fine, instead of having all the projects under one mono repo and then slowing everyone down, we thought, okay, we'll draw a boundary. What we did was we scoped it across, let's say, logical pieces. For example, we have monorepo, which is specifically for, let's say, payments. We have monorepo, which is specifically for, let's say, the dashboard suite of applications. Like, okay, this is my web dashboard, this is my mobile application. So then we started creating monorepos, which are like logically connected. And they belong to one product. Instead of saying one Razorpay monorepo, we said, okay, this is what we want, because that's how the team were comfortable working with. So I think what
did you all have like your own implementation, or you all used one of the any open source tools that are provided?
No, so we use Lerna with Yarn Workspaces.
Okay, with Yarn Workspaces. Yeah. Okay, I think that is this thing been like where have you decided, okay, we should split this into two repositories and have two separate deployments and all of it? Yeah.
So yeah, currently we have different repositories for React Native and MSite and desktop, but we are also doing this evaluation about how should we structure it, and we also arrived at the exact conclusion with Kamlesh came, which is like we should draw boundaries at a release level, like what things ship together should stay together, right? If you mess with that, like it will slow down the agility, and yeah, basically as simple as that. So yeah, that's how it is now.
All right, Ritesh, have you had a decision point like this when you're working, where how, or this can actually be even applicable to your personal project, where it's not necessarily your work, where you decide that I need this to be in a certain way. So have you come across this point where you have to make a decision?
Yeah. So apart from work, when I was working on two design systems, one for React Native and one for web, there were a few shared components, and it made sense to have them inside a monorepo because of the shared components. And we never know when we have to use something in both web and React Native. So we always release them together. Now at work, we have like web and other platforms, all of them use the same core. So because of that, it makes sense for each of them to live under the same repo. As we are dependent on something which is common. So I think that's a good way to judge if you're depending on something that is common to multiple packages or multiple projects. Sometimes it makes sense to have a monorepo.
All right. You, Ankita, have you come across this thing where you've decided to split between the two, or have a certain folder structure based on the application, or what have you used to define the boundaries between these two?
We also have a monorepo repo in which we have different projects for our M-site. There are two different projects, but we have a shared repository for components. Like each of these projects, they use the same components. They use like the shared components from a particular project, but it is inside the same repository. We have different projects for like there's one shared folder, there's one shared project for utils, like I was talking about earlier. You should keep your utils or common stuff in one place, so that you can change it at that particular location only, and it should be replicated throughout your system. So we have a monorepo and a shared components, utilities, and services folder, and all other projects are there in that repository. So far we have not faced any problems related to this monorepo kind of thing. It is working out well for us.
All right. I think then next we can move to probably what can be a very debated sort of a topic, where I expect a lot of different contrasting opinions and fun answers is on state management. So this is something that has evolved over the last 5-6 years, where new libraries have come up. People have said, no, we should use normal React state itself. Then context became a thing, then MobX came, and then there are some more new ones. So I think for a fresher to start with, it can be extremely confusing. What do I start with? What do I do? So what is your experience in your daily projects or at work been with state management for someone who wants to start with, or for someone who already has implemented state management? Your pros and cons on any state management system, library. Anyone can start. We'll start probably. I'll start with Ritesh, maybe. Yeah.
So with experience, I can say that I mean 3 or 4 years ago, the first go-to solution for me was Redux, but now I don't think I hate something as much as I do Redux. So it's mostly because with time I've started working on larger projects, and you start seeing the downsides of Redux only once you start working on large projects. It's not that visible in smaller projects. But at the same time, at that point in time, there were not much options. So right now, if you are starting, if you are a fresher, please use context. That I've done in use context. And in one project which needed me to use, 3JS and all, in which these don't work, I had to use just stand. So yeah, that's it. But make sure you just don't follow the herd, because this is one topic where people generally try to follow the herd, and that often backfires.
All right.
I have
Nice.
similar, I have
Sure,
similar
go
thoughts.
on.
Yeah, I have similar thoughts. Where even I don't remember even the syntax of maybe sagas, or let's say thunks, as of today. But I think that was a thing that people used to use a lot in the past. So even in the recent projects, I have not yet felt a need of adding any third party or any new libraries just for state management. And I think instead of just making it look good, and then seeing that, okay, we have 5 items or 10 things in the JS ecosystem in our app, I think if it makes sense for you, or if you really feel the need, then you should add, but at least start with use state or context. I think most of the needs get fulfilled with that.
Okay. For anyone else, probably Ankita, on your opinion on this?
Yeah, so it all starts with Redux only first. We use state management tools by default as React and Redux. So whenever I see, at least a year back, when you want to create your own project, what you do is npm install, you do create React app, and after that you do npm install Redux. And then once your app grows, your dream is to just replace all these action dispatches with use context, and you do it component by component. But I agree with Ritesh that there's a lot of boilerplate code, and you don't really want to work with Redux. Now that we have options, we should really, now that at Trebo, we have started using use context. We are using context for state management in components. But for state management across components, we are using Apollo client, and
Okay.
it is working well till now.
How different has probably been Apollo client in terms of onboarding for a new developer, the learning curve for it? Because Redux has, according to me, a substantial learning curve, because you're writing multiple boilerplate codes, right? You write an action dispatcher. So in terms of Apollo client, how easy does it get for someone who wants to start?
I completely agree. So, our Trebo.com, it uses website code basically. It uses Redux, and there are dispatchers everywhere. There are actions. So, you have to search on files. Okay, this action is getting called from this particular file. But in other project, we have completely got rid of Redux, and you are using Apollo client. So, whenever you say a developer that you have to build this feature on website, he would say, I don't want to build this feature on website. work on website because of Redux. I really want to work on Apollo client because it is easy to understand. It is easy to predict that this is how the data is flowing from this particular component A to component B. So far we have observed that like learning curve is not as much in Apollo client compared to Redux.
All right. Rajesh, so you spoke about like a widgetized architecture at Flipkart. So how has state management changed, or has it changed for you over there?
Yeah, here it hasn't changed that much, but in the newer solutions that we are building, right? Say there is some small state management required for even for design systems, like theming, and also wherever new code that we are encountering, we are planning to use context. But otherwise, like we are pretty much happy with the Redux thing. Meaning it's not completely happy, but it works, and it's meaning our code base is already a bit structured, right? And with Redux, I feel like things are more clearly labeled. Whereas like with other solutions, like things get jumbled up. Like one thing does it takes multiple responsibilities. So in that way, like I like Redux because things are very predictable, and meaning you can have a separation of concerns pretty easily in Redux. So then I like still like a
Okay.
good approach.
Okay, yeah, that's the whole point of it, that you have two contrasting opinions because people have experienced positives in either of them. For the rest of you, have you guys picked up any other front end state managements, like your experience with probably a MobX, or partly with a React Query or Zustand or things like that? Anyone who's worked with probably MobX or any other state management library. Ritesh, I know you've done it in your personal project, so you can.
Yeah. I
Uh,
mean, see, the thing is, what I've learned with time is that we are generally a fan of having too many dependencies. Okay, and if you see the chats also, people are suggesting that there are ways where you can simplify the APIs of Redux by installing one more dependency.
Okay.
Now, the thing is, I like doing that personally at the start of my career. And now I look at decreasing the number of dependencies. Like, of course, you'll find abstractions that are going to make things, APIs easier. But then under the hood, you are doing the same thing, I believe.
All right.
So, yeah, I mean, whether you are going for MobX, whether you are going for XState or Recoil, or there are so many. First, try with vanilla APIs that come with React. Try, fail, and then try something new.
All right. That's that's. I think we've got a nice sort of discussion that we had here. We're also partly out of time because this was scheduled for 30 minutes. So all the panelists are there is a section, a separate panelist section where you can ask questions, and probably you can discuss all of this a little more. You'll get better, like more time to with some of your questions. I'm sure everyone is eager to answer all of them. Thank you very much, Rajesh, Ankita, Kamlesh, Ritesh, for taking time out of your schedules, and coming here. And yeah, we hope everyone probably from engineers, freshers to people who worked, experienced people, that you guys could take something from this. Again, the panelists are all available for questions that you guys can ask. And yeah, thank you very much. Hope you enjoy the other talks.
Thank you, everyone. Quick reminder that these folks are still available on the lounge, in the lounge. So please feel free to ask all your specific questions to them and don't let them go. See you in the next session. Bye bye. friends, and even at the end of the world, Antarctica. There you go. She loves cycling and streaming cool stuff on her YouTube and Twitch streams. You all should definitely go and totally subscribe. And one little more cautious thing, she holds 4th-degree black belt in Taekwondo. So be sure not to get on the bad side of her while asking questions. Okay, please enjoy the talk. Over to you, Debbie, now.
Debbie O'Brien. I'm a head developer advocate at Bit. I'm an open source contributor, speaker, teacher, blogger, YouTuber, and all these days. And I absolutely love, in my free time, cycling. You'll find me cycling around the mountains of Mallorca, running, playing paddle, which I'm competing now in as well, which is really cool. Skiing when I can get out of this island, go to the snow. And I'm also a 4th degree black belt in Taekwondo. So yeah, you can follow me on Twitter, Debs_O'Brien. And yeah, I'm also a GitHub star, a Google developer expert, a media developer expert, and a Microsoft most valuable professional. So let's get started. The modern web is component driven. I mean, we know that, right? We've got all these frameworks, amazing frameworks, Gatsby, React, Next.js, et cetera, and they're all basically working in component driven, and React was built for component driven. So we are basically, creating everything in a perfect way. And as I actually stole these slides from Matt Bielman from his Jamstack conference keynote talk. So Matt Bielman from Netlify, thank you for these slides. And this is what he says, how it's going. Monoliths are going to APIs. Git has transformed the web. Components, and pre-building in JS. And if we look at trend 3, which is what he says, thinking in components. So it's not just me that's saying it. The whole world is going into this thinking in components. This is the direction we're all going. So we're living in a perfect world, right? We're all building components. Everything's great. Or are we? Are things really that great? Well, this is what building apps in 2021 looks like. This is an issue. This is a problem for us. Why is this a problem? We basically have normally really massive code bases. Everyone's trying to just build on top. And, because of COVID, et cetera, everything's gone online. We're online now at this conference. And everything just went and exploded online, which meant more things needed to be developed. More apps needed to be created. More people were added to the team. And it just becomes a very difficult place to work in, especially in the front end. So yeah, building apps in 2021 can become a little bit of a minefield or like this building shows. Everyone's just trying to keep building, and there's no kind of thought process going into it. And yeah, it's kind of an issue. So let's go back in time a little bit. Let's try and understand where we came from and where we are today and where we can go. So we start off with monoliths, right? Everything composed all in one piece. You got your jQuery in there. Remember those days? You got your PHP and your HTML all stuck together. Could be Java, whatever backend language you're using, and CSS and JavaScript all thrown on top of it. Now, if I were to ask you, are you still working like this? Hands up who's still working like this. I really hope you're not. But if you are, God love you. No, I was actually working like this literally 3 years ago. So this is something that, it's still there on a lot of large code bases. They're still working like this, and they're trying to get out of this. But the majority of us have managed to move away from this, luckily. So from there, we basically went to this. We separated the back end and the front end. And this was a major change especially for front-end developers, because we can now choose our framework, right? So now we got React in the front end. We have our code, just our code. We don't have to worry about what the back end are doing. They can be Java, they can be whatever they want. And we're just gonna call from an API, communicate with them through JSON, and that's it, happy days. So this is the perfect solution. We got front end and back end separated, and that's it, right? Everything's cool, or is it? So what the backend did was they started moving towards services, and they were very, very cleverly done. Absolutely fantastic initiative. And they basically if you're into backend, you'll know what I'm talking about, and kind of separate them out as little microservices. So if one goes down, the whole backend doesn't go down, right? And this makes their lives a lot easier. They can easily share them and reuse them. etc. So the back end, basically, excuse my artwork, but basically now looks like it goes to microservices, but the front end is still a monolith. That's our problem. Application as a collection of loosely coupled services, and everything is split in terms of like responsibility and knowledge, so each team can work on different services and incremental updates, one service at a time. You don't have to update them all, and then you can deploy one service. You don't have to deploy all your services, and then you the back end have done things amazing, and the front end is still a monolith. This is our problem, and this is the problem we're going to try and solve today. But you know what's going on here? Everything we're talking about, you're saying I'm building. Yes, you are building components, and as you can see, this is my demo application of a nice e-commerce store, and it's all made out various times throughout the application, and the heading is a component that's reused various times throughout the application, etc., etc. So we're all building in components. We're building how React basically told us to build, right? Building in components, separating it out, and we've got this amazing application, and that's front end. The problem is other components are tightly coupled and nested inside the app. So when we build in a React application or Next.js application or Gatsby application, for example, we build those components, and then we have those components stuck inside that application. So we can't use them in another application. Well, we can, but there's a lot of kind of work you need to do. So it's very hard. And we basically build everything thinking of that one app. We build apps. We're not building components, really. We're building apps, and those components are just nested inside, and then they get stuck in there. So yeah, the front-end monolith is basically, we've got one code base. We've got no team ownership. So if we have a massive like application or a really large enterprise, for example, how can teams own different parts of the application? How can we have
Component-driven repo for a component-driven world. Hello, everyone. My name is Debbie O'Brien. I'm a head developer advocate at Bit. I'm an open source contributor, speaker, teacher, blogger, YouTuber, aren't we all these days? And I absolutely love, in my free time, cycling. You'll find me cycling around the mountains of Mallorca, running, playing paddle, which I'm competing now in as well, which is really cool. Skiing when I can get out of this island, go to the snow. And I'm also a 4th-degree black belt in Taekwondo. So yeah, you can follow me on Twitter, Debs_O'Brien. And yeah, I'm also a GitHub star, a Google developer expert, a media developer expert, and a Microsoft most valuable professional. So let's get started. The modern web is component driven. I mean, we know that, right? We've got all these frameworks, amazing frameworks, Gatsby, React, Next.js, etc., and they're all basically working in component driven, and React was built for component driven. So we are basically, creating everything in a perfect way. And as I actually stole these slides from Matt Bielman from his Jamstack conference keynote talk. So Matt Bielman from Netlify, thank you for these slides. And this is what he says. How it's going. Monoliths are going to APIs. Git has transformed the web. Components, and pre-building in JS. And if we look at trend 3, which is what he says, thinking in components. So it's not just me that's saying it. The whole world is going into this thinking in components. This is the direction we're all going. So we're living in a perfect world, right? We're all building components. Everything's great. Or are we? Are things really that great? Well, this is what building apps in 2021 looks like. This is an issue. This is a problem for us. Why is this a problem? We basically have normally like really massive code bases. Everyone's trying to just build on top, and because of COVID, etc., everything's gone online. We're online now at this conference, and everything just went and exploded online, which meant more things needed to be developed. More apps needed to be created, more people were added to the team, and it just becomes a very difficult place to work in, especially in the front end. So yeah, building apps in 2021 can become a little bit of a minefield, or like this building shows. Everyone's just trying to keep building, and there's no kind of like thought process going into it. And yeah, it's kind of an issue. So let's go back in time a little bit. Let's try and understand where we came from and where we are today and where we can go. So we start off with monoliths, right? Everything composed all in one piece. You got your jQuery in there. Remember those days? You got your PHP and your HTML all stuck together. Could be Java or whatever backend language you're using, and CSS and JavaScript all thrown on top of it. Now, if I were to ask you, are you still working like this? Hands up who's still working like this. I really hope you're not. But if you are, God love you. No, I was actually working like this literally like 3 years ago. So this is something that, it's still there on a lot of large code bases. They're still working like this and they're trying to get out of this. But the majority of us have managed to move away from this, luckily. So from there, we basically went to this. We separated the back end and the front end. And this was a major change for, especially for front end developers, because we can now choose our framework, right? So now we've got React in the front end. We have our code, just our code. We don't have to worry about what the back end are doing. They can be Java, they can be whatever they want. And we're just going to call from an API, communicate with them through JSON, and that's it. Happy days. So this is the perfect solution. We got front end and back end separated, and that's it, right? Everything's cool, or is it? So what the backend did was they started moving towards microservices, and they were very, very cleverly done. Absolutely fantastic initiative. And they basically if you're into backend, you'll know what I'm talking about, where they were basically able to just take very small services and kind of separate them out as little microservices. So if one goes down, the whole backend doesn't go down, right? And this makes their lives a lot easier. They can easily share them and reuse them, etc. So the backend basically, excuse my artwork, but basically now looks like this. The backend is composed of all these little microservices, but the front end is still a monolith. That's our problem. Now, if we talk about microservices basically arranges the application as a collection of loosely coupled services. And everything is split in terms of responsibility and knowledge, so each team can work on different services. And incremental updates, you can update one service at a time. You don't have to update them all. And then you can deploy one service. You don't have to deploy all your services. And then you've got obviously a much smaller code base to work in. You don't have to have that whole back-end code base, just a little code base of that one little service, for example, which obviously makes it a lot easier to scale. So yes, the back end have done things amazing, and the front end is still a monolith. This is our problem, and this is the problem we're going to try and solve today. But I'm building React applications, right? They're modern. So, what's going on here? Everything we're talking about, you're saying I'm building a monolith, but I'm not building a monolith. I'm building React. And you're right. Yes, you are building React components. And as you can see, this is my demo application of a nice e-commerce store. And it's all made out of components. A button is a component that's reused various times throughout the application. And the heading is a component that's reused various times throughout the application, etc., etc. So we're all building in components. We're building how React basically told us to build, right? Building in components, separating it out. And we've got this amazing application. And that's front end. The problem is, all our components are tightly coupled and nested inside the app. So when we build in a React application or Next.js application or Gatsby application, for example, we build those components and then we have those components stuck inside that application. So we can't use them in another application. Well, we can, but there's a lot of kind of work you need to do. So it's very hard. And we basically build everything thinking of that one app. We build apps. We're not building components, really. We're building apps, and those components are just nested inside, and then they get stuck in there. So yeah, the front-end monolith is basically, we've got one code base. We've got no team ownership. So if we have a massive application or a really large enterprise, for example, how can teams own different parts of the application? How can we have a product team owning the product components? Well, you can kind of say, yeah, don't touch that folder, don't touch that folder. And you could put code owners from GitHub and stuff, but it's not great. So one version, right? You've got all these components, and every time you need to make a change to that component, you've got to rebuild everything. And that makes it hard to scale. Now, there are some some other tools that can be used to improve this, etc. But I'm not going to go into too much of that today. I'm going to show you later on how we can solve this. But basically, yeah, with the front-end monolith, we got one build. So everything is slow to develop. So if you've got large teams, multiple teams working on one large application, you've only got one build. And that means we used to do builds on a Friday and just forget it before then because it just would take too long. And then you got problems with, people on the same master branches and everyone kind of trying to get theirs basically built and basically out there into production. And then you can have merge conflicts across components. So yeah, working in a front-end monolith, it's just not fun. And what happens when we want to scale to multiple apps? And this is what COVID has brought to us. We now need applications for everything. Every company that decided they didn't need so much technology, and then all of a sudden it's we need everything. So, teams have literally had to scale to multiple apps overnight without even thinking about it. It's we need to scale. We need to scale now. How do you do that? So now you've got these 3 applications, and sometimes they're very, very similar or reuse very similar components, especially if you're working across, say, e-commerce, for example. You could have a really big cart component that has a lot of logic. It's a lot of work goes into that shopping cart component. And you don't want to have to duplicate that component. You want to be able to share that component, reuse that component. But you've just got no time, right? The product managers come along and you need that other application needs to be out the door tomorrow. You need to just get it done. So you now got basically these similar applications. What do? I mean, you just duplicate components, don't you? Don't lie to me. I know you do it. I see you. Yes, I do the same, right? I've done the same so many times. Duplicating components is quick and easy. You just copy paste. You can get the application at the door and the product manager is happy. Happy days. But what happens when you need to, maintain that component, when you need to update that component, when you need to make changes to it? You now have inconsistency across multiple applications. You've got all this code to maintain. You've even forgotten which applications have these components. And you're basically just reinventing the wheel by rebuilding it. If one component gets, a new version, etc., then you're the other component doesn't. You've got it's just an absolute a nightmare to maintain. And then updating those components across those multiple apps is going to take forever because you've got to figure out where they are. You got to clone that repo. You got to update that component. It's just a nightmare. Don't do it. Don't duplicate the components. Packaging components is another thing you can do. You can basically say, right, I've got this component. I'm going to send that up to NPM. I'm going to package it. And that can work, right? But then you have all these packages to maintain. Now, the problem with maintaining these packages is maintaining the package JSON and maintaining all the dependencies. And that's a lot of work. Again, there are tools out there to help you with this, but it's still not a perfect solution. Updating the dependencies can become a nightmare, and it's really hard to discover components. Have you ever shipped 50 components to NPM and then tried to find them, or tell a junior developer to go to NPM and find all the components? It's kind of really easy to refactor at a large scale because we can just, change anything we want because we have everything there. Cross-team collaboration. So if I'm working on one app and you're working on another app, well, we can just work together because we're all working on the one code base. Easy. So standardization is easier. We just got one ESLint file to maintain, one config. Easy. So yeah, Monorepos, this is a great solution for us. Although, is it? So the tooling can be a little bit of an issue when it comes to Monorepos. And, the tooling wasn't really built for Monorepos. Lerna wasn't built for Monorepos, for example. So we've got a lot of issues with our tooling, and, Git wasn't built for it. So that means basically we've got the Git fetches are going to take a long time. Cloning repo is going to take a long time because we've got this massive, massive repo. Now, I know GitHub Codespaces does come along with a solution for that by putting in a dev environment, makes it a lot faster and stuff, but still a problem. Visibility and discoverability. Now, although I said before, it's going to be easy for you to find your components because they're all in the one repo. You can just VS Code and just search, find a product card, and you go to find it. But discoverability is not really the same because maybe I want to see what that component looks like. And how do I know what it looks like? The code, VS Code is not going to show me what that component looks like. I've got no preview. I can't play around with it. So now I've got just the code, and I've got to figure out, is that really the component I want just by reading the code? So it's not that great. And it's it's really easy to break each other's code. I know. Have you ever done that before? It's terrible. Yeah, you kind of like make a change, but you have absolutely no idea who is using that component, how many, of the applications are using it. I mean, you can probably search VS Code and see how many are imported, etc., or use tools like Madge, for example. But again, it's quite hard, and it's very easy for you to make a simple change thinking, that's not going to break anyone's code, and then bang. Yeah, I know you wrote tests, so you're going to figure it all out, but what if you don't write tests? So it's just, onboarding new developers is really hard. So you've got these like amazing junior developers coming onto your team, and then you tell them like, go diving into this massive code base and just figure it out. Right. So that's a bit of an issue. Like you really just want them to be able to just come into the workplace and basically just be able to company like, oh yeah, really hard to deal with. Builds can be very slow, right? Because you've got like the more applications that you add into this monorepo, you've got like all these slow builds because you're building all these. Again, there are tools that can help with this a little bit. So there are solutions kind of, but yeah, team boundaries and ownership, that's a bit of a problem because there is no boundary. I own everything. I have access to absolutely everything. And that can be great, but it can be also a problem. So yeah. So I kind of asked people, I was like, what do we love or hate about monorepos? I mean, do people love them or hate them? And it was quite interesting, the results I got back. So I got a load of results back, but I'm just putting these one and highlighting these ones here. But basically a lot of them love them and a lot of them hate them. It's kind of like a 50-50. But solutions like Learner were hamstrung by the NPM's client's limitations. The tooling is just not there. He is a huge fan of monorepos, but we need to improve the tooling. And Brandon says it amazingly. Brandon says he loves the shared code between apps and libraries, the visibility, the collaboration, the consistency, the ability to standardize single package versions. But he hates the insufficient tooling. It makes the experience bad and can lead to bloated CI times and lots of ad hoc scripts. So we need to fix the tooling, right? But yeah, seriously, if we're going to scale one large app, imagine you don't have to share between multiple apps. You've just got that one large app. You're still going to have these problems because it's still hard to discover components even in just one application. It's still hard to give teams ownerships. You've got just one main branch that everyone's working off. You've got no internal versioning for any of those components. There's one long build time and you've got to manage like multiple deployments. So whether you're scaling multiple applications or one large application, you've pretty much still got the same problems. So let's break down the front-end monolith once and for all. That's the solution. That's all we got, right? So let's do it. Let me show you how. We want to have teams own features. So we want teams to own different parts of the application and be responsible just for that. That's their job. Like, just work on that. You own that, own it, and do an amazing job because we know you're going to do an amazing job. And that's it. That's all you got to worry about. So that's simple, right? Let me show you. So we could have a support team, and the support team could have certain components like a form component, which has the create support request. It's got a widget component with an online chat widget. They've got a page component for the open support tickets, another page component for the support ticket dashboard. Now they're responsible for those components, those pages, those widgets. That's theirs. That's all they have to worry about. It's like they're kind of working on a mini application, but it's all part of one big application, right? And then you've got a product team. Now the product team could own the shopping cart, which is a component. They could own a hook component, which is the get product, a widget component, which is a product card, and a page component, which is a product page for all those products. So that product team, they own those components, and they basically only have to worry about all those that they work, that they can be shipped and deployed, etc. That's their job. Now then you could have a design team, and the design team, you could call it the design system or component library or however you want to call them. And they're basically responsible for those small little components that are going to be used and consumed by all those other teams. Like a button component, for example. You want to have one button component that each team can use because that's going to bring you consistency across all your application. You want a card component. You want, the cards to look the same across the application. The logo, you only want one logo, right? You might have it in the header and the footer. You might have it in other parts of the application, but you want to have one logo. If you change that logo, then it just has to be changed once. So the design team will own that logo. And then a tooltip, for example, you want the same tooltip across all your parts of your website, and etc., right? So the design team is going to own those smaller pieces of components that the other teams will use to help compose those other bigger components. So that basically means that the support team, they build their components and they ship their components to the support scope in the cloud. The product team, they build their components and they ship their components to the product scope in the cloud. And the design team build their components and ship their components to the design scope in the own repo. So you can have the product team have one repo, one GitHub repo, and the support team have a GitHub repo, and the design team have a GitHub repo. But in that design scope, you might want to separate things out into different scopes. And you could have one GitHub repo called design, but then you might have design and, I don't know, something else like CSS animations and have that in the same GitHub repo. So every scope can have its own repo, but repos can have multiple scopes. So you can basically play around with it as much as you want, which is kind of cool. So teams, this is what we want to achieve, right? We want the teams to own features. We want the teams to work basically on what they need to work on. They own their features and they work independent from the other teams. They build their components, they ship their components. They've got a separate build pipeline. They test their components independently, separate to all those other teams that are working, and they basically ship them individually. So you have one big component, like a shopping cart component. You ship that one component. You don't ship all your product components. You ship that one component. Teams want autonomy, so why not give it to them? Why not let them just work? Because believe me, if you give that team ownership of their components and their features, and they can just ship things fast without having to worry about what the rest of the company and application are doing, they're going to do an amazing job and they're going to work so much faster. And as a developer, you're just going to be so happy, right? So this is what we want. So apps are composed from components. We all know that, right? But I want to just basically kind of show you in a different way, because we're composing the app from components composed from different teams, from different clouds, different scopes in the cloud. So like my application here of my e-commerce site, I have it actually split up into a base scope, an e-commerce scope, and the shoe store scope. And different components are being used to build this shoe store, which means like the base scope is giving me the logo, for example. The e-commerce scope is giving me the product card and some other, like, the mock data, for example, and the entity with all the types and stuff. And then the shoe store is giving me that hero component because I want it specific to that shoe store. I don't want it like to have the same one across all my e-commerce stores, for example. So each scope is feeding down different components, and that allows me to build one application. What that means is then I can build another application similar to this, or different, but using the same logo, for example, using the same product cards, and then have a completely different look and feel, a completely different hero component, etc., etc. I can choose, and I just choose the components I want to use, and I compose that application built from those different components, which are built from different teams, which are hosted on different scopes on different clouds. I know, cool, right? That's what we basically call component driven. So when we talk about component driven, components are truly isolated. They're scoped to a particular team. They're individually versioned. Now that's very, very important. Individually versioned. You version one component. You don't version your whole library. You version one component and you release one component. If you change one button, you just release the button unless the button is being used by other components in that scope, and then it will auto update those components, right? That's what you want. You want the components to no longer be coupled to the app because you want to be able to use them across multiple applications or across multiple repos. And yeah, you want them to be consumed in the app, in any app, in many apps. That's the goal. If you build component driven from the start, it means you can scale anytime. You're just set up for scaling. So when the product manager comes along and says, we need to build another application, you just go, no problem. And in a matter of hours, you're going to have another application built, done, shipped, ready. And your product manager is going to go, what? Seriously? You'll get a pay rise. Seriously, I'm telling you. But yeah, no, seriously, build so that you can scale, which just it's going to make your life easier. But how do we even do that? I mean, it sounds great, right? That's exactly what we want to do, right? And you're all sitting there going, yeah, I want that. I need that. Yes, yes, yes. But how do I do that? How do I do that? Good question. Great question. Well, let's go back to the future because, we're living in the future now. That was the past. I mean, it's a lot of the present, but we want to go to the future now. This is where we want to go. So let me show you how to do this. So welcome to Bit. Bit is basically a tool for component-driven development. And I'm going to show you a little bit of how it works. But first of all, before I show you that, let me tell you that with Bit, you can work in a monorepo if you want to. So if you're a monorepo fan and you've got all these applications and you want to have all your code in one GitHub repo, that's totally cool. The difference is that every single component is going to have its own version. So the button is going to have a version that's going to be versioned individually, and that's going to be used in all of those stores, in the e-commerce scope as well, in any of those components that use it. And anytime you update that one button component, it's going to create new versions of the product card that uses the button, the header that uses the button, etc., etc. And yeah, you can work in a monorepo and everything is just going to be versioned for you. So that makes things so much easier. But you can also work in multi-repos. So if you wanted to have the base UI having one repo and let them work individually, that team, the e-commerce team has one repo, they work individually on their components, but then maybe the applications are owned by the apps repo, and they've got like the perfume store and the shoe store and the electronics store and the sports store, and they're just consuming the components from all those other teams from other different repos. And that's very easily done. Again, every component has its own version. And again, you can even take that further and you can have decoupled code bases. So now you've got every single team owning or having its own GitHub repo. So the base UI repo from the base team, the e-commerce repo from the e-commerce team. They've got like all the product card components and the store hero components and the header component, because you want your header and footer to be the same across all your e-commerce stores, but maybe you might have other applications and therefore they're going to have different header and footer, etc. You got your perfume store, your sports store, all different repos, and all those repos are able to consume components from any of the other repos. And that's basically what we're going to do. Let me show you. So this is a repo I have. This is the base UI. And you can see here, I've got all my components. I've got like environment components, a Figma embed. We'll go into that later. Got styles, got themes, but look at the UI. I've got a button component, card, heading, very simple, normal components, but going down to the theme toggler component there, which changes, the dark mode and light mode. And basically, I'm importing the button on line 2. I'm importing button from LearnBit React. That's the name of my company. I know. It's just so it's easy to find. But LearnBit React, this would be your company name. Then you got base UI. So that's like, the team ownership. So that's the scope name. And then you got UI. That's just your namespace or your folder there, as you can see. And then button. So I'm importing the button from somewhere that's already there. It's a local import, but I'm basically importing it as if it wasn't a local import. And that allows me to easily be able to share it and use it across different repos. So really it's going to the node modules folder and it's actually getting that component from there. It's not getting it from the local version. So that's how we're able to do it. And that's basically how you should import your components when using Bit. And that means if I go to the e-commerce scope, e-commerce repo, which is a completely different repo, as you can see here, it's completely different. You can check these out later on GitHub. And what I'm doing is I'm importing that button on line 3 from that LearnBit React base UI scope, from that base UI repo. I'm importing that button and using that button. I'm importing the card. I'm importing the heading. And I'm also importing local components like the currency component, the image, the available colors, etc. So I can mix and import components from this repo, or I can import components from a different repo. Now that's basically it. That's how we should be working. And that basically means that teams can have ownership. So if we look at this, for example, we've got a base UI, which is basically like, feeding down. The e-commerce is in the middle there. And that's kind of like, the stores are being built from those. And you can basically see like what dependents are. So the base UI dependents are like different repos there, even the Figma example, the perfume store, the shoe store. So all the different repos that I've created. And, you can also look at, who its dependencies are. So if I'm looking at the shoe store, my dependencies are the base UI team and the e-commerce team. So I know like I need to have a meeting with these teams because these teams are important to me because I'm using those teams. Now you can see my picture, my beautiful face on all of these. But generally, if you like, that's because I'm there's no one else on my team. I know, it's so sad. But yeah, we are hiring, by the way. But no, normally you would have different people in there. So you would have the base UI team would be owned by like one person, and the e-commerce would be another team, another person, and the shoe store would be another team, another person. Just it's all me. But that's how you'd normally do it. So with Bit, you get a documentation and live playground for your components. So when you're actually building your components, you're able to easily find them and see them because you can actually read the documentation. The person who creates that component is going to tell you what that component does, and it's going to allow you to play with it in a live manner. So you can change the title and see what the title look if it was really big. Would it fall onto the next line? How is the CSS being like, is it working good for you? If you were to add something else in there, can you add something else? Do you have access to it? So the documentation will tell you and allow you to play with that component before you decide to actually install and use it in your application. Now you can also add your Figma embed right there into the documentation, which makes it very easy when developing. It's very easy for your project manager to come along, or for the designer even, to basically make sure the component is, the same as the styles. And another great thing is that you can just click on that button. Like, these are live, so if the designer changed something, you'll see it live, but also you can click on the button and open direct the Figma file. And then you're like, if you wanted to like inspect better the kind of the CSS and the widths and the heights and stuff like that. So yeah, basically having the designs right there in your documentation of your component just makes your life so much easier when developing. And you can create different states and compositions for your components. So you can say, right, this one, I just want it to look like this, but in the next one, the converse one, they've got like an available colors component that's put in there. What does that look like? Do I want that in my in that component, etc.? And you can, add different states right there. And you can see the component props. So you can basically, like, these are auto-generated for you. And basically you can see, like, I've got a button text is required and it's a string. There's no default value. So it's going to scream at me if I don't add that in there. And basically it's the text for the link element, style is the button. And, you got the price, which is the product price, and et cetera, et cetera. So you can see what's available to you, which also means before you use that component, if there's something you really require, you can speak to the developer of that component and say, hey, I'm looking to add this. And, you got better communication because you know what you want. So it's really easy. Rather than just like, developing and then finding you've got problems, you can actually just think ahead beforehand. You can seriously visualize your components. And yeah, like when we talk about visibility and discoverability, all your components are in this scope, they're in a cloud, and you can basically just search across them. So if I'm looking for a product card, I can search with like Command K, which is great, search product card, and I can basically see I've got a product card grid, I've got a product card component, I've got the entity product card, which is the, all the entity, all the types. I've got the product price, and I've got the available colors. So any of those components, and I can then just click on it, open that component, check it out. Is that the component I want? And then just use it. Now I can also search across multiple scopes because I might not know where something lives. I might have multiple scopes, multiple teams in a large organization, but I can also just search across that organization, and I'm looking for a button. Maybe the button is in the base UI, maybe it's in the e-commerce. I don't know. I don't have to know. I can just search and I'll find a list of the components that are available to me. And it's going to search through the name of the component as well as the labels that you give it. So yeah, you can filter by dependencies as well. So you can say, I really want only components that are using SAS, or only components that are using Tailwind, only components that are using testing library, or et cetera, et cetera. And you can check by the size, if it's a big component, small component, and you can, filter things out by the labels, etc. So you can then use your component anywhere. So as you can see in the use product card box there, you can basically use bit install to install that component. Now, if you are basically not using bit, but your components are built in bit, but then you're building a React application, Next.js application, you can just install it with npm or yarn. So you can just open your Next.js app, and you can take this npm install instead of bit install, and just install that just like you would install any module. And then you can basically just use that component inside your Next.js application, your Gatsby application, your Create React application, all of the applications, and just use it and consume it, which is fantastic. So every component has independent versions, which I told you about. And this is what it looks like. So you can go to that page of that component, and you can see basically the history of the whole component. Now,
you hiding the complexity behind the bit devs UI, so I can see my components instead of going inside repos, finding the repos for the new onboarding stuff. I just have a central place. So I have a couple of questions if you can take.
Sure.
So I wanted to know, there was a bit command. Does it work with npm internally, or does it maintain a separate version? So if I'm talking with some components which are not on bit.dev, will I use npm package name? So there is
bit installed. Anyone can use it. You can use it. I can use it. The world can use it. You can use yarn instead, but it's not actually on npm. It's like kind of a proxy between them. But we use npm to help it like be able to be installed in other applications, or you can just install a bit, whatever you're working with.
Sure. So and the other point that I quite related to was that we also have a central team which maintains those components, and if something goes wrong, we have to depend on that team to fix that component. But the example that you just showed, you could just pull down that component, you would get the files. I think they get pulled automatically from the cloud. You get those files, but when I update it, will that be a normal patch number, or is there a review process that the main team says that you can't, not everybody should update my components, or what sort of things work there?
Yeah, so 2 answers to that question. You can do like minor match, major version, patch version, whatever you want. So that's when you're doing it out, you decide what version it is. And then the other thing is permissions, right? So if we're on the same team and we have permissions set, then me and you trust each other, everything's okay, whatever, and then you can just do GitHub pull requests. But we are actually working on a Ripple CI, it's called, and we're testing it internally. What that will do is, if you modify one component, you will visually see all the components it's going to affect. So you can see that it affects the header component, the product card component, and then you can visually see the change, what it's going to look like, and then you can accept that pull request once it's kind of built it first, like a pre-build, and then you kind of say, yep, that's good, that's good, that's good, that's good. So there is a revision process, but at the moment that's not fully out there. We're still working. It's still still behind closed doors.
Okay. I think I raised a very good question there.
Yeah, a very good question.
Okay. Thanks, Debbie. I think there are a couple of more questions that I saw on the YouTube chat. Folks want to definitely get in touch with you. So would you please go to the lounge, and folks will join you there asking questions. Thank you, Debbie.
See you all there.
Thank you. Your talk was amazing. Your energy.
Thank you.
Amazing.
Cool. Thank you. Bye.
Thank you. Thank you so much, Debbie. Bye-bye.
Oh, I think I'm live. Yeah. So, hello guys. I'll be emceeing for the remaining talks of the day, and you'll have to bear with my face. And now, the first talk or the first session will be more from one of the gold sponsor, who is Anstock.io. And I'll be welcoming Dean to talk about Anstock.io. And Dean, the stage is yours.
Hello friends, my name is Ankit and I work as a backend engineer at Anstock.
My name is Purti. I'm a UI UX designer.
I am Saurabh Sutar and I'm working as a front-end developer at Anstock.
My name is Atul Kumbhar. I'm working as Serverless advocate at Anstock.
My name is Subhu Saina, full stack developer.
My name is Apurva. I am a developer at Anstock.
My name is Nathan. I work as a visual designer with Anstock.
I am Shourabh, a backend developer at Anstock.
My name is Mitanshu. Here I work as motion graphics designer.
Hi, this is Satya. I'm working as a front-end developer in Anstock.
We are a remote-first company driven by trust, so there's no micromanagement. I can do my work in early morning or at late night. As long as I deliver on time, my manager is fine with that.
As I'm an interactive person, I get a good chance to interact many people here. We learn from each other every single day.
The reason why I love working with Anstock is because it's a pretty cool company with people, very humble and very supportive. Also, you got a few perks with flexible work hours.
and Stack encourages and motivates us to learn new stuff. It provides flexibility and freedom.
On a typical day, I spend most of my time designing and implementing APIs for front-end applications. Here at Anstack, I came across really great and knowledgeable people. Anstack provides a great environment to work and an ample amount of time and resources to learn new technologies.
The work that I do here is really creative. What I like the most about Einstein is there is no such thing as red tapeism.
The best thing about the Anstack is it provides best ways to expand individual wings in their interested areas.
Here in Einstein, we are not just employees, we are all family.
What I like about Abstract is it's an employee-centric company who cares deeply about each of its employee and has excellent work and life balance.
Here you are able to develop a deep understanding of the business as a whole and your role within. The company also values your feedback, the leadership, and all the EMs are very keen listeners, and they motivate and appreciate your efforts.
Another thing is the company is employee centric. So the founder invests their time, effort, and resources in the growth of the employees.
People in the company who, right from the top, they care about us. They want us to be heard and want to be happy with the work that we do.
The team of ants is of exceptionally talented and humble people.
We are surrounded with amazing talents. It offers the opportunity to learn, grow, and build upon current skills.
Everybody here has a unique and a different stories, which creates very vibrant and a good working environment.
And Anstack doesn't follow micromanagement approach, it follows mentorship approach ultimately, which provides a zero work stress environment to each and every ant in the ants colony.
It makes working here really easy and fun. Also, there are no defined working hours, so if you are a night owl like me, you can work at night as long as you are completing your assigned tasks on time.
I'm surrounded by smart and humble guys, so I enjoy working with them.
The company lives by its core values, out of which fail fast, objective driven, and be curious are the one which I follow daily for with the latest cloud.
I would like it to tweet a little bit by saying, choose a company and a job you love, you will never work a day in your life. That's what working in Anstack feels like. So I have found the right company.
So that was one of our sponsor, and they are doing good with serverless things. Just go and visit their application product and their careers page, and they're really good. And next up, React 18. React 18 has been a buzz for quite some time, and we are going to have a detailed panel discussion about React 18. And that's what is going to start now. I'm going to welcome the panelists on the stage. So we have Akansha from Excelidra, Sudhansu from Prophecy, Nikhil Sharma from Postman, and Saurav from ONMG. They will be our panelists for the day to discuss about React 18, and the stage is yours, guys.
Hey, hello everyone. I hope you are having a good time at React India, and I hope you had a great meal. But yeah, it's time not to feel drowsy, and because it's React India, so yeah, let's just have the let's start the discussion on. Basically, in this discussion, we are going through the what are the new features and how it is going to actually affect the application, and what are the things we might want to think or just discuss that people might want to call out that okay, these are the problems which we might be facing when going into the React 18. So yeah, in this discussion we'll be diving deep into it, but before we start the discussion, I would actually request all the panel members to just introduce themselves. So maybe Sudhanshu, you can go first.
Hello everyone. So I've been working on React for quite a while, and basically I love understanding how things internally work. I've done enough research on React as well, like how things work. So probably could share some insights in this discussion.
Nikhil, you want to go next?
Yeah, so yeah, hey everyone. Super glad to have everyone on this event. Hope you're enjoying. So I'm a software engineer at Postman. I mostly handle stuff around Postman on the web, Postman just a platform, and the design systems. I love to talk about like design systems and performance in general. So yeah, so super excited to be in this panel discussion. Hope like it comes out to be a very fruitful one for all of you. Yeah.
Saurav?
Hi everyone, I'm Saurav. I currently look after the front end team at 1MG. And if there are things that you really enjoy at the app, I think, and if you do not, then you've got a bone to pick with me. I enjoy, talking about tech in general. Apart from that, I just dabble into music quite a bit. But yeah, really looking forward to discussing what React 18 has in store for us.
Yeah. Thank you. So, yeah, I think we can start the panel discussion, and we have a couple of questions which we will be discussing. And then I think if we have time, we can actually open up for live Q&A as well. But yeah, otherwise you can catch all of us at the launch. So yeah, like the first question which comes to our mind is that, hey, what excites you most about React 18? So yeah, actually there are a lot of improvements coming in, and but yeah, if you ask me personally, I think I'm most excited about the streaming with selective hydration, because with that, people will be actually able to interact with the parts of the application which is not possible till now, and it's going to reduce the time to interact to a crazy, like great extent, which will be great for all the applications looking forward to migrate to React 18. So yeah, I think I'll open up to the other members to share their views. I think Nikhil, you can go first.
Yeah. So yeah, like I definitely agree with you, Akansha. So this is a very like server side rendering along with suspense was like something that people were like wishing for like a lot of time. So they all know that they all like wish that, hey, I'm like having my HTML, my JavaScript, and I have to wait for like so much of time to get all of that to get all of that done. So it was a very obvious solution that we everyone had in mind that like, hey, why not just like do that async part at the server side as well. So yeah, super excited. Other thing that that also excites me is like now we have concurrent mode, although it's an opt-in feature, like how React 18 has like conveyed it to us. That but like I really like the way that now people can think of the state updates and like all of those asynchronous tasks as thinking in branches, or like thinking in separate sort of slabs of tasks that React does for them. Now, like we as developers have struggled a lot with this, right? We have been using like techniques like throttling the UX, or like throttling the events, stuff like that, so that we just delay things on purpose, so that we could like just mimic the case what React is doing right now, which is to give the important stuff in priority and like just intentionally delay things. And I really like that how now React has like made this major change in how this algorithm is working internally. So now what's happening is, rather than just like delaying a whole task, React can now have this power of switching between things. Like if there is a task that's already running, now all the tasks are now like interruptible. So now we can now we are like just free to like just create like we can just focus more upon creating UI, and React does all of the stuff of handling the context switching part of prioritizing things around what's important to show and like what's important to do now, whether with the browser with the main thread or not. So yeah, that's something that excites me the most. And yeah, hoping to hear everyone's thoughts.
Yeah, thank you for the detailed answer, Nikhil. Sudhanshu, what does excite you most about React 18?
I have a similar excitement as you folks. Most of it is definitely the async capability on the server rendering. Earlier, like I'll it is basically as a like architect I have seen we end up doing a lot of manual thing to just have improve the TTI. which is like a time to interact. And though like all the solution we do, it's very hard to achieve. And if you think about the app cell architecture, which is completely on a SPA thing, but still you have a server-side rendering, and then in a server-side rendering also we think about what is the on-screen, what is off-screen, and then doing lazy load. A lot of things we have to manually do, which is separate for like a server and a client. So we have been saying like the React as a library is a universal library, but when it comes to writing the universal application, you'll have to make a lot of decisions when it is rendering from a server. Do this, you might have to make API calls first and then start rendering, and for a client you follow the other pattern. So Next.js and other those libraries try to solve this, but now it will become the core part of React application. You don't have to think about it. It's just a suspense which can interrupt, which can hold your rendering until the data is loaded, and it will stream in the meantime. So definitely that is the most important thing which I'm looking forward with React 18, and definitely all those APIs for concurrent feature will open up a lot of possibilities. So yeah.
Thank you, Sudhanshu, for sharing your views. Saurav, do you want to add anything to it?
It's so weird that all of us are just using selective hydration and streaming render over everything else. Because I thought I was going to be the only one who does that. One of the reasons for that is that's what my talk is also based upon tomorrow, on how we sort of try to mimic selective hydration uh, on our code base without React 18. Uh, but that's a very important task for us as well, right? Especially given the demographic that we live in. I think that feature is going to be one of the most important ones for people in general. Even though we're looking at it from a very developer centric lens at the React 18 update, I think it means a big change for users in how they use their internet. If most of the React applications are interactive a lot more faster, they'll have a better time browsing the internet, using their favorite apps, ordering food, or browsing e-commerce websites. Streaming render is definitely something I'm most curious about, and because right now most of the hacks that people come around with have sort of a janky or jittery experience once things are getting loaded on the client. And because we can now actually render the content and then send it out and choose, let the browser lazily react on top of it, and React handle the hydration as it wants. I think that helps a lot.
Yes, because that's what I'm excited about. Is like the concurrency thing is what everyone is
just to
excited about.
just to like also
So
add on to this, Akansha,
yeah.
I had this like not like exactly related to React 18, but it's never been like a good hype around a working group having being present when there's a React, like there's a new release or a major version bump in React. And I'm like super excited to see like the community who has been like involved in asking so many questions. I see in a working group talk with Tom, who has been a part of the React Score team. Like there were so many curious questions, and like people had been so involved with that working group. So that makes me like even more excited around like how the community is giving it back in terms of feedback to the React team. So I really look forward to like how it all turns up and like how things evolve more after this. So that's also
E-
more exciting.
Yeah, that's completely true. I mean, this is the first time React 18 came up with the idea of launching the working group.
Yeah.
And as part of the working group, it really feels great that, it really helps in collaboration because, especially with the opt-in concurrent features, that's what the main agenda or
Yeah.
main worry of the React team is that how the community will be receiving it,
Yeah.
and because it has a lot of dependency on the external libraries as well, and that's the reason that the concurrency is actually opt-in and not like on a full-on concurrent zone. React is not launching on a full-on concurrent zone
Right.
because there are a lot of things, and it helps that collaboration has been turning out great so far. if you see the working group discussions, you will find the more insights into it. That what are the more the new things which are coming up. Like there are a lot of new things which are coming up, which we'll find in there. So yeah, I mean that's great, and I think it will help especially the libraries. It's going to help a lot in testing out and calling out the features which might not work or which might work, so that at the end, application developers who will be migrating to React 18 will have a seamless, like will have a very smooth experience. They really don't need to worry about anything when migrating.
Yeah.
So yeah, I think I think that we have a next question is about Suspense. So Suspense, as we already know that it has a lot of limitations right now. And generally there is a kind of there has been a kind of thing that okay, it's like a placeholder that we show, like you just remove the is loading state which you have when you're lazily loading a component, and then you just instead of that just start using these on the client side. That has been the kind of to the it's not at all like that, especially with React 18, the streamed. But yeah, we need to wait for the data fetching
Suspense are like actually far more like mesmerizing in that fact. So what I have a fallback to render, it rather helps you like to do things in parallel, right? So it helps you like do that context switching, like be it like as you mentioned, Akansha, be it having like big there on unlike our like old school loaders, which so like if we had a waterfall model, like so I had explained this in one of my like talks. It's was just going to be a placeholder, right? We can eventually use a loader of our choice. But what I thought was like if if there is a loader and I am showing a loading state, unlike Suspense, like a normal loader does not give you the flexibility of doing other stuff in parallel. So like if there's a loader on one part of the subtree, the other subtree hasn't like started doing its work yet, because when that loader actually gets off, then is the content like then are the components that get started loading, and like that's where the beauty of Suspense lies, because Suspense eventually like gives you a fallback, but like it lets you do things in parallel itself. So your other so like it's like your whole subtree is eventually like doing the rendering as they're fetching, and like that's how React docs explain it. It's render as you fetch.
Yes.
So that is the beauty of Suspense that I think. Also, like with the like incoming APIs like Suspense list, I also see Suspense as like just not a loader, but how you can like orchestrate loading inside your web page. Like so I'm like really curious how people take this, but Suspense can like help you define how like where can be the parts of your page where you would want to show a loading state, or like with Suspense list coming up, you can think of like which like what is the order of loading states that you would want to get. So it like does not tie your logic with your loader, which we had been doing before Suspense. But yeah, like it gives you an abstraction on top of these loaders and like helps you do things parallelly with that sort of fallback. So like it's way more than a fallback now, and like it's
Yeah.
way more how this thing functions. So yeah.
Yeah, that's I think that's how the team also came up with the name is rendering. So that's how I think that they came up with the name as well. I think
Yes.
Sudhanshu, I think since you are also working on Brahmos, and do you have any thoughts to share, or did you get a chance to look into the Suspense in Brahmos?
Yeah, the Suspense and Suspense list APIs are implemented there. And to be honest, like the first when I knew that like a Suspense doesn't work properly on the server side, it was like, oh man, why it isn't,
Why is it is there?
why it is there? And the basic like we couldn't use the Suspense earlier the way it opens right now. As Nikhil mentioned, Suspense is not about showing the loading screen. It's more of like a rendering in a parallel, while something like basically showing something while something is happening in parallel and suspending. So this capability we didn't had earlier. People used to implement it on our custom way, and when earlier Suspense was there, it was just for the um, loading scripts. But what I'm more excited on is when you want to load data. So earlier we used to load data on use effect, and with when we do that thing on like a use effect, one thing people don't realize is basically like they end up in waterfall of loading things. Like once your parent is not completely loaded, you can't load your the child component. Uh, when Suspense is there, it kind of lead to a pattern where you want to fetch data at the same time you want to render, like a fetch as you render pattern, right? So you don't have to wait for fetching and then rendering and then fetching and then rendering. You can move all the things at one layer, and everything will start happening together. So this is something which Suspense provide us, and also like when Suspense list and everything will come while multiple async thing is happening together. It's very hard to orchestrate things manually. Like you don't know which one loads first, which one loads later, and people spend a lot of time on orchestrating that UI, that what should be the loading order, or if you want to combine some loading. Suspense will solve all this problem along with the Suspense list if it comes on React 18. But yeah, like it's much beyond placeholder.
Yeah,
Yeah.
that's right. Saurabh, would you like to add anything to it?
Yeah. So the entire orchestration bit is interesting. What I'm curious about is how things are being handled when it comes to A/B experiments, and when you cannot determine what components or widgets are going to be loaded early on, right? It would be interesting to see how that happens and if we end up with some sort of jankiness there or not. What excites me the most is that we won't have to actually deal with loading states within components themselves, right? So if there are nested components within one Suspense boundary, it just bubbles up to one single Suspense full state, right? And that's one of the biggest wins. Otherwise, you would just end up having is loading state everywhere, flowing down the line to the smallest child. So yeah, I think a lot of development would be painless now, and yeah, like Sudhansu said, that the biggest bummer early on was that Suspense was not on server side. So really excited about it now.
Yeah. And also, I think there, if you have used Suspense earlier, if you don't pass a fallback, it basically skips those Suspense boundaries. But now with React 18, these things are actually fixed. It will actually not skip those Suspense boundaries where you're not passing the fallback. Earlier, it used to actually skip it and go like above. If there is any Suspense boundary, it will go till there. That's not going to happen. So there are a couple of improvements that we have made. And then the next question I think is about the concurrent features which are opt-in, and I think that is the discussion, that is the center area of the discussion throughout. So with the concurrent features like start transition and use deferred, which are coming in, and maybe probably more APIs would be added, maybe Suspense list would be added, and more APIs would be added. But with the APIs coming in, the main idea is that how do you use and where do you use it? Because this is something which is still needs to, like, we need to do a brainstorming on that. Okay, that, where do I use start transition? Okay, it helps me, basically the start transition, what you can do is, you are telling React that, hey, this part of my update is actually not urgent, so please don't update it immediately. That's the control you are getting in start transition. You are deferring the updates basically. But with use deferred value, what is happening is that you are not deferring those updates, but you are getting an older version of the update which you are using in your component. So these two have a different scenarios. So based on that, how do you decide where you would want to actually use it? And also, yeah, keeping in mind, like, it helps you to if you want to since this is something which React is launching first time, so you would probably not want to use it in a way from the beginning where your whole app will start using the concurrent features, but in a way where you can actually experiment with smaller parts of the applications. So that is something where how do we decide which one to use where? So probably start transition. Yeah, Sudhanshu, you wanted to say?
Yeah, I was just saying like so the user land, or I would say like the developer land where we create the application. It has a lot of variables, and when you think as a library maintainer, it's very hard to cover all those variables. Like you can't make assumptions.
Yeah.
So it's very critical to provide an API and let user or a developer decide where those thing is required. You if you try to make everything out of magically come out of the box, you might be right sometime, you might be wrong sometime, and I think that is a responsibility of more of a framework type of thing, not the library like React, more of like a Next.js, which can make a opinionated uh, guess on that, like okay, this would be the loading sequence, or this would be something which you optimize. They can make those assumptions, but like the main core library be open up for different permutations and combination of this UI cases. And having this opt-in thing is very much important, so that we, like as a developer, we can decide. But at the end goal, on all this concurrent feature is the pursued experience. Like you want to have a better, if something is happening in background, you want to give some feedback to user. You don't want to block your rendering. So basically, and there are a type of improvements which should be directly done. More of this batching thing was there, right? Or if you have marked something as a deferred, you can interrupt it. So there are certain improvements which should be like inbuilt, and then there are certain improvements which you can decide whether like you want to wrap it in a suspense boundary, or do you want to mark that particular update as a deferred update, or you want to mark like a transition to page A or a page B types. So um, yeah, I think having this opt-in was a good decision, so that like in a user land, people can decide where to do that, and user have more information about like where they are facing this problem, the pursuit problem. On the places people don't see the pursuit problem, like for example, deferred is not always a solution. Basically, like when you're typing, probably you want to debounce the API call as well. So the uh, let it user decide. Let the user decide like where they want to use something.
Yeah. To add on to that, I think like yeah, as I like completely agree with what Sudhanshu mentioned, and that's like pretty much the crux of the thing. Uh, but I think that like since like there are lack of resources there for people to find out a use case, and like people are still the community is still experimenting with these two APIs, right? So what I have been able to take a key takeaway here is like if I am to decide between use deferred and the use transition hooks. So what I think is like what use transition gives you is it creates transition. It creates a state update as a transition, and it also helps you provide a fallback to it. So if there is a case where a state is updating very very frequently, you would, as a user, I would have to choose that if showing a loader at every time would be a jarring experience, or like is it a must have. For example, if like it's a very famous example that there's a search bar, and based on that search as I type in that input value, right, some content below that search changes. So since typing inside that input is a very frequent sort of a task that user is going to do, so using using use transition in that place and showing a loader every time might not be a very good experience. Instead, I like what I might want to do is like why not just use a use deferred hook and like just use the previous value, like rather than showing a loader. It's like no loader is the best loader policy that I think. So so the more we can like reduce loaders, the more it can be better. So like in this particular example, if I can like just show the previous value and like make the updates after the important part, that is typing inside that text input is done, that can be a good example of use effort hook. But like places where there can be like transitions to like maybe some other page or like some other section inside the UI, where the probability of showing a spinner is far less frequent than the example that I discussed earlier, that might be good places to start with use transition. So far are my takeaways for that. So yeah.
I think that's start transition. Like
Yeah.
you probably went back to the old concurrent mode docs.
Yeah.
Yeah, but I think I look at it slightly differently.
Okay.
So let's take this analogy of, let's say, slowing a car down, right? So use deferred value would be like applying brakes slowly, whereas not use start transition would be like slowing down by throttling down, right? Like reducing your accelerator. So you're controlling the ingress of how updates are being done by start transition, whereas with deferred, you're basically just reducing the amount of re-renders that is being, or at
Yeah.
least at what pace your renders are being catching up to the state, right? And those two, even though they are giving you the same results, they're working very differently. So if developers might know what all ingressions to slow down, they can use start transition and tell React that this is not that important for me to update right away. Whereas if there are things which are maybe, let's say, altered by multiple changes in your app, like the table that you mentioned, right?
Yeah.
Today it's search. It could also be a filter. It could also be certain filter chips. At that scenario, you might just want to say, you know what, this can be changed through many different places. So I'll rely on use deferred so that I know that only this part slows down and the
Exactly.
rest
Yeah.
is work. Right? I don't need to know the entire flow or where else changes are being done and apply start transition there. So I think that would be one place where things get a little easier with it.
And I see a transition. Actually, the word we should take here literally. So when we call a transition, it's mostly user wants that your page is at state A and you want to move to B, and probably you want to show some information while it is going from state A to state B. You want to show some information, maybe loading indicator, or you want to persist state A, and at the same time you want to show the loading indicator as well. So all of those things you want to do. And deferred is mostly like okay, the value is something which is not a priority value. It can lag behind. So basically you want on eventual consistency, and there could be multiple changes happening on a deferred value, like let's say while you're typing there, and triggers happen, and at the time like React will decide when to throttle based on like a resource available, and it will try to display things. But transition is more like you clicked on a button, and now your state is changing from something to something else. So it's more of a expectation is a different here. Expectation is you're moving from something to something else, and in deferred, the expectation is it's just lagging things behind.
Yeah, that I
Yeah.
think I also consider it that way. So basically use deferred would be actually mostly easily used, I think, because that I think probably as you have some list or something which is basically dependent on some user input, you would want to defer it. But start transition, I think, where uh, let's say, I think some first something which comes into my mind is like when you're navigating from one page to another with suspense, both with suspense plus start transition, we can use it together, where you can you can just navigate from one page to another. You are showing a loader kind of a thing, and until your data is fetched, data is fetched for the next page, you show a loader kind of a thing, and when as soon as your data is there, then you go to the next page. So but yeah, I think sooner we will get some real life examples as well. But yeah, any expensive update which we think, I think there is famous example where you have a slider where you can update, where in the working group as well, where you can actually increase the value of slider and the data changes. Basically think of it as that some expensive operation is happening on the UI when you are actually increasing the slider. So that's also a good use case for start transition. Maybe there through some animation or some those kind of stuff where you have some expensive operation going on the UI. That time you will want to use start transition, and where you want to just want to make sure that that these updates are there, but I don't want it to reflect on my component immediately, because I don't want to render my component immediately. That's where you will want to try out used effort.
Yeah, exactly.
I think, yeah, we have a couple of, I think 2-3 minutes left. Probably we can just discuss around what do you think about the migration strategy. So migration strategy is actually gradual. It's with gradual adoption. So like React 17 it was. So what are the things you think that might worry you as an application developer when you want to migrate to React 18? Yeah, maybe Sudhanshu, you can go first.
Yeah. So I think the most thing which worries me is the libraries, which is adopting the concurrent feature or not, because um, it it doesn't impact on a user like application land. In application, people can define because it's opt-in feature what they want from the concurrent thing, but as a library, like a third-party library, they have to support all the cases. And if those libraries are not supporting those cases, even though in your application you want to support concurrent feature, you will not have the ability to do that. And some of those features will even break as well, because in a concurrent there is a problem of tearing down. Tearing in the sense like a lot of deferred update are trying to update same shared state, that could be your MOVX state, Redux state, or anything. And though like a React 18 is bringing a solution for that, called I think it's called use sync store something. I forgot the name.
Yeah, that's yeah. That is basically for the external store management where they want to use this API to integrate the React
Yeah.
18 thing, concurrent.
Yeah. So
Yeah,
the thing is like until those things are supported on all the library, the migration would be hard because
exactly.
you
Yeah.
are highly dependent on that. So first we want that, and slowly, like the application part, it's fine. We can decide where we need it, and we can migrate progressively. We don't have to migrate everything at once. The migration can happen
Okay, I
slowly.
think we just have like maybe 30-40 seconds. But yeah, I think that's what, even to add to it, I think I would say, like, apart from the external libraries, I think CSS and JS also would be one thing to point out, because with streaming, you know, to tell the libraries that hey, the CSS also needs to be streamed in. It's not like the earlier one where you just get the data at one shot from the server. And think, yeah, those are some kind of things. And but yeah, as an from an application point of view, we might not be worried, but yeah, the external libraries are something which we'll be waiting, and that's something React 18 will be launching after these things are solved, and that's where working group also plays an important role. So yeah, I think.
Yeah. Also, like people would have to do the small thing of like making their app in their like sort of strict mode, like not using. So I think the React docs mention it,
Yeah.
if I'm not wrong, that like people should be like their app should not be in like using sort of legacy APIs or unsafe lifecycle hooks, stuff like that. So I think that like people should be like careful when they want to migrate to concurrent mode, because like I'm pretty excited because concurrent mode and its features are like very much common in terms of our use case. So yeah, let's see that how people react to
Yeah.
that.
Saurabh, you would you like to add anything? I think we'll have just 10 more,
Well,
20 more seconds. But
anytime. Well, all I'm going to say is that, for companies with very large code bases, I think this will be the biggest boon out there, because we can create different routes at different level and then start migrating things gradually. Also, thumbs up because we do most of the stuff in house, so we don't have to rely on libraries much being updated. But
Yeah.
I
I
think we'll stop right now.
yeah, I think
We're already here to kick us out.
No, I just have to. I'm a timekeeper here. So yeah, it was a great discussion, guys. Like I'm already so much excited to try new things with React 18, and thank you for spending your time in talking about all these things. And guys, attendees, if you have any questions, all the speakers are gonna be in the launch now. So just go hit them up, get everything you need from them. Thank you, guys. Thanks. Thank you so much for joining.
thank you. Thank you.
Thank you.
Thanks, guys. Bye bye.
Awesome. So, after a very insightful panel discussion, it's time for us to get into the regular talks again. Now, for the rest of the day, we are going to have two teams of speakers. One belong to the light squad, who use light themes, and other who use dark themes and belong to dark squad. So, the next speaker on stage is Max Stoiber. He's from the dark team, and he's the founder of GraphQL CDN, Graph CDN. And many of you guys already know him. He's the creator of Style Components, and he's also a celebrity because like there is a short documentary movie on about his life, about his open source contributions, his parents and his friends on YouTube. You all guys should check it out because it's really inspiring. And also when not coding, you can find him skiing or bouldering. He's like a very active person, and he has a special place for coffee in his life. So that makes him my friend already. So he's going to take us through caching GraphQL APIs, which is a everlasting problem, and he's going to take us through it and how to solve it using Graph CDN. I'll pass it on to Max, and it's yours, Max.
Hello, everyone. I am super excited to be here today and to talk to you about edge caching GraphQL APIs. My name is Max Stoiber. I am in a beautiful Vienna, Austria here. Unfortunately, I can't be there in person this time, but I am really excited to be here. And if you want to follow me practically anywhere on the internet, I am at MXSTBR, basically everywhere. I am the co-founder of Graph CDN, which is the GraphQL CDN. If you are in the React community, in the React.js community, or in the JavaScript community more generally, you might have used some of the open source projects that I helped build, like styled components or React boilerplate or microanalytics or a whole bunch of others. I'm really active in that scene, and so if you're there, you might have used some of those projects as well. The story of GraphCDN and how we got there started in 2018. At the time, I was the CTO of another startup called Spectrum. And at Spectrum, we were building a modern take on the classic community forum. So essentially, we were trying to combine the best of what PHP BB gave us 20 years ago with the best of what Discord and Slack give us nowadays. That was essentially the idea. It was a public forum, but all of the comments on any posts were real-time chat. So we tried to take these two worlds that are currently very separate, where communities in Slack and Discord write lots of messages, but none of them are findable, and make them public and a little bit more organized so that you could find them afterwards on Google or elsewhere. And we tried to combine those two worlds together. Now, that actually worked out surprisingly well, which led to quite a bit of user growth. As you can imagine, with all of this user-generated content, lots of people found us on Google and elsewhere and started visiting Spectrum quite regularly. That meant we had quite a bit of growth. Now, unfortunately, I had chosen a database that wasn't very well supported. I had chosen RethinkDB, which nowadays doesn't even exist anymore. The company behind it shut down after a while. And I'd chosen that database originally because they advertised themselves as the real-time database. And their key feature, or the thing they praised externally, was that you could put this changes key at the end of any database query, and it would stream real-time updates to that database query to you. And so you could fit for what we were trying to do. Because obviously, almost anything in Spectrum was real time, right? The posts popped in real time, the chat was real time, of course. We had direct messages, which had to be real time. So this felt like a great fit for what we were trying to do. Lesson learned in hindsight: rely on the databases that everybody uses. There's a reason everybody uses Postgres and MySQL and now Mongo. There's a reason those databases are as prevalent as they are, and it's because they work. I'm a lot wiser now. I wasn't that wise back then. And so it very quickly turned out that RethinkDB, the real-time nature of it, didn't scale at all. We had hundreds of thousands of users every single month, but RethinkDB couldn't even handle 100 concurrent change listeners. Now, as you can imagine, every person that visits the website starts many different change listeners, right? We're listening to changes of the specific post that they're looking at. We're listening to changes of the community that the post is posted in. We're listening to new notifications. We had a bunch of listenings per user. And essentially, our database servers were on fire. Literally on fire. Well, thankfully, not literally, but they were crashing quite frequently. I Googled servers on fire and found this amazing stock photo of servers on fire, which, if your data center looks like this, you have some really serious problems. Ours weren't quite as bad, but they were still pretty bad. So we had this database that didn't scale, and we had to work around that limitation. We wanted to switch to a more well-supported database. However, that's a lot of work. Rewriting the hundreds of database queries we'd written and optimized up to that point, migrating all of that data without any downtime, that was just a whole project. And we wanted to get there eventually, but we needed a solution for us crashing literally every day right at this moment. As I was thinking about this, of course, I realized that caching, we had an ideal use case for caching because our API was really read heavy. Of course, it's public data. Lots of people read it, but not as many people write to it. And so actually we had an ideal use case for caching. We'd originally chosen GraphQL for our API because we had a lot of relational data. We were fetching a community, all the posts within that community, the authors of every post, the number of comments, a bunch of relational data. And GraphQL was a fantastic fit for that use case. It worked out extremely well for us, and we really enjoyed our experience of building our API with GraphQL. The one big downside that we ran into was that there weren't any pre-built solutions for caching GraphQL at the edge, which is what we wanted to do. Now, we wanted to essentially run code in many, many data centers all around the world, and we wanted to route our users to the nearest data center and cache their data very close to them for a very fast response time, but also so that we could reduce the load on our servers. Now, if you've ever used GraphQL, then you know that that is essentially what GraphQL clients do in the browser. If you've heard of Apollo Client, Relay, Urkel, all of these GraphQL clients, what they are is essentially an
a fetching mechanism for GraphQL queries that very intelligently caches them in the browser for a better user experience. So in my head, basically, the question I wanted to answer was, can't I just run a GraphQL? GraphQL clients do this in the browser. Why can't I just take this GraphQL client that's running on my local browser, put it on a server somewhere, and have that same caching logic, but at the edge? To answer that question, I want to dive a little bit into how GraphQL clients cache. If we look at this example of a GraphQL query, which fetches a blog post by a slug, and it fetches its ID, title, and the author, and of the author, it fetches the ID, name, and avatar. And there is one magic trick that makes GraphQL caching really great, and that is the __ type name meta field. You can add that to any GraphQL object. In your query, you can add that to any object type, and you will get back the name of the type of the response. So, for example, with this query, we would add type name in these two places for the post and also for the author. When the origin responds with the data, the response will look something like this, with the important piece being that now we have the post data, and we know that the type that was returned there was a post. And the same thing for the author. We got the author data, and we also know that the author is a user. And when we take this response and we store it in our cache locally in the browser, we can now associate that cached query response with those two objects. We can tag it with post with the ID 5 and user with the ID 1. Okay, that's fine. So we've just taken this query response, we've put it in the cache, we key that by the query that we saw, also by the get post query. And anytime we see the same query, we return that same data. Why are these tags relevant? Why do I care that this contains the post with the ID 5 and the user with the ID 1? Well, this is where the magic comes in. GraphQL also has something called mutations, which are essentially just actions. Anything that changes data needs to be a mutation. For example, if we had a mutation that was called edit post, which edits a post. In this case, we're editing the post with the ID 5 and changing its title. Any mutation also has to fetch whatever it changed. So in this case, we're getting back the post. And again, we can do the same thing we did for the query and add the __ type name field to the response. Now, when that response comes back from the origin to our client, the client can look at this response and go, oh, look, we just sent a mutation to the origin. That mutation has come back from the origin, and the data that was returned was the post with the ID 5. Ha! I actually have a cached query response that contains that post with the ID 5, and I can now automatically invalidate that cached query result that contains the stale data of this post. That's amazing, right? And this is what GraphQL clients do under the hood. They do this magic invalidation based on the __ type name field and the ID field, and then they combine them to invalidate any stale data that has been changed at the origin. There's one slight edge case here where the magic kind of ends, which is list invalidation. If you imagine a query that fetches a list of blog posts, in this case, just their ID and title, when we look at the response to this query, it's an array that just contains the one blog post that we have right now, the post with the ID 5, how to edge cache GraphQL APIs. Now, a mutation that creates a new post now poses an interesting problem, because of course the response to this create post mutation will look something like this. It will return an object of a post with the ID 6. But of course, our cached query result for the post list doesn't contain the post with the ID 6. And that's really annoying, because that means that GraphQL clients can't automatically validate when new items are created. Kind of frustrating. Now, thankfully, they found a good workaround for this, which is manual invalidation. Essentially, GraphQL clients give you different APIs to manually influence the cache and change it depending on which things pass through it. So, for example, with Urkel, which is the third biggest GraphQL client, this would look a little bit like this. You could tell Urkel that when the create post mutation passes through the GraphQL client, invalidate any cached query result that contains the posts query. that contains the list of posts. And so that way we can automatically invalidate that, no problem. And whenever a post is created, our GraphQL client will automatically refetch the fresh data from the origin. GraphQL clients actually go one step further, and they do something called normalized caching. If we go back to our original query of fetching a single blog post, it's a title and its author, then rather than taking the entire response of the post with ID 5 and the user with ID 1 and putting that entire thing keyed by the query into the cache, they actually take each object within the query response individually and store that individually. So inside of Urkel's cache, this looks a little bit like this, where we essentially in the cache store, okay, the post with the ID 5 corresponds to this data, and the user with the ID 1 corresponds to this other data. Why do we care to do this? Because now, if a query comes in that, for example, fetches the user with the ID 1, then the cache can go, oh, hold on, you're fetching the user with the ID 1. Although we haven't seen the specific query before, we do actually have that specific data in our cache, and we can just serve you that on the client without you having to go to the origin to fetch that data again, because we've already fetched it. It was just deeply nested in some other query, but we've normalized that for you and can now give you the user data for the user with the ID 1, no problem, just like that. Which is very nice and actually makes for less network traffic and a much nicer user experience because things will resolve much, much faster since they're already on the client and loaded. Very nice. You essentially only ever fetch every object once, which is fantastic as people, particularly if people navigate around your app quite frequently. Now, the one thing that's missing here that you might have noticed is the post.author. We have the post with the ID 5 data and the user with the ID 1 data, but how do we know that the post author is the user with the ID 1? Well, Urkel stores that in a separate to the post with the ID 5. If you're fetching the post with the ID 5's author, then that corresponds to the user with the ID 1. And then the user with the ID 1 doesn't have any further relations or links that you can go into. Now, what I really want you to take away from this section is that GraphQL is actually awesome for caching. It's actually really, really good for caching because of its introspectability. It tells you what data you're returning. And this introspectability combined with this strict schema where you have to return something that matches that schema means it's actually really good for caching. And that's also a lot of the reason why so much great tooling has spun up around GraphQL. It's gotten such wide community adoption that if one person builds tooling for it, because it's always the same GraphQL spec that it has to follow, everybody else gets to benefit from that tooling, and that's incredibly powerful. Now, to get back to my original question that I posed way back in 2018, can't I just run a GraphQL client at the edge? Can't I just take this logic that Apollo client, Relay, and Urkel have internally anyway, take that same code and just put it on a bunch of servers around the world at the edge so that everybody that uses Spectrum everywhere gets super fast response times and we get to reduce the load our server has to handle massively? Well, the key to the answer of this question lies in the last part, the edge. Because as it turns out, GraphQL clients are designed with very specific constraints that differ ever so slightly from the constraints we would have to work with at the edge. One of the main ones that we have to deal with if we were to deploy caching logic to the edge is authorization. Because, of course, if a GraphQL client runs in the browser, it knows that if something is in the cache, whoever's requesting this again can access it because it's the same person, right? If I'm using Spectrum and I'm querying for the post with the ID 5 and the GraphQL client puts that in the cache, then the GraphQL client doesn't have to worry about authorization. It doesn't even have to know anything about authorization because I am allowed to access the post with the ID 5. So if I request the same post again, the client can just give that to me from the cache, right? And go, yeah, of course, right? No problem. At the edge, that's slightly differently, right? If we have one server sitting that a lot of users are requesting data from, some of those might be allowed to access the post with the ID 5, but others maybe aren't, right? Or maybe even more specifically, if you think about user data, right? Maybe somebody's allowed to access their own email, but nobody else is. And so we can't just take a query and put that result in the cache, because that would mean everyone gets served the same data. So if somebody queries some data that's sensitive, that's specific to that user, suddenly that would be served to everyone. That would be a nightmare, right? That would be a terrible security nightmare and a really bad experience, because we would essentially just be leaking data. Very bad idea. So at the edge, what we have to do is, rather than just making the cache key a hash of the query, so essentially we take the query text that we have in the variables and we use that as a cache key, rather than doing just that, we also have to take the authorization token into account. Whether that's sent via the authorization header or whether that is a cookie, we have to just add that to the cache key, so that if somebody else sends the same query, they don't get the same response. It's as simple as that. Just put the authorization token in the cache key, and everything will be fine. The other part that's a little bit different is cache purging, because not only do we have to do automatic cache purging and support manual invalidation for list invalidation, we also have to do it globally, right? If you're running at the edge in all of these data centers globally, then you have to invalidate that data globally, right? If the post with ID 5 changes, then the user sends an invitation to edit that, or the server says, hey, look, this has changed and wants to manually invalidate it, then you have to do it globally. You can't just do it in one data center. That would be a terrible experience, because the stale data would stick around in every other data center. You have to do it globally. And so as we were thinking about these problems for GraphCD, and as we were building out this GraphQL edge cache solution, we came to the conclusion that we're going to use Fastly's Compute at Edge product. Now, we are huge fans of Fastly here. And the reason we chose Fastly is because, like their name suggests, they are super fast. Fastly has about 60 and ever-increasing data centers worldwide, spread across the entire globe. Now, here is a crazy fact. Fastly's invalidation logic, right? If you take a query response and you put it into Fastly's cache and you tag it with the post with the ID 5, if you then send an API request to Fastly to invalidate any cache query result that contains the post with ID 5, they can invalidate stale data within 150 milliseconds globally. 150 milliseconds globally. That is probably faster than you can blink, right? In the time that it takes me to do this, Fastly's already invalidated the data globally. That is absolutely mind-blowing to me, right? And I actually looked up a while ago. I was like, wait, hold on. How fast even is the speed of light, right? Surely that takes a while to go around the globe once. And so I looked it up, and actually light does take 133 milliseconds, if I remember correctly, to get across the entire globe. So how can fast invalidate within 150 milliseconds? That is super fast. Well, the answer is, of course, that they don't have to go around the entire globe, because they're going bidirectional. They're going both ways at the same time. So they only have to go around half the globe, which cuts the time in half. And then, of course, they also they have a really fancy gossiping algorithm, which you can Google. They've written some great articles about it, and I bow down in front of their engineers, because it's absolutely genius. And it is so fast that it enables our customers now to cache a lot more data, right? If you can invalidate stale data within 150 milliseconds globally, imagine how much more data you can cache, because it will never be stale, right? When the data changes, send an API request, and 150 milliseconds later, everybody globally has the fresh data. Imagine how much more data you can cache if you have the super fast invalidation. And that's the reason we use Fastly. They're super fast, and we're super happy with them. So that's essentially what GraphCDN is. We rebuilt this caching logic to run at the edge, to take authorization into account, and to have this global cache purging. And we deploy it to Fastly's Compute at Edge 60 worldwide data centers to allow our customers to cache their GraphQL queries and their GraphQL responses at the edge. I wish this would have existed back in 2018 when we had our scaling problems with Spectrum. At the time, I just built a terrible in-memory caching solution that reduced the load slightly until we eventually got acquired by GitHub. And if we had GraphCD and we would have been able to scale so much more smoothly, we would have saved so much money, because of course running something at the edge is much cheaper than running the request through our entire infrastructure. And it would have been a much better experience for all of our global user base, because everybody would have had super fast response times from their local data center. All right. I hope you learned about GraphQL caching today. The main thing I want you to take away is GraphQL is amazing for caching. That's really the takeaway I want to hone in on. GraphQL, absolutely fantastic for caching. The introspectability, the strict schema. Chef kiss. I'd love to hear what else we can do for you in the future, even if you don't need caching. Thank you for having me. If you have any questions, feel free to hit me up anytime. I am at MXSDPR, practically everywhere on the internet, and I look forward to hearing from you.
For joining us at the early time.
Thank you for having me. I'm really excited to be here, and I'm glad that you enjoyed the talk. I hope everybody learned something new about GraphQL caching.
Absolutely. And this is a existing problem. I definitely had these problems, and I'm definitely loving the idea on how you guys thought through this. And the first question, how are you so handsome, Max?
The question I asked myself. That's kind of a layup, isn't it? That's kind of a layup. I think I just have to. I think I just have to thank my parents, right? Like that's all due to my parents. I really can't take credit for any of that. I will say that it's very interesting that it took so long for someone to solve this.
Yeah,
and that's one of the things that I say both about products, but also about open source. Just solve your own problems. Right?
Mm-hmm.
If you have a problem and you can find one other person that also has a problem, it's very likely that many other people have that problem, right? And that's how most of what I've ever built has come to be. All the products I've built, all of the open source I've built was always like, well, I have this problem. A friend of mine told me he also has this problem. We should probably solve it, right? And then we solved the problem that we had, which was fine, right? Like we still solved our problem. But sometimes that ends up being a problem that actually a lot of people have, like style components, for example.
Yeah.
In this case, Graphql. And so that's something that I would highly encourage everyone to think about when you're creating open source or products. Think about who has the problem that I'm solving.
Mm-hmm. That's brilliant. Like I also have this problem, and actually my question will be like, what will GraphCDN look like maybe 6 months from now? Because already you're solving a bigger problem, and I'm damn sure you have even more bigger product roadmap in your mind. So if you can share some light on that.
Of course. So where we eventually want to get to is that we want to enable any developer to change the world, right? And that sounds slightly cheesy, but a lot of developers have really good ideas on building things. Like we have this Spectrum, right? And I'm not saying that Spectrum was maybe the best idea ever, right? Like, but it was okay, and people really like using it. We have this thing that we built that people like.
Sorry,
making
Max,
that work.
There was some issue with your audio.
But making that.
Can you speak now?
Oh,
okay, now it's good. Now it's.
Yeah, I can speak. Can you hear me? Right? All right. But making that code work. This is where I was. Making that code work for even hundreds of thousands of people was really, really, really tricky. So we built this thing. Why was it so hard to make it work for many people, right? Like that doesn't make any sense. Like that should be the easy part. The hard part should be building something people want, and then making it work for lots of people. That should be a lot easier than it is. Like it's almost like my job had changed from invent something to try scaling this in production to hundreds of thousands of users, right? That's a completely different job. And so we take essentially like big companies have teams and departments dedicated to doing things like this internally, right? Like Facebook probably has hundreds or thousands of engineers trying to build tooling like this. And we essentially built this tooling for everyone else so that you can take your project and you can make it work for maybe even billions of people, right? If 4 billion people want to use your product, that shouldn't be difficult. You should just be able to do that. You should be able to create something that everyone that is connected to the internet uses, which, by the way, it's crazy to me that that's only half of the world's population. We're literally only at 50%. How is that possible? How are only 50% of all people on the internet yet? It's going to change massively by the time everyone joins. And hopefully by then we'll be at a point where we can help you scale to 8 or 9 billion people. But that's sort of where we want to go. And so right now we're very focused on making the caching as good as it can be and making it work for all use cases. And then beyond that, we've added GraphQL analytics, we've added GraphQL performance monitoring, we've added GraphQL error tracking. So we're sort of trying to, our niche is like making it easier to run GraphQL in production, right? Making it easier to operate your GraphQL APIs in production. So that's what we're really focusing on. Letting you know, both helping you like get to scale and grow and helping you grow, but also when things go wrong, we tell you about it, right? We tell you that your API is really slow. We tell you if you're hitting an error spike, which mutations are having problems.
Hmm.
So that's sort of what we're going to try to do for the next 6 months, and then beyond that, expand wherever we see the next opportunity.
That's really amazing. I'll definitely keep following this, and hopefully I'd like to see you in some other conference or talking about how you change the world.
I hope so too. And honestly, I hope next year I can be in India in person. That would be amazing. I've been to Bangalore once and I loved it. So I hope that next year I can be there in person and we can all hang out after the conference.
Awesome. So we have one question, Max. Like, any insights on how it can be used for on-premise infra?
Great question, Ravender. So currently, we use Fastly under the hood. And so we rely on Fastly's 60 data centers heavily. And so you actually have to use GraphCDN as sort of a separate piece of infrastructure. On-premise is a little bit difficult because not many companies have 60 worldwide edge locations or even more, right? Like almost no one can operate that infrastructure themselves unless they're a CDN or they're Netflix, right? Like Netflix obviously has like a CDN team and they've built their own CDN. That's fantastic. And I have good friends over there on that team. But every other company, you can't spend time going to 60 locations around the world or even more and operating all this infrastructure. And so on-premise is a little bit tricky for us because it's like, yes, we could offer you the ability to run it on-premise, but who's really going to do that? You know what I mean? Which company can operate all of this infrastructure? Like, that's a lot of work. Like, we'd much rather just use Fastly because Fastly is excellent and they've been doing this for decades now, right? And they're really good at what they do. And so we'd much rather just use Fastly under the hood and give you the ability to operate it for you. We're thinking about potentially allowing you to deploying it to your own Fastly account, so you have at least some more control. But it's really a bit tricky with on-premise and CDNs. It's a little bit like saying we're going to run Cloudflare on-premise, which are you really going to run Cloudflare on-premise? Like, does that even make sense as much? I don't know. It's definitely a question we've heard a bunch though. So we'll see what happens there. Something we're definitely keeping in mind.
Awesome. Thank you so much for your time, Max. And guys, Max will be available in the launch area for any more questions if you have and any discussions you have to talk about him. And with that, we'll have a good thing for this talk. And thank you again so much for joining this talk.
Thank you for having me. This was fantastic.
Awesome. See you. Awesome. So we had a good talk from Max. Now it's time for another team member from Team Dark. It's Matt, and he's from Melbourne, Australia. He's a front-end practice lead at Seek Jobs, and he's also working on great design systems, and also he's into Rocket League. So if you guys are interested in it, go hit him up. Matt is also a father and a husband, and he told me that he got married when he was 19 years old. In today's talk, he'll be teaching us about CSS and JS at compile time, and he'll be teaching more about vanilla extract, and he's the creator of vanilla extract. So who can be the better person than him to teach us about it? So all over to you, Matt.
Hey everyone, my name is Matt Jones. I'm Matt Compiles on GitHub and Twitter, and I'm a front-end practice lead at Seek Jobs in Australia. Today, I'm going to talk to you about Vanilla Extract and how it works under the hood. For those who haven't seen it already, Vanilla Extract is a CSS and JS library that my team and I developed alongside our design system, Braid. Vanilla Extract allows you to author CSS style sheets in TypeScript by utilizing compile time evaluation. Its API is designed to be a minimal layer on top of CSS itself, just enough to give you scalability and type safety. It also has first-class theming utilities that generate type data structures of CSS variables. Vanilla also lets you build your own abstractions on top of the base set of APIs. It does all of this without shipping any runtime code to the browser, and it compiles all your CSS to static, highly cacheable CSS files. This is all provided via a plugin to your preferred bundler or framework. We currently support Webpack, Next.js, Gatsby, ESBuild, Vite, and Snowpack. But first, let's address what you're all thinking. Why build another CSS and JS library? In the early days of our design system, we were hitting the limits of CSS modules. TypeScript was giving us the confidence to refactor our core systems while continuing to ship value to our users. But this all broke down once we hit our styles. We'd created a theme set of utility styles to power all of our components, but this was getting harder and harder to maintain. We looked into existing CSS and JS solutions, and they made styling components really easy and quick. But we wanted to continue using our themed utility class system. It fit perfectly with our design system goal, which was to write less custom CSS overall. We're also uncomfortable with the runtime overhead of CSS and JS. Not because the existing solutions were slow, but because we didn't really need dynamic styling, so there was no reason to pay a performance penalty. Now, there was also some zero runtime CSS and JS libraries, but none of them allowed us to express our styling logic in the way we wanted to. Their use cases were limited due to relying on static analysis of the code. Now, outside of CSS and JS, Tailwind was a huge inspiration for us. It's an amazing example of how a pure CSS API can be incredibly powerful. But things like type safety are non-existent unless custom wrappers were written over the top of it. So we didn't want to stop writing style sheets altogether. We just wanted to be able to reference our styles as confidently as any other dependency. And we wanted confidence to maintain and refactor our styles over time. What we ultimately wanted was to bring the power of TypeScript to CSS. And this is what Vanilla Extract is. It lets you author static CSS files, but gives you the confidence and refactorability of TypeScript on top. And now we've got the Vanilla Extract uses a technique we refer to as compile time evaluation. Simply put, compile time evaluation is executing your code during compilation rather than in the browser. Because both inputs are known at compile time, we could actually pre-evaluate the code, leaving just the log statement printing the number 3. The add function can also be removed completely because it's no longer used. In a world where all code was this simple, you could apply this technique to remove runtime costs from your code. So what would it look like if we applied this technique to a CSS and JS library? This example shows a super basic CSS and JS setup. We have a style function that accepts a style rule, things like color red or padding 8 pixels. It then creates a single CSS class to represent the rule, returning the identifier to the class. All the CSS that gets created is just appended to the top level CSS variable. After the style function is created, we call it to create some background styles. The red and blue background variables could then be assigned to an element's class name prop to reference their respective styles. After evaluation, we now have a string of all the generated CSS. We also still have our red and blue background variables, but now they just point to their respective class identifiers in the CSS. All the style logic has been stripped away. Okay, so this is pretty cool, but we still have a few problems. Firstly, what do we do with the generated CSS? It's not much use just storing in a local variable. However, we'll come back to this. Our other problem is how do we decide what code should be executed at compile time? It wouldn't make sense to evaluate all your application code at compile time, and automatically detecting what code can be evaluated is an incredibly difficult task. And believe me, smarter people have tried. And even if we could detect what code was safe to evaluate at compile time, we want to be able to guarantee that all CSS logic is executed during compilation. And this is where ES modules comes in. It turns out that they make the perfect compile time evaluation boundary. They have their own top-level scope, which keeps you from accidentally mixing compile time and runtime scopes together. And they have statically known exports, which gives us a way to safely communicate with the runtime code that will execute in your browser. So which modules should we execute at compile time? This is where vanilla extracts .css.ts file comes into play. We use the .css.ts extension as a signal to the compiler that this module is safe to evaluate at compile time. But as it is still a valid TypeScript file extension, we get all the benefits of TypeScript out of the box. The same goes for any other tools you may have set up, like Prettier or ESLint. For anyone across React's experimental server components, this idea will seem very familiar, although I'm going to claim that they stole it from us. Let's break down how a basic vanilla extract.css.ts file gets transformed during compilation. In this file, we're exporting two styles, a container and a button style, remembering that the style function returns a string reference to the generated class name. After evaluating the file, we're just left with the two exports being directly assigned to their respective class name identifiers. But there's something new here. We've also injected an import to a CSS file. Now, this file doesn't actually exist on disk. Instead, we use a bundler feature commonly referred to as a virtual module. A virtual module is essentially a file that only exists in memory. This is implemented slightly differently depending on your bundler of choice. However, an easy way to think, it broadcasts a message to its plugins asking if anyone knows about the file. At this point, Vanilla jumps up and says, "I know what this is," and hands over the CSS that we generated while evaluating the file. At this point, the bundler has everything it needs to continue compiling your application. All your styling code has been stripped away, leaving only the values you exported from the file. And we've also linked a virtual CSS file containing all the CSS that was generated. Your bundler can now handle this like any other CSS import, running it through post CSS, minifying it, or merging it with other CSS files. Now, there are a few limitations to this approach. Firstly, as each .css.ts file is executed in isolation from the rest of your code, you can't reference any global state or perform any side effects. Secondly, all exports from this module must be serializable to JSON. This means you can't export functions from .css.ts files. If you do accidentally export something that can't be serialized, you'll receive a compiler error. So now we know how compile time evaluation can be applied, and we have our basic vanilla extract style function. What interesting things can we do with it? Here we have a React component, and it's supporting the myColors export from the styles.css.ts file. myColors is an array, so we're mapping over it and rendering a div with a corresponding class name for each item in the array. We're also importing some global layout styles just to make our demo pretty. Inside the styles.css.ts file, the myColors export is sent to an empty array, hence why we don't see anything in the browser yet. Now we also have a colors.ts file. This is where we're defining our color palette, which is an object mapping color names to hex codes. This one is actually the excellent Tailwind color palette. Back in our styles file, we can import the colors from our palette and map over our color entries, returning a new style for each one. We can then set the background to the hex code and set the content property of the after pseudo element to the name of each color. And now we have a great rendering of each color in our color palette. Opening up DevTools shows us that all the styles we just created show up as a regular CSS class in a static CSS file. You'll also notice that the classes are all start with styles_mycolors, followed by a unique hash. This is a debug experience to help you find where your styles originated from. In this case, from the styles file and the mycolors variable. In a production build, each class would be identified by just the hash. Now looking at our styles file, we find array, pre-populated with all of our class identifiers. None of our actual styling logic was even sent to the browser. The import you see is the virtual CSS import that we spoke about earlier. Now, some of our color names are a little hard to read. It would be great if we could tweak the text color to ensure that they satisfy accessible contrast ratios. The readable color function from the Polish style utility library can sort that out for us. It can choose the text color, either black or white, which best suits the passed-in background color. Opening up DevTools again, we can see the accessible text colors have been added to each class. And looking at the styles file in the browser, we can see that nothing has changed. Our accessible text logic all ran at compile time, so there's no need to bloat our bundle with extra libraries or run extra startup code before rendering something to the user. So now we've seen what can be done with the basic style function, let's take a look at what other features Vanilla Extract adds to our CSS development. CSS variables are a feature of CSS that benefit greatly from Vanilla Extract's TypeScript first approach. For those who haven't worked with CSS vars yet, they allow you to set custom variables in your CSS and then read the current value of that var in another style. To do this, you use the var function-like syntax you can see here. The best part is that CSS variables are only set for the children of the DOM element that you apply them to. They are effectively React context for your style sheet. Now, this unlocks lots of possibilities for static CSS, but like the rest of CSS, they are globally scoped and there's no type safety. So obviously, Vanilla wants to fix this for you. Here we're importing the create var API from Vanilla Extract. This function creates a unique CSS variable identifier for you. This allows for local scoping of CSS vars, ensuring another team member on your project doesn't also create a different var named something generic, like background color. In this example, the background color variable is set to a string pre-wrapped in the var function syntax, so it's ready to be used in any style. But before we use the var in a style, we should give it a value. Here we're using Vanilla's global style API. It's similar to the regular style function, but allows passing in a raw selector rather than returning a class identifier. Using the root selector, we can set the var to red for the whole document. You'll also notice the vars key our property is nested within. This tells Vanilla that you're giving it a CSS variable reference, and it will automatically unwrap the var function syntax in the string. Now we can use our variable in any styles we like. Often when using CSS variables, we use them in groups. We might be building a component that has multiple different color schemes, and we want to declare our component theme as a contract of CSS vars. In this example, we're using Vanilla Extract's create theme API to define a critical theme for our component. Within the colors key, we've declared two variables, background and text. Vanilla allows you to create as many layers of nesting as you want when defining themes. Under the hood, create theme will call into the create var API for each of the defined variables. Create theme returns two values, a class identifier, so we can apply this theme in the DOM via an element's class name prop. We've named this one critical theme, and a vars object containing references to our locally scoped CSS variables. We can now consume these variables inside our root style. Okay, so what if we wanted to add a new promotional theme with different colors? We can use create theme again, but this time we'll pass in existing vars alongside the values for our promo theme. This tells Vanilla that you're creating a variant of an existing theme and that it should reuse the variables from it rather than creating new ones. So now we want to wire our style and themes up to our component. Because we only want to apply a single theme at a time, let's export them as a theme lookup object. Now in our component file, we can use the theme import as the point of truth for the theme prop type, only allowing existing themes to be requested. This is also great because if we ever did add any new themes, we won't need to update our component code. Theme to have low to use our new padding variable. But we've actually missed something here. We've added a new variable to our theme contract, but we forgot to implement it in our promo theme. This causes a type error, as Vanilla Extract won't allow incomplete themes to be created. This saves you from shipping a broken variant of your component. So by now, I hope you can see some of the benefits that Vanilla Extract brings to writing CSS. But what if we wanted to take things to the next level with our CSS APIs? Being able to export JSON data structures is great, but it can only take us so far when it comes to creating reusable abstractions. So remember before when I said that we can't export functions from .css.ts files? Well, that wasn't completely true. Let's imagine we wanted to create a declarative Flex API. We could pass in props at runtime, like direction for example, and receive a valid class name in return. If you tried to do this, you'd receive a compile error informing you that you tried to export an invalid type from your .css.ts file. Now here is a refactored version of the same code. We've moved all of our logic into a create flex function. This then returns another function which owns the logic of deciding which class identifiers to return. I want you to observe how we've split our logic into two separate parts. One that runs at compile time and creates our styles, and another that performs our runtime logic. Let's pull our runtime logic into a separate file. We'll call this create flex runtime. Now we have the exact same result as before, but we've completely separated our compile time logic from our runtime logic. This allows us to import Vanilla Extract's add function serializer API. This API allows us to add instructions about how to replay a function when it is exported from a .css.ts file. The instructions needed are where to import the runtime logic for this function, in this case from the create flex runtime file, and what arguments should be passed to the function. In this case, it's our flex styles. The Vanilla Extract plugin can then read these instructions and imply them when generating the final styles file. And this is what the result of this process would look like in your bundle. We're importing the runtime portion of our Flex API and passing our generated class references to it. This approach also leaves TypeScript blissfully unaware of the compile time runtime boundary between the modules. Types can flow through just like any other function. Okay, so this seems like a very complex way to just export a function, right? You wouldn't want to be writing function serialization all over your code base. And I agree. The point of this API is to enable library authors to create powerful APIs that can still generate static CSS, but with the dev experience of a runtime CSS and JS library. You definitely don't need to understand how function serialization works to make use of Vanilla Extract. All right, so now we can export functions from our .css.ts files. How can we make use of them? One of the biggest hits in the CSS and JS space over the last while is the amazing Stitches. Stitches is a CSS and JS library that uses a variant-based API for creating component styles. Instead of thinking about styles in isolation, it encourages you to write styles that map to all the variant states your component can be rendered in. This allows you to define all your component styling logic upfront inside the styles themselves. It also generates a typed API to ensure your runtime usage is working as expected. If you haven't seen Stitches before, I highly suggest taking a look. The modules team does incredible work. So what would the Stitches API look like if we implemented it on top of Vanilla Extract? It turns out the approach of defining all your styles up front fits perfectly. This is the Vanilla Extract Recipe API. It's available through the @VanillaExtract/recipes package, and just like Stitches, it allows you to describe component styles in all its variant states. Here we're describing the visuals of a button. First, via the base key, you can set your default styles in your component that are always present. Then you can describe all of your variant states. Here we have color and size variants, plus a Boolean variant named rounded. You can also set which variants should be enabled by default via the default variants key. Then there's compound variants. These allow you to express styles that are enabled by having multiple variants enabled at once. And of course, you can use the full Vanilla Extract theming API hand in hand with all the styles in your recipe definition. Once you've defined your styles, it returns you a typed function that returns the required class list to render your component in that state. Over in our component file, we can render different variations of our button by passing in different combinations of our defined variants. As with all Vanilla Extract APIs, all your styles are created at compile time, and only the minimum required logic to return the relevant class list is actually sent to the browser. Currently, this API only comes in a function form. However, as React components are functions themselves, building a version that returns React components directly is entirely possible. Now, the final API I'm going to show you today is the aptly named Sprinkles. Sprinkles is an API that we could only have dreamed of in those early days of building our design system. It allows you to quickly create a set of themed utility classes via configuration. It then returns you a typed API for accessing them. You can think of this as a way to create a custom typed version of Tailwind or styled system. To get set up, first we call the define properties function. Define properties allows us to configure a collection of utility classes. The properties key allows you to pass scales of values to specific properties. A scale is a semantic mapping of named keys to values. For example, here our space scale has small, medium, and large keys, and they all point to specific pixel values. We can then expose our space scale via the padding and margin properties. To make things even more interesting, we can swap out our hard-coded space scale for a vanilla extract theme contract. The conditions key allows you to pass a set of conditions your property should be available over. This is normally to allow for responsive values or color scheme preferences via media queries. However, you can pass any valid CSS selector for more advanced setups. Scrolling down a bit, you can see that we're calling define properties multiple times. This allows us to set up different sets of conditions for different types of properties. Here our layout styles have screen width conditions, whereas our color properties are conditional via the user's preferred color scheme. To output our sprinkles function, we then pass all of our properties to create sprinkles. Now over in our component, we can call our sprinkles function to style an element. The type given to the sprinkles function ensures only valid properties are requested, and you get excellent developer feedback via the autocomplete. On this element, we're asking for a medium border radius and massive branded font on all screen sizes. Padding is using the conditional syntax to grow as the screen's width grows larger. You can see this in the mobile, tablet, and desktop responsive condition values. And our background and text color properties change depending on the user's light or dark mode preference. Here we can see the same code rendered across all three breakpoints and toggling our preferred color scheme, with dark preferences being on top. Opening up DevTools, we can see a huge list of utility classes have been assigned to the element. In production, this will be much shorter, as the debug information will be stripped away from the class identifier. Sprinkles allows extremely high reuse of your CSS. Also note, as vanilla generates consecutive class identifier hashes, it compresses amazingly well due to such a high degree of repetition. We found Sprinkles to be an invaluable tool for building design systems with. Now that was a really quick run through of both recipes and Sprinkles. I have no doubt you could do a full talk on both of those APIs. So feel free to ask any questions afterwards to help fill in the blanks, or check out the docs. Just to recap, both recipes and Sprinkles are built using Vanilla Extract style API and use function serialization to create mixed compile time and runtime based APIs. They are both available via separate packages and don't rely on any private or hidden Vanilla Extract features. I'm super interested to see the community come up with other API ideas to build on top of Vanilla Extract's platform. So we've covered a lot about how Vanilla Extract works and what it can do today. We went through how Vanilla Extract evaluates your code at compile time and creates static style sheets, how theme contracts can make working with CSS variables scalable in large code bases, and how function serialization can be used to create excellent developer experiences, but still only ship the minimum required JavaScript to achieve it. If you enjoyed the talk and you want to hear more about Vanilla Extract, you can follow me on Twitter @MattCompiles. Also, please check out...
Hello, Matt. That was an absolutely brilliant talk.
Thank you very much.
Yeah, and thanks for being here. We really are honored to have you here. And Vanilla Extract is absolutely a beautiful project. I'm so excited about it.
Yeah, thanks for that. Appreciate it.
Yeah, and one question, Matt. What is the future for Sprinkles? Are you planning to have some VS Code extensions or something of that sorts?
Well, I think with Vanilla, we try to lean into the TypeScript tooling, as that's what we're writing it all in. We'll see. There's a lot of proposals for new stuff to add onto Sprinkles, but it's a tricky one because we don't want to just bolt everything onto the Sprinkles API. Sometimes things should be built on top of it. So yeah, we're sort of just like contemplating about other things, but about what we could do with it. But yeah, I guess I can jump on. If you have any ideas about what the next things we should be adding to it, we can jump onto the GitHub discussions and we can talk about it there.
Yeah. Sure thing. I'd love to do that. Probably soon you'll be expecting a request from me.
Yeah.
Awesome. So guys, if you have any questions for Matt, please feel free to pitch in now. It's a live Q&A now for 2-3 minutes. And even if you can't ask anything right now, Matt will be available in the launch for discussions after the talk. So go talk to him, learn more about vanilla extract. Cool. Let's wait for a few more seconds if somebody asks. Awesome. So now we have the first member from Team Light who loves light themes, and he's my very good friend Roy Dirks. He's an international speaker at tech conferences, and he has also authored a lot of programming books. You should definitely check those out. And he also hosts a lot of workshops, both for aspiring developers and experienced developers, like experienced developers. He's quite famous in Europe for conducting workshops. He has done so many workshops in Berlin as well. Currently, he's working with Stepzen, and he's trying to make building APIs with GraphQL easier. He's one of the early adopters of GraphQL. I remember him saying that he started using GraphQL from 2016 from a hackathon, and that makes him the best person to talk about developer experience with GraphQL. He loves building things always, either with code at work or even when it's not working, he uses Legos and wood to build some stuff. So he loves building something always. And one wow factor about him I learned is that he climbed a volcano with a broken leg. So, be it the questions about volcano or about GraphQL, it's time for him to take the stage and share it with us.
Yes, thanks, Vilva. Hi, everyone. I hope you enjoyed your day so far. So for me, it's still morning, but for you, it's already afternoon. So I hope you're not too tired yet with all these talks. So let me try and share my screen. Yes. Okay, great. So today I'm going to talk about using GraphQL for a better developer experience. And one of the two things I like is GraphQL, and it's also React, and especially combined with something like TypeScript. So in this talk, I'm going to be showing you these technologies. So who's this talk actually for? I think, well, most of you are React developers, maybe everyone, and maybe some of you have used GraphQL, hopefully a lot, but probably not everyone. So this talk is also for everyone that wants to have a GraphQL API and maybe have some have some trouble in getting their backend to actually build the GraphQL API for them. So that's something I see a lot. A lot of people want to have GraphQL APIs, and then they are the front-end developers without backend skills, or they're within an organization that doesn't want to support GraphQL. So those are the two flavors I mostly see. If you don't have any limitations and you can use GraphQL in your front-end, backend, full-stack developer, please do so. If you're not any of those, then well, stick with me for this talk. I'm going to show you how you can actually combine these technologies and how they will make your life a bit easier. So a little bit about myself. You've already thought something about the things I've been doing in the past and the things I'm doing right now. And something else, I don't know if you told me where I'm from, but something I actually discovered as you had, well, this festive week, like 1 or 2 weeks ago. Where was this picture taking? So I'm from Amsterdam, and even there we were celebrating Diwali. We have a huge community of Indian people. I also work with some Indian people, so it's nice to see these traditions come to life. So if you are over in the Netherlands around Diwali, you don't see any friends or family. No, there's also a well, large community here able to support you. So about me again. So my name is Roy. I'm an entrepreneur, a software engineer, author, and speaker from the Netherlands. Like I told you, I like to work with things like GraphQL, TypeScript, React. I also wrote some books in the past. Actually working on a new book now on React 18. I saw some interesting talks about it already. Interesting discussions as well. So hopefully we'll have well, more green light about the release date for React 18 soon. Also I work for a company called StepSen. And with StepSen, you can build a GraphQL API in minutes with just a few clicks. And next to that, as Phil said, I'm also well, giving workshops through my own company, Hackteam. So if you go to hackteam.io, you can find some of the workshops or courses I've built. And for now, just stick around, or either find me on Twitter, so you can find me on @hackteam and ask your questions there, or either use the chat function we have on AirMeet. So what do you know already about GraphQL? So if we would have been in an audience, I would have probably seen a lot of hands of people knowing everything about GraphQL. But if you don't know things about GraphQL or just want to fresh up a bit, let's look at some of the some specifics of GraphQL. So most of all, GraphQL is a query language for APIs. Often when I ask people what GraphQL is, they say it's a framework, or it's a programming language, or it's JavaScript. It's none of these things. So GraphQL can be used independently of basically everything, and it's just a query language or protocol for APIs. So as opposed to REST, which have OpenAPI or Swagger, GraphQL really is a query language for APIs that support GraphQL. And what does it look like? So this will be an example of a GraphQL API. On the left side, you can see a query, and your query is your request to get data from a GraphQL API. And a query will always be sent to the GraphQL server within something we call a document. So the whole thing you see on the left is a document that has a query inside. It could have multiple queries, but for now it has just one. So our query is basically the information that we are requesting from the API. And within the query, you can see all the basics of the API. You can see we're having something called GitHub user. We're going to provide a login to it, which is some information like a username. Then we're going to be requesting multiple types of information like a bio. We have some sort of relational field like followers because it has multiple levels. You can see it on the curly brackets. And then on the right side, you can see the response. And you can see the response has the exact same format as what we saw on the left. So you can see we have GitHub user, bio, followers, and all this information is also present on what you see on the right. So this is a true specific of GraphQL. You're going to request information in a specific format, and that specific format will also be returned to you. So it's a query language for APIs, and it's also a really declarative one. And because it's so declarative, it's also what makes it really easy to use if you're a front-end developer or basically everyone that interacts with APIs. And whenever I talk about GraphQL, I came across this meme. I couldn't find the person who made it. But if you're like me, if you're maybe not 20 or younger anymore, you probably also know the Spice Girls, and they had this number, tell me what you want, what you really want. That's basically GraphQL. Tell GraphQL what you want, what you really want, and it's going to return you that information in the exact same format as you requested. And also, we started GraphQL as a query language for APIs. It also offers a single endpoint for multiple resources. And if you're now working with REST APIs or RESTful APIs, you probably know you have multiple endpoints, and all these endpoints have their own characteristics. So some endpoints are returning product information, other endpoints are returning reviews or offers or images or whatsoever, determining on the kind of project you're working on. So GraphQL is a query language for APIs, and it also offers a single endpoint for multiple resources. So every resource you have in GraphQL, it doesn't have its own endpoint, but instead you can find them all on one endpoint, which is usually the -GraphQL endpoint. And if you go back to the thing we saw before, so you can see a query again on the left side. This time we're not requesting information from GitHub, we're requesting information from Twitter. And on Twitter, we're going to search for all the tweets that have the word Einstein in. You can see we are requesting some information. You might have seen something about edges and nodes. It's quite interesting to learn about why you have edges and nodes in GraphQL, because GraphQL is all based on graphs. So if you're into graphs database, you probably saw these things before. If you're not, just try and ignore it for now, because it doesn't really matter for the purpose of this talk. So on the left side, you can see the query we have, and then on the right side, you can see the return. And if you will look here, you can see there are actually nested relationships defined. So the curly brackets, you can see whenever there's something with a curly bracket, it's usually a relation. So we have our Twitter search. We're going to search for things with Einstein in them. We have a node, and in the node there's created at text. But there's also field author, which is actually a nested relationship, as you can see here. So if we would have a database or multiple REST endpoints connected to our GraphQL API, probably it's going to look in different tables. It's going to look in different columns. It's just going to try and find the information somewhere else on where it should usually be. So for a REST-ish or a RESTful or a REST API, probably every table in your database has a separate endpoint. For GraphQL, it's not the case. So it really makes interacting with your data so much easier, because you no longer have to search through all these different types of information, all these different types of endpoints. Instead, you just have one endpoint. And then actually the most promising thing, or for me the most interesting thing about the GraphQL, it's all based on the type system. So if you've worked with TypeScript in the past, you know a type system really helps you on knowing where your data is, what your data consists of, what things you can do, what things you can't do. And if you don't have a type system, it's really hard to see what you can do with certain data, unless you really enjoy spitting through documentation. And something I sometimes enjoy, but not every day, and especially not when I'm on the clock and I need to finish something quickly. So whenever you're trying to finish something quickly, or you want to make something reliable, scalable, actually really stable, try and get a type system in there. So GraphQL is a type system for the API query language, which will already help you whenever you start working with APIs. Use the query language, rely on the type system, and being able to build stuff. So what does a type system look like? So we have the same query we saw before. We're going to get Twitter information. This time we're going to just get everything from Twitter. And then you can see we have a type system. So on the right side, you can see the documentation for a GraphQL API, which is usually auto-generated because GraphQL is a schema. In the schema, you can find all the queries you can send, but also all the types for this API. In here, you can see, I've picked out some of them. You can see we have a field called created@, which is in a date format. And you can see we also have a field called location, which is a string. It's just a regular string, as you see them in any other language. And if you haven't worked with TypeScript before, but you maybe have worked with React prop types, then things like this should also be feeling familiar to you, because prop types are also a way of React to implement a type system. So enough about the type system. I'll be showing you more about this type system later on. And I already mentioned REST APIs or REST-ish or RESTful APIs a couple of times. People often think GraphQL is a replacement to any of those things. And I try to say it's not, because GraphQL is not a replacement for anything. It can be a replacement for your REST or REST-ish APIs, but at the same way, it can also be a replacement for your SOAP APIs or gRPC APIs or any other kind of APIs you're running. So GraphQL could be a replacement for REST, but it isn't necessarily a replacement in itself, because the two can easily coexist. You can have a GraphQL API for your application doing one thing, and then maybe have REST endpoints doing something else. So it really depends on your architecture, it really depends on your backend team, or it really depends on the things you already have. Because if you already have an API in place, which is REST, why should you try and transform it into GraphQL if you can also do it automatically? And this relates back to one of the companies I'm working with, which is called StepZen. And at StepZen, we've created something to transforming REST APIs into GraphQL APIs automatically. And this is something that sounds magical because it almost is, but it's all relying on the type systems and the schemas and everything that GraphQL already has to offer. Because GraphQL, as I told you before, it has a type system and it also has a schema. And in the schema, you can find the relationships with the type system. Because the schema really is the source of truth for a GraphQL API. So if we would go back to REST APIs, you probably have OpenAPI or Swagger or documentation that your teammate or someone else's teammate. For GraphQL, you no longer have to build documentation yourself because the schema is already documentation on its own. Of course, you can extend this by building proper documentation in the form of a page. But for now, the GraphQL schema is a proper source of documentation. And by using this one as source of truth, which is also the place where the type system of GraphQL is getting its information from, you can actually create GraphQL APIs using steps. And also, if you already have a GraphQL API, if we go to the demo later on, I'm going to be showing you tons of cool things that you can use with any GraphQL API on your own. But for now, let's look at what StepSend can do. So at StepSend, we've built something called GraphQL Studio. And in GraphQL Studio, you can select pre-built APIs like dev.to or GitHub and Twitter, and combine them all into one query. So one thing I really like about GraphQL, it's really easy to combine things. So you can combine existing APIs, you can combine your own API, your own data sources like MySQL, any other type of SQL. So basically that's what you can do. You can create your own data source, you can connect them with existing APIs, with pre-built APIs we have, and then from one interface, you can just explore them all at once. So this is called graphql.stepsend.com. I'm actually not sure if the page is reachable today because if you have noticed, I'm in Europe, and in Europe we have a great Google Cloud outage. So hopefully you can find the page from India or any other location you're at. If you're in Europe, then probably you might have some issues reaching it. But if you're watching this talk later on, then probably it will be back up. So let's have a look at the demo I prepared for today. So we're going to be using two things, or actually multiple things, but our biggest building blocks are Next.js. They just released version 12, I think 1 or 2 weeks ago, and also GraphQL Code Generator. So GraphQL Code Generator is a library to generate code for GraphQL APIs. So with GraphQL Code Generator, we're going to be using a GraphQL API now built with StepSend. It can be any other GraphQL API. And we're going to be using the schema of that GraphQL API to create code for our Next.js or React application. So combining these two things, you're actually going to get pure magic because you can combine React and Next.js together. You can also combine it with GraphQL, a GraphQL Code Generator, have auto-generated types for you, have auto-generated building blocks for you, which in the end brings pure magic. So this is the GraphQL Studio I discussed. I'm not going to refresh the page. As I told you, we have the Google Cloud outage here in Europe, but maybe people use the chat to discuss if it's working for you from any other location. This GraphQL Studio, as I said, you have a combination of APIs, which we curated ourselves. We're going to be opening up this as well, so other people can curate APIs, and actually you can bring in your own APIs. We have lots of schemas you can explore. So all these APIs already have been connected, like Google Maps, Google Cloud, but also SendGrid, the SpaceX API built by Carlos Rufo, who actually was supposed to be doing a talk today, but unfortunately we switched places. Things like Spotify and Trello. But to go back to the combinations, I've prepared a demo for you today in which we'll be using this combination. So it's a developer publishing pack. Something I struggled with when I started developing was building my own APIs and actually building my own portfolio. So if you're building a portfolio, there's tons of information you can find online on how to build a portfolio. And often you have to connect with APIs from things where you do your things. So you either build your own API, or you're actually going to be using APIs from DevTo if you're a blogger. So if you put blog posts on DevTo or Hashnode or any other platform, you can connect with API. Also, if you're working with GitHub, you're publishing open source libraries there. Maybe you're working for your employer there. Maybe you build your own pet projects on GitHub. You can connect with their API. And if you're active on Twitter, you can, of course, also connect with their API. And normally, when you build a portfolio, you would have to connect all these APIs separately. You're going to have one API request to get your blogs, one API request to get your code examples, and another one to get your tweets or maybe any other social media information you want to have in your blog. But with this GraphQL Studio, you actually don't have to do this anymore, and instead, you can just combine them all together. And if you combine them all together, you can do them from the studio. You can use mock data as well. And what it will give you, it will give you a GraphQL endpoint. And this GraphQL endpoint looks like this. I'm just going to copy paste it and I'm going to show it to you. And on this GraphQL endpoint, you can basically see GraphQL happening. So this is a GraphQL endpoint. It's going to show it's the GraphQL playground. So what we saw here before is GraphQL Studio, which is a product we built. And then on that GraphQL endpoint, you can generate from there. It's actually going to show you GraphQL Playground. GraphQL Playground is an open source project. It's maintained by, most of the core maintainers of GraphQL itself. And in GraphQL Playground, you can play with GraphQL APIs. You can inspect them. You can see what they're built of. So you have the documentation we set. You can see its type system, all the types that are in there. And you can also try out the different queries. So this is a query I wanted to try out today. See, it's not complete, so probably we need to get some stuff out of there, which we're not using. So it's better. And for now, I'm actually using mock data. You can perfectly well fit in your own bearer tokens for GitHub, for Twitter, for DevTool. I didn't do it right now because I don't want to expose my my environment variables to you, even though I really like you all. I don't want to share my environment variables just yet. Maybe it's some later stage. So on the left side, you can see a query. On the right side, you can see the response. And you can see we're getting a lot of information. So we're building a portfolio page. And on the portfolio, we want to show our blogs. We want to show our GitHub information. We also want to show our latest tweet. And this portfolio we're going to be building, you can use it to show to your friends, to your family, or maybe even to the new job you might be applying to. So we have our main query. We have a username, which here it's Cersei, but it's just mocked. And Cersei is a coworker of mine. We're going to get a name from DevTo, which is our blogging platform. We're going to be getting a summary from our blogging platform. We're going to be getting our Twitter username. Going to get some pinned repositories from GitHub, and we're going to get our pinned tweet. So if you're using Twitter, you have this tweet you can pin, which is basically either a tweet in which you present yourself or just a really popular one. And by doing this, you make it easy for people to see their information about you. And we're also going to get a list of our latest articles on DevTo. And this information is coming from 3 separate locations. It's coming from GitHub, it's coming from DevTo, it's coming from Twitter. But you combine them all in one query. So no longer as an end user, you have to call 3 separate APIs. Instead, you just call one GraphQL API, which is this one. Using this query, and it's not really doing magic, right? Because GraphQL is just a way to do HTTP request over the internet. So if we will be looking at a network request, you're going to be seeing it's just a HTTP request. It's going to /GraphQL. We're sending in some information, and we're also sending a body. And in the body, you can find a query, which is basically this query. It just has some parse strings. It's just going to encapsulate some things in order our browser don't break. And then it's just going to return the information like this. So it sounds really magical, GraphQL as itself, but in the end, it's just a way to communicate with APIs over the internet. So we looked at our API. We now know what query we can send. So now it's time to actually see what this would look like in an application. And this is probably big enough for you. So let me see what we have. So we have a Next.js application. We have some basic building blocks in there, some divs, some H1 titles, some links, some other divs. And what we're doing right here is, if we go to server-side props, we're going to be calling our GraphQL API endpoint server-side. And it's important to do it server-side because this is a public API endpoint. But if you don't have a public API endpoint and you're going to be having environment variables, maybe you did have that GitHub token, which we discussed before. If you don't put it server-side or static side during build time, you're going to be exposing information. So if we would be calling this GraphQL request from a React component directly, so on runtime, you're going to be exposing secrets to people that might be looking at your network tab. And it's something you want to avoid at all times because you don't want people hacking your GitHub or hacking your Twitter or doing any other freaky stuff. So it's important when working with React always to do server-side requests in case you're exposing any secrets that you don't want to expose to other people. So we're going to be sending a request to this API endpoint. We have our queries defined. So this is the exact same query that you saw before in the browser playground. We have our DevTow information, we have our GitHub details, our Twitter username, or our tweets, and we'll also be getting information from there. And I've created this in a separate file for later on because we'll be going to using GraphQL code generator in order to auto-generate our code for us. So in our index file, we're going to be calling this information. We're going to be using Next.js. We have this get server-side props method, and from this we return prop information. So our data will be returned, and from our component it will be readable. And then we could just start up this application, and then I'm supposed it will be working. Yarn dev. Where my browser is at. So we have a GraphQL API endpoint, and then we have our local host, which is basically my portfolio site. And as I told you, it's all mocked information. So this is mocked, this is mocked, this is mocked. Even the username is mocked. This looks like it might be Latin, or maybe it's just lorem ipsum. So this is all mocked. Let's stop this one. And now I'm going to show you, because this is already cool. We have GraphQL, we have this query that's combining all our information together. But something I didn't tell you just yet is that we're also using TypeScript. And one downside of using TypeScript with any GraphQL or any other API actually is that you don't have the types for your API request. So I do a request here. My return is going to be any. It's going to be going to props, and my component is any. My component received the props. It still thinks data as any. So I have literally no clue because it's all any. If something will render, right? If I will do this, I will post this to the internet. Probably nothing will render because information might not be there. And then, of course, you can type your own data. So this is probably what all of you do. I do this in the past as well. I'm going to create a type here. So data. I don't know, what does it have? It has get user. Okay, so it's DevTow get user actually underscore get user. Okay, it's probably also nested. Oh yeah, I have a username there. I'm going to be putting my username. It's a string. Okay, so now I've just added one type. Let me see what else. I got another query as well. Should I be adding it here? Probably I should. Okay, so this is an array. It has more information in there, I think. So let me find. So you get to do it right. This is pretty annoying. It's not something you want to do. You don't want to write type definitions all the time because it's going to cost you a lot of time. And also, if we change things, if we change a query and instead of username, so let's go to a query. Maybe we don't want a username. Maybe we want to get our Twitter username instead. Okay. So now I need to change username. I need to add Twitter username. Oh, wait, I didn't copy that. Twitter username. You see, it's going to get pretty messy because you're going to be creating type declarations all the time. So this is where GraphQL code generator comes in, because I already told you we have a type system in GraphQL, we have a type system in TypeScript, and let's find a way to actually combine them. So for this, I've installed the GraphQL code generator. Just a couple of things I installed. So I installed GraphQL code generator with its CLI. I've installed something for GraphQL request because instead of a regular fetch request, I'm using GraphQL request to do my GraphQL request for me. And then I have TypeScript operations here. So these are all the things in place. The code generator, which is this. And then I will be able to do yarn GraphQL code gen, which is the request for the CLI. It's going to start running. It's going to do a couple of things. It's going to load my GraphQL schema. It's going to load my documents, which are the queries that we see here. And then it's going to generate my TypeScript definitions. And this is taking longer than it should be, which is basically my own fault, because in here I have to find that my definitions are in TypeScript files, which basically means it's going to look for all my TypeScript files. So this takes a pretty long time. Okay, but I've generated the outputs, I've parsed the configuration, and now the really nice thing happened because this file has been created. It's called generates, and in here it's mapped all my GraphQL types to TypeScript. So if you can see here, this is all my custom types for my GraphQL schema. In here, if we're going to start looking for our queries, so we had a query called devto get underscore user. Copy paste it for you. And then if we would find it here, we can find this query. Oh, this is not the query itself. There's some other queries. Yeah. So in here we can find devto user, which is a type which is created from our GraphQL schema. So you have the schema here, the query. You can also see we have get user. So this is a GraphQL type. This is a GraphQL type, and in here you can see it's being transpiled to TypeScript. And by doing so, we are able to actually use this inside our app. So if we would be looking here, data, it was undefined, but let's see if we can find a type for it, right? Because what is this doing? It's sending a request with this query. And this query is called steps and queries. So it's also present in this one. As you can see, it's also here. So we are able to import it. Let's try and import it. We're using TypeScript, so it should be able to find it. Let's just write it out. Steps and queries. See, yeah, so this is our type. And now we actually know we have a type defined. And then Next.js is sometimes a bit stupid, so we should actually tell Next.js every data type actually is steps and queries. Query. Cool. So now we actually have the TypeScript autocompletion and we have the type system, because now we're going to see that devto get username is a string. This one, it has the summary username. If we would go somewhere else, so if we want to map over our different articles, we're going to be seeing article is an array. We're going to be seeing it has a title, which is a string. It's going to make life so much easier. And every time you change something on your queries, you're going to be adding fields, you're going to be changing fields. You can just run the code generator again. And it's going to generate new GraphQL and TypeScript types for you, which is pretty cool, right? So if you want to find this example and any other steps and examples, you can go to github.com/stepsandsamples. If Google Cloud is being nice to us again, make sure to try and find the GraphQL Studio on graphql.stepsand.com. And also, I'd like to say thank you. So if we go over to the contents of this this talk again, you can find me on Twitter. You can find the studio here. If you want to know more about my workshops or courses, go to my own website. And if you want to start using GraphQL together with TypeScript, have a look at the GraphQL Code Generator, because it's going to make your life so much easier. So with Code Generator, it was the library we used to auto-generate all the types based on our GraphQL schema in TypeScript. And you can use it with React or Next.js on the front end, but you can also use it on the backend side. So if we're bringing together multiple GraphQL APIs into one API, it can still be useful, because if you want to have a build it your own GraphQL API, just use Code Generator in order to also generate the code types on the back end. So that's basically it. I hope you have some questions for me later on. I also hope you check out the studio and let us know if you like it. And please also find me on Twitter. So that's it for now. And well, I hope you enjoyed, and I hope you will have some nice questions for me in QA. Thank you, everyone.
Thank you, Roy. That was an amazing talk as usual. And guys, Roy will be available in the launch for any questions you have. So feel free to hit him up. He's a very good guy and he answers patiently. And thanks for being here, Roy.
Thanks, everyone.
Bye.
Bye-bye.
So.
React India.
All right.
Hello, guys. So, the next talk is by a speaker from Team Light. He is Radoslav, and he's the head of engineering at Product Hunt. He has been a full stack developer for 19 plus years now. Like, imagine, guys, how much experience and knowledge he should be having. And he enjoys blogging and solving problems a lot. And personally, I follow only a few blogs or few personal blogs of developers, and he is one among them. Everybody do check his blogs, and it's really useful. He is also organizer of VarnaConf, and there is an interesting thing about this conferences. He just started it as a small conference, which is going to happen just for 1 week, but then it just got exploded, and he ended up conducting it as an IT tour of conferences, and it happened in 4-5 cities. You can find him usually with books, audiobooks, and then test email 50,000 people with just one.
Stankov, and I'm joining you from Sofia, Bulgaria on this recording. Today we are going to talk about Product Hunt React architecture. Currently, I'm the head of engineering at Product Hunt. A lot of the slides are going to contain code samples and things like that, so I have already uploaded it to my speaker deck where you can find my talk notes. So architecture. So that's the main thing we're going to talk about today. And in order for us to understand the architecture, we have to understand the context of the situation, of the things we are experiencing. So Product Hunt is mainly a website. Right now it looks like that. It lists the best new products released every day. And it also had a lot of other things around it. The Product Hunt architecture can be simply redrawn out like this. We have a domain logic which lives on top of React on the web and React Native on the mobile. We connect through Apollo via GraphQL API with the Ruby on Rails where the backend logic lives. If we are going to see how a request is going to flow through our system, what happens is there is like a browser hitting Cloudflare, which hits Amazon, which then hits the front-end application, which is the Next.js app we have. The front-end app calls via GraphQL the backend, and the backend, depending on the situation, can read from a cache, read a database, return JSON, and the front-end can return an HTML response. For today's talk, I'm going to just focus on the front-end part and particularly the React portion of our front-end architecture. Our front-end tech stack right now consists of React, GraphQL to Apollo, TypeScript, Next.js. We also use Prettier and Jest and CSS modules. So let me walk through how all those technologies are combined for us to have like a reliable architecture. A lot of the things with React is that if you start with React doesn't give you much context and doesn't have a lot of architecture. So often when you just start coding from scratch, you might get into the situation where you cannot move. And in order for us to design a system, we need to see how the system is going to work and evolved. We have this saying that Product Hunt moves fast and have breakfast. And we're, again, a startup. We have to iterate fast. And for us, those are the 5 architectural principles that guide our decisions. We want to have good defaults. We want to have good code organization. We want to make the common operations easy, the things that a developer is going to do every day. And we want to isolate dependencies where, especially in the JavaScript world, things change so fast that it's good for us to isolate those. And again, focus on extensibility and reusability. But the most important thing for for us is to make the common operations easy, things that every developer is going to do every day. But talk is cheap, so let's look at some code. So throughout this presentation, I'm going to walk you through this page, how this page, which is the profile page of my account, is structured. So in order to understand how the page is structured, let's open the folder which contains our frontend tab. And our frontend tab has all those folders, and those are a lot of folders. But if we have to think about them, there are just three buckets of things. There is support, there is components, and there is pages. And the way I think about it, this is a pyramid where you have a big supporting layer, which is the utilities you have. Then you have the React components and the things that are built there, and those things go into pages because we build websites. This is a more funny representation of this. Think about it like the pilots get into the lions and the lions combine into Voltron. So if we look at our folder structure, if we color coded support of those things here, components is just components, and pages is the red part. So let's go first on the support side. On the support side, we have the config TS. The whole everything which is related to the product configuration is handled here. Next.js, which our system is built on top of, provide this get next config utility. However, for us, we don't want to use this thing across our whole system. So what we do is we have this config which just exports useful variables like environment. Are we testing? Are we production? Is this like a browser process? The GraphQL folder is the folder where we put all the auto-generate, get the GraphQL schema, combine it with the queries in your applications, and get for those types. And this allows us to have type safety across our system. And this is one of the most magical things which we have, and the things that allows us to be fairly safe and feeling very confident in our front-end changes. The second folder I want to go through is hooks. So hooks is something right now quite old in React. It's a couple of years old now. And this is something we are very heavily using. We have a lot of utility hooks like useKey, which is used to say when some key of the keyboard is clicked. We also have useIsMounted to check if the component is mounted, use timeout to trigger timeouts. We also have nice hooks like useHide on top. This is like a hook which triggers when the user has scrolled to the top, usually used to hide different elements. The nice thing about hooks is you can combine them. Like we have a hook which is called use GraphQL fragment. And this hook accepts a GraphQL fragment and returns its contents. From there, we build another hook which is called use viewer, which gets the currently logged in user data. And we abstract this away into a hook which is called use is logged in to check if the current user is logged in. Two other folders I'm just going to glance at are the server and static. Static is something with Next.js to just put like static assets there, nothing interesting. Server is a custom Next.js with Express front-end server because we need to do a couple of interesting things there, but they're out of the scope of this talk. Styles is where we put our main configurations for our style system. I'm going to talk a bit more into how we use CSS modules to group styles later in the talk. And types is the most reusable types we have in our system, some TypeScript utilities that are used across our board. And utils are utilities. And the utilities is the folder where we put pretty much everything which is not in other folders. Something, for example, is we work with a lot of dates. So we have an utility which is called util dates. And it's just, and from there we just use our own date format, so they're consistent across the system. Also, the nice thing is we don't ever import the dating library directly in our code, we always go to date.ts. So before we used to have this library called moment.js, but over the time moment.js is too big and we didn't use most of its features. So we replaced it with date.fm without changing anything in our system. A lot of the utilities we do are wrappers around external dependencies and dependencies that we don't care. Another thing in utilities is called external. Unfortunately, we live in a connected world and we have to talk with a lot of external services like intercom, one signal for push notifications, segment for tracking, or sentry for exception tracking. And usually people scatter the code about the external libraries and external places that they use in the system all over. What we have as a rule is that everything which is not from our core system goes into util external. In this way, it's very easy to trace and see which are all the external library and JavaScript we load on our pages. The second part is components. It's a single folder, but it will be a big chunk of this talk because it's a React talk. So I'm going to walk through around a couple of the components. So what we leave in our components folder is components that are used in at least 2 places, aka things that are reusable. So what we use is we use component as directory pattern where everything in components folder is considered public, and we have a folder for each component. This component. The way we structure those, the idea here is we are grouping changes together. Like everybody knows, okay, if it's component index, that's the thing I have to care about. Anything inside of this component is considered very private. One of our most used component is text. We have our own design system which defines, okay, this is the font size, the font weights that we are going to use in our system. And we have a component called text. So this is the component that represents the text. And it's a very simple component, or at least it started simple. The way we use, right now we use CSS modules where it allows us to combine CSS classes. We just import them and use them and just have unique class names. So the code from this text component would render this. And a couple of features we have is that sometimes we don't want the text to just be spam. Maybe it's a P. And this is the implementation here. In this way, we can put this. Sometimes components accept class names for extra extensibility. So from here, we just can pass the class name and we use this small utility called class names. Sometimes the text component might need a couple of other things. Like for example, it might require that the text is a button. Like just a text where you click it, it acts like a button, or you have a text that's a link. So we have those component packages here, text.button and text.link. Before, we used to have text as button and text as link, but this was causing a lot of issues. The other thing which we spent a lot of time thinking about is forms and how to deal with them. As every web application, we have quite a bit of forms, and we have a standardized form library that we built. And this is how a regular form on Product Hunt looks like right now. What we have is we have a form mutation. This is a GraphQL mutation. We passed the mutation, we passed on complete handler, and we passed form fields, and the field has a name, and it has different controls. And the other thing which we encapsulated in our form is not only the looks, but the activities. Like every form has a couple of states. It has the input state where the data is entered to the form. There is a loading state where the form submits to the server. It has a success state when the form is submitted, and we have error state where there is some validation error on the backend. So the submit, server, success, and errors is something that we have standardized, and we have a standardized error format that every GraphQL mutation we have in our system returns. So in this way, all our fields can map to this format. And in this way, every mutation in our system can be an argument to a form, and the form can automatically know, okay, this is the thing I'm saving, this is the errors, this is how to map the errors to the fields and things like that. Another thing which we have in our form library is custom controls. So we just use the standard hooks to define form components, and we can build quite complex form components like this one, where the idea is this is a very complex component. It uses a lot of other components, but it presents like a unified topic speaker. And again, we built our form library as a wrapper to a well-existing library. We haven't built our own handling of the form validations and things like that. And in React world, there is like two form libraries that are quite popular. One is called Forming and the other is called Final Form. And what we use right now, and if you use any of those, you're good. We use Final Form because it fits our working style a bit better. And what we have from our form is we have a unified style system. We have a common interface for the form. We support custom input, and our form understands the backend GraphQL. And it wraps the existing form library. So if we want to change our form library, we can change it. Change the form engine below it without changing the main forms. And that's something quite useful because we have changed our form engine a couple of times throughout the product's history. The other common thing which we have in our components is the buttons. It's one of the most used components after text. So our buttons are like a Swiss Army knife of functionality and style. So the naked button is just plain text, and the button can be a link. The button can take on-click handlers, and those on-click handlers, if they return a promise, the button cannot be clicked twice if this promise hasn't resolved. Also, our button accepts a bit more complex logic like confirmation, like, are you sure we want to delete this? Connecting it with the GraphQL API and handling, okay, after the GraphQL mutations, this is what we should do. The other thing we have with our components, the button is having different style packages. Like we have button.primary, button.secondary, button.line, button.small, and those are the core button components of our system. So we have the button, the main button is just the main functionality. And to be honest, the native button is just this one hook that's called use on click. And this use on click hook can be used in other components as well. And it can accept quite a bit of functionality, like it can say required login. So if you click on the button and the user is not logged in, we are going to show you a model. Also, there is some things around tracking, optimistic responses and things like that. So the thing you have to think about with us is the way we have our component system, we think about it utility, stylist, and domain. And the hook is the utility, the styling is the button packages, and the domain is the next components I want to talk about in the talk. And this is one of our most iconic components, is the vote button, one of the main interactions done in Product Hunt. And the vote button is a component that wraps the button component. And the idea of the domain components are that those are components that are related to the business domain. They are not just like naked shells like the button. So the vote button is living inside of another component, which is called the post item component. And the post item component is using a button and the like button. And the domain component is the component which is called post list. So this is a component that lists posts. And the components are just flex row components. And flex row is a component that wraps the flex functionality. The post thumbnail is a domain component that renders the thumbnail. We have a flex column, which is the main part, in the flex column, we have the title, we have text component, which is title, subtitle. We have the post comment, which is still a button. We have the post button. So those things all nest. And some people may think about this kind of sounds like atomic design. And I would just say just kind of. We don't think about in terms of atoms the way we just think about our components. Our generic components and domain components. And generic components are the ones that are just utility like button, form, and things like that. And domain are things that are related to the business domain. And the final thing I'm going to talk about today is pages. So for the pages part, the first thing we have is called path.ts, and path.ts is just a simple export of all the routes we have in our system. So we don't just type strings to get to paths, because this breaks quite easily. This is something we just have in our system where you just import the paths, and you can get path root, you can get to static pages, you can get profiles and things like that. And it's a very nice utility because combined with TypeScript, it adds a lot of value. Layouts are the shells of the main pages, and they can also be nested. So on the profile pages that we started with is a layout where the blue part is things that are just plugged in, and the other thing is a shell. And that layout lives in another layout that's the main layout, which is just the header, which every page on the site has. So, and the layouts are the thing that wrap the pages. So something notice here, we have pages and screen. And what's the difference here? So what's the difference? Like, why do we have pages and screens? And the reason we have that is due to Next.js. The way Next.js works is that it uses file-based routing, and everything that's in pages is exported as a route and is accessible. And the way things work is if you have a file that's pages, profile, select, index, what we do is we don't render any React components there. It just imports a component from screen that maps more into the domain logic. And the reason we do that is because a lot of the pages have their own private components, their private styles and things like that, and we don't want them to leak. Also, often the pages, how the URL for a page is presented, it's different than the domain logic of grouping of pages. So that's a workaround we have done throughout around Next.js. So for pages, so the way we structure pages is we just nest them according to the domain. Pages can have a lot of subcomponents. Those are always considered private and can be only be used on this page. A lot of pages have a GraphQL query and an index page where everything starts. So for this page, let's go through its life cycles. So the page life cycle is we have a loading state, we have sometimes an error state, which can be like server error, there's not found a resource, like if you go to the wrong, there can be authorization errors. There's also, like in the good state, we have the loaded state, and for the loaded state, we have multiple things happening, like setting up SEO, analytics, and other part, and then rendering the page itself. So there is a lot of common operations here. So what we did was we created this utility called create page, and every page in our system uses this utility. And this utility is built around GraphQL. It loads query, puts its variables, handles all the load state, error states, and things like that. Also, this page can also be type safe by passing generic GraphQL type, like importing the page profile. We can make sure the data that flows through this page is the expected data from the query. Also, this page utility we can describe that this page requires a login, requires certain permissions, it may be feature flagged. We also have the SEO friendly things like, okay, maybe we get the SEO tags, maybe we have a fancier title and things like that. So this create page utility is the thing which powers every page on the website. And it's built a lot around the GraphQL part. And if you think about this page, it's not a single thing, like it's built with multiple layers. Like if you think about the GraphQL part, there is the profile, layout, header, and this is the data for the header. There is the profile layout sidebar fragment. There is the main profile page data. And if we dig down, the header actually requires an avatar fragment. The show page part requires the post item fragment, and the profile layout, sidebar info fragment, and the comment fragment are needed for the main sidebar. And that's one of the best things in GraphQL, is that you can have a query and the query can use multiple fragments that are referenced and nested as a tree. And in the end, they are considered into a single query. And this is how the profile page query looks like. We are importing 3 fragments: the meta tags, the post list item fragment, the profile fragment, and that's how we load all the data. And the nice thing is the page doesn't need to know what the layout needs. It just gets data passed down to the layout. And in this way, for us, it's very easy to move components around and change the whole infrastructure. And this is how our architecture is set up, all the small pieces and all the things that make our system to work. And for a quick recap, one of the main takeaways of our architecture is that we redid our architecture like a year and a half, 2 years ago, to be GraphQL first. Like everything is powered by GraphQL on the backend, and every component understands GraphQL. And what we have done is we have wrapped a lot of the things. So for us, it's very important to isolate the dependency. We don't just willy-nilly use external libraries. They're always wrapped with something so we can replace them later. We used a lot of directory as folder pattern, and we are separating a lot of the impact of our components. We use a lot of, we call them domain components. Those are components that combine a lot business logic and a presentation. And we build our pages system is built around Next.js. We have this nice paths helper, which is basically just an export. And there is layout system and the create page utility. So yeah, thank you very much for attending my talk or listening it on a course later, and have a great conference. Bye bye.
That was a brilliant talk. That was a really brilliant talk. I learned a lot through it.
Thank you. Glad you like it.
Yeah, and we have some questions piled up for you. How do you measure front-end performance in Product Hunt?
So the way we measure front-end performance is we use the Google Lighthouse. That's like a general tool we use. We also have like a service which takes the Lighthouse performance of a couple of the more critical pages and runs the report for just health measures. We also sometimes, depending on the developer, they use the flame graphs. The other thing which is very useful for us is dependency maps, like building all the bundle sizes, because a lot of things related to performance we have noticed are the bundle size. Like we are very careful of how big is the bundle and how to split things, so the main bundle has all those big things and all the dependencies are isolated. Because what happened a couple of times is we use like a small function from something and it imports like 2,000 lines of JavaScript that just stays unused. So those are the main things we use for performance.
Awesome. That's a good thing. So the next question: is it a good practice to use tailed components or regular SaaS performance wise, which is better?
I mean, it works. Like we actually have SaaS in some new places where we are experimenting with it. Like the performance is mostly around the development speed, which it's almost negligible if you use CSS module with Spot CSS with SaaS. And in the end, they are the same. So yeah, does that
Oh,
answer the
cool.
question?
Yep. Thank you. And is it good to put all the assets in the public folder? The next one.
I mean, we don't use a lot of the public folder. The most things we use the public folder are, for example, in order to verify to Google that you own this domain, in order to verify for Apple or different providers, we need to provide like static files hosted on the root. The place where we put most of our static assets is S3, which we have Cloudflare in front of them, so we cache them and they are really fast to get. And the second thing we use for our static assets, mostly our static assets are images, so we use a service called ImageX, which is a CDN plus resizing based on like params. So we have like all the optimizations that comes with the images. Like for example, Next.js have these great features regarding like image optimizations built into the, like 2 versions ago. We use none of that just because our image provider even provides a lot better integration with that.
Got it.
So we use ImageX. It's called a service. I will just send the link in the chat.
Yeah, that would be amazing.
Yeah, I'm a big fan of them. Like they have some awesome features. Like one of the coolest features is they can automatically convert the image format from, like, let's say you have a PNG, but the browser supports WebP. The image is converted on the fly, so it uses the optimal one. And on iOS, for example, when you don't support WebP, they just fall back to that. And they have other cool things like that.
Awesome. So yeah, we have more questions, but unfortunately not much time. So guys, he'll be available in the launch. Go buck him up and get your questions answered. And thank you so much for being here and giving us such wonderful talk, actually.
Thanks for having me.
Yeah,
have a
and
nice
guys,
day of the conference.
Yeah, sure. And guys, like, feel free to check out these booths of our sponsors. They are also giving up some prizes to give away. So yeah, see you in the next talk. Awesome. So the next speaker is someone who moved from dark theme to light theme. He is Obina, and he describes himself as a human before anything else. Wow, that's amazing, right? He mostly works on the web and loves to teach concepts in JavaScript. And he also advocates a lot for web accessibility. Of course, he describes himself as a human first. Occasionally, he's a poet, and also he told me that he recorded, produced, and distributed a poetry all by himself. Oh, that's a huge effort. And in the weekends, you can always find him making short films about history or poetry. And guys, if you are into cocktails, Obina is learning to be a bartender, so make friend of him. Right now, he's going to amaze us with his talk. And over to you, Obina.
Hello, everyone. I'm just going to share my screen so I can get going. And yeah, hi, everyone. So today we're going to be talking about life on the edge. Wait, gonna check this. Okay, I am muted. Yeah. So today we're going to be talking about life on the edge, and what does this mean? You might be wondering. So I consider myself a very curious person, and I've always wondered, like, when we deploy serverless code, where does it all go? Like, what happens to the code where it goes to? Does it make friends? Like, does it stay in one region? And usually, like, my introduction to serverless was when I got into like the Jamstack, like building with the Jamstack and just focusing on front end, writing like my front end code as I always have. And I'm sure that this is like most other people's introduction to it. If you were not part of like the server migrations and everything, if you're just a front end engineer like myself, you would be wondering like, what is serverless code? Like, what happens to it? But now that we have these superpowers, we just use it. But because like I want to know more and I'm more intrigued like the user experience of people and how people experience the technologies that we build. I always wonder like what happens to the code where it goes to. So my name is Obina, and like I've already said, I'm a weekend like filmmaker, like to make films on the weekend. I just walk around London with my camera. I'm also a developer advocate at Cloudflare, and um, I like to define myself as a sentient water field carbon life form, which essentially just means that I'm human. And because I feel like it's always important to remind yourself of like your own existence, so that when you're building stuff, you also know that people that are experiencing these things are also humans just like you. And if you build stuff for yourself, then you would also try to improve it and reduce the stress that it causes. So therefore, improving the life of other people. So serverless. If you're like me and the first time you heard serverless, you're wondering, is it a cloud? Is it like, what does it mean? Like, are they no longer servers? Do I need to like not ever have to walk into like a cold room to see like servers anymore? Is it like if my plane is flying and would I hit like some servers on the way? Like I'm not exactly sure what's going on. And I know there were a lot of talks about what serverless is, where the information gets stored, how people are giving talks on what exactly to define this word, because it's serverless, but then it's someone else's computers, which is really weird to hear at first. But essentially what it means is a man-made cloud, and this is just like Latin for homogeneous, which essentially means man-made cloud. So what this means is it's not the absence of servers, it's just the absence of you having to worry about where those servers are and how they are being managed. You're just worrying about your code. And essentially this is where we all started from. Like we started the term serverless started from somebody having like a bunch of servers, a bunch of wires in their basements, and coordinating all of these like end points and making sure that it's cooling and making sure that things are moving as it should. If you've seen the Netflix series Startup, you would see the lady with her servers in her basement, and because she was mining Bitcoin, which is like something different. But the point is, these servers were essentially made for the radius on which they were, the premise at which they were, and people could only access them like directly or from that space. And then from there, we moved on to these kind of cool servers, different data centers. Everyone had like this cool blue lights and everything. Even though I'm not sure this is how servers room look today, I feel like this person just made it look nice for an Instagram photo. But still, this is where we got to, and now at this point, we've gotten to this place where it's no longer just in people's basements. These are replicated across different regions or different places because they have to cover the radiuses of which they are in. But then to understand like where we are going to, we need to understand where we are coming from. And this is a clip from Back to the Future, which essentially means that let's go back to like the past a bit to see where we are coming from and to appreciate where this technology is heading towards. So we need to look at where it all started. When we first of all started like using servers, we had the on-premise servers, which essentially was like maybe an Intel machine, a box that people would buy, but this box cost like a lot. People would buy these boxes and keep, and like the first picture we saw, the more you grow, the more your users grow, the more you're integrating servers and services and using these services to make you're a new startup and you just bought your first server, but the truth is you're only going to get like maybe 20 users, but you've paid that large sum of money for your machine, and you're spending money without like knowing how the money is being you're getting like profit back from it. So that there's a lot of confusion there. And because these machines were really expensive, there was a problem that needed to be solved. And as human beings, we keep trying to solve our own problems. Like we keep every innovation is a new problem to be solved, and then new solutions come with new problems. And then we moved on to what we call infrastructure as a service, which stopped services like DigitalOcean um, provide. So what DigitalOcean essentially does in a nutshell is they say, okay, cool, don't buy your own servers. We have the servers. Just come manage your infrastructure on our machines, and then we charge you per hour. So we charge you per hour, which is less cost than the machine. So we solve the problem, but then the problem increased to, if you're charging me per hour, what if I don't have like more users in this hour? What if like I don't even have users at all, or if I have like more in an hour that I'm not paying for? So now that's a new problem. And then we move further to like platform as a service, like Heroku, for example. We've used like Heroku and Heroku says, okay, cool, just manage like a part of your infrastructure. Would handle like other things, which is still like per hour billing. And then because like I said, we're very curious species. We've said, okay, how do we solve this problem further? And we came up with the concept of functions as a service. So functions as a service like came at a time when like the world was like, wow, okay, I can just focus on my code, write my code, and deploy it to someone else's infrastructure, someone else's space, and then this person handles my requests as they come. So I only pay for every time somebody pings this service. Sounds like a good deal, no? And then we ran with it, we built stuff on top of it. Most of the stuff that we are using right now are functions as around costs per request. But the heart of everything that we've done is to improve the user experience. Um, solely focused on user experience, but the heart of what we're trying to do is improve the experience of like our own experience while building. And this is fine, but in the heart of every business, there is the business model or the goal or whatever you want to like call it, the tagline, essentially summarizes into this sentence: like you want to deliver high quality experience to your customers around the world with low latency, because the lower the latency, the more people would want to use it, because people don't like slow products. Even if sometimes like the internet is just terrible, people don't even want to blame themselves, right? And you have to understand that everything that will break will break. Everything that can break will break. So essentially, if you're managing like your own infrastructure, saying, okay, cool, I don't want to move on to any other like modern like services, you're then carrying a lot of headache to yourself, and then you're not focusing on the things that can break, like your user experience. How are these functions like defined properly? Are they in regions more than the one that you are deploying to? There are a lot of things that you're not thinking about, but they can break, and surely they will break. And you don't want to be in this kind of situation where say, for example, you scaled and you're using function as a service and you deploy to certain regions. Say you deploy to an EU server or like a US East server, and you're like, yeah, cool, that's all. All the other users in my company, or all the other users that I have that are not like part of my engineering team, because all you've done by making those deployments is you've saved yourself money with the per request, and then now you're just like, yeah, cool, anybody else that's using this services can worry about themselves. Even though you're not saying this explicitly, what you're saying is, I've deployed to these two regions and everybody else can. Yeah, essentially it's not my problem. Like, I'm sailing on the part of the boat that is not sinking. But the fact is that user experience is essentially important to the development of your application. Now that I've said all of this, let's look at like the first gen of serverless, right? Like when we started, I like to think of it as like the first generation of when we started functions as a service. And you can see that we had like more standardized containers. We had like regional based deployments, and more a more like suitable kind of billing. But at some point, it becomes a bit complex. Like you start to pay for things that you don't essentially understand, but then the bill comes and you're like, yeah, it's probably saving me more money than running my own server, so therefore it's probably right. Like, have you ever gotten an outrageous power bill, a utility bill, and you're just like, this makes no sense, but oh well. Like if I go there, I'm not sure. So I would just like pay the bill and just forget about it. But let me tell you about the next generation of serverless. So the way I see like the next generation of serverless, and this is not even next generation because like the future is now, like it's happening right now, right in front of our eyes, and the next generation of serverless that I see or that's most users are experiencing is it has better user experience with like embedded into it. You have like global deployment, so you're no longer just focusing on users in your highest rated request sections, and then just saying, okay, every other person can, we probably get like 2 pings a week, so yeah, just forget about it. They'll sort themselves out. And we also have lower latency with this next generation of serverless. And how do we get to this lower latency? I would explain like later on in this talk. But we have something called predictability. So you can say that, oh, if I'm having like users surge in this place, it's possible for me to reroute them to a different um, server that's closer to them, and not like, okay, if I have a lot of requests coming in from this US East server, then I will route them to Europe. That's like saying if you're going like a direct, say Dubai to India, I would reroute you to the US first of all and then send you to India. That's like the closest airport and just taking you to a different place, which is how like requests usually behave. So just a bit of a recap. We've spoken about servers, like on-premise servers, and we've spoken about virtual machines, which is the infrastructure as a service, and we've spoken about serverless, function as a service. But the next generation of serverless technology is moving towards originless. And you might be wondering, originless, like what does this even mean? Now, imagine a world where like your servers were closer to your users. And even when you deploy, you're not deploying specifically to a region. You're deploying to like a bunch of like computers all around the world that will serve your information to your customers as they require it. And you might be wondering like why should I care about this? And I always like when people ask me, oh, why should I care about this? There's always this need for the what's in it for me factor. You should care about this because like you want your users to experience things properly in the way that you intended it and not just leave everything up to chance. Yes, you're saving money, but at the same time, you need to understand that users are at the heart of the product. Now, let me tell you a little story. I grew up in Nigeria. I'm currently in London, where like the internet is faster. But I grew up in Nigeria, and if you're like me, you probably experienced like slow internet, and you're further away from the servers, and like you're using like the internet is just terrible, and it's very expensive as well. So imagine like trying to get like information from like a site or get a blog post, and then I'm sending a request from Nigeria to like a server that's in Norway, for example, and then that request is going to take time to come in. Note my internet is slow. I'm losing money because it's very expensive. And that's not the kind of like experience you want your user to have. But this is like the kind of experience that I had living in Nigeria, trying to ping certain sites, and it's not. It wasn't the best experience. I'm sure that you can relate. This is like a pictorial representation of what that request would look like. If there are only like 5 servers around the world, once people like ping a certain one, you can see like the time it takes to get those requests from where from the point of where the information is to the user. And these are like different they're just placed at strategic positions. And then at the end of the day, like people spend a lot of money trying to get the site and they say, oh my goodness, the site is slow. And then you have like terrible user experience. But imagine a world where like all these servers were just scattered around the world. They're just there, closest to your users. Like your users are able to ping the closest server to them the code exists like everywhere. This is what I call better experience. So I want to introduce you to Cloudflare Workers. And Cloudflare Workers is a product that is very close to my heart, mostly because it solves a problem that I've experienced personally. And like I said, if we're solving problems for ourselves, then so therefore we are making it we are making solutions to better it for ourselves and also solving the problems of others. And the the good thing about like Cloudflare Workers is that it runs on Cloudflare's Edge network. So it's the same code that runs on the browsers. And you might wonder that like, what does this mean? Like, what does this mean? The same way like browsers run code. And do like Cloudflare Workers have like similarities to like JavaScript, like in the browser or in Node.js? Like there are few like subtle differences on how like they run your code. Like under the hood, Workers runtime uses a V8 engine, and if you know like Chromium, like this is the same thing that Chromium and Node.js use. And the difference, but with difference between like JavaScript written for the browser and JavaScript written for Workers is that, and we also use that they also use like the same standard APIs that are available in like most modern browsers. So the code that you're running is ready, is browser ready, is written for the browser. It doesn't need like any compilation or interpretations. It's written for the browser, it's ready to run. But instead of like running to the browser specifically, it runs on like Workers run on Cloudflare's Edge network. And you might wonder like what is an Edge network? And the definition of like an Edge network is essentially in edge computing is closest to your user, really just like cutting edge right in front of your face, kind of like technology. And this global network like keeps improving and keeps increasing. The number of servers, like I showed you in the previous slide, and see that these dots like keep increasing. And you can see that most of these dots are scattered across Europe, mostly in Africa, different places, even in Australia. If you're familiar with how the map is, there are like a lot of dots. So why is being close to the edge important? Like I said previously, if you've seen how people experience the web. Like imagine what happens when you're scrolling through your Twitter feed or you're loading stuff from Instagram. You can see that like if you try to load something and you draw down that refresh button and the information doesn't come like fast enough, you're wondering like what's happening, and you do it 3 times and you're already pissed. Like people, I feel like the more the world grows, the shorter our patience is, and people expect things to be lightning fast. So you want to be able to get closer to your users with from the edge. You don't like to say, okay, cool, I'm a company based out of the US, so I deploy to a US server. Anybody that's pinging my stuff outside the US can worry about themselves. No. You want to be able to be closer to your users and deploy the same serverless code as you would, but in a more optimized manner. That is, like I said, Cloudflare Workers are V8, everything on like the runtime is on the same V8 engine as like Node and Chromium. So this code is like browser ready. And in Cloudflare's network, 95% of the connected world is within like 50 milliseconds of a request, and 80% is within 20 milliseconds. What this essentially means is that it's fast. Like it's really fast. Like getting requests are really relatively faster than every other like request that you would normally send. This is a screenshot literally from like the Cloudflare London office, like where I and if you go to workers.cloudflare.com right now, you can actually ping and see how fast a request would come if you decided to deploy an application. And this is me like just testing out how fast it is from like the London office. And note that I'm in a city that has servers like really close to me, and this is 9 milliseconds. If I was in a place that had like the closest server to me was probably in the UAE, for example, you would get like almost the same, if not faster responses. So imagine me being in Nigeria and seeing that, okay, cool. If I ping, there's also servers in like in Nigeria as well, and or close to Nigeria. So I'm not having to go to like the US East to get that information. I'm getting that information straight from the server close to me. And how does this? You might wonder like, how does this work? So the way Cloudflare Workers work is that it treats your network as a computer. So instead of like thinking of workers as like different zones. It thinks of it as like it's taking the browser ready code and it's ready to like to run on the different browsers, except that is running on Cloudflare's Edge network. It's ready to send this information to your users. And like I said, it works like with V8 isolates. I can only touch like the basis of this, but essentially what this means is that a single runtime of a Cloudflare worker can like run like hundreds of isolates seamlessly and switch between them. So every code that you deploy is deployed on each of these network nodes. So every time that you deploy code, it's not just deployed in a specific region. We don't have regions. The region is Earth, right? It just goes around the same code is deployed. And you might be wondering, okay, if I'm sending the same code, then I'm paying for like the process overhead. But the truth is that with each isolated memory is completely isolated, and each piece of code is protected from like untrusted users. So every time you spin up like code, you spin up just one overhead for all that code. So you're not paying for all the different times that your code is going to like these different nodes. You're just doing all that process once. And what this gives you is faster deployment and faster setup time, because there are no cold starts, and there's no like you have like more predictable prices, because like you have a very generous free tier as well, up to like 100,000 requests per day. And the way I like to think about workers is it like tiny V8 babies just running around and just staying in different nodes waiting to be called. And as soon as like you deploy a service, it goes very fast. So when you think of workers and the way the originless technology should work, I don't want you to think of different nodes. I want you to think of like this big ball filled with like a lot of like nodes that just work together, because we are either, and if like you're in a region where like more requests are going to your server and we know that it can't handle it, that there's smart routing as well, which like allows you to go to like the nearest server instead of like sending you to the one that is already overpopulated. So this is like a tweet from Sunil Pai, he's a colleague of mine, really amazing guy. He was like, the new mental model for Cloudflare workers is not like one serverless, like I've said. It's like one big server that's every day like a number of like the verticals and edges just keep increasing. So it's like one like stretchy server. It just keeps going, and everything is interconnected, and all your code like runs, your same code runs on this network. So when you think of Cloudflare workers, I want you to say that's like super fast. Like this is like if you this is the only thing you've gotten out of like this talk, I want you to understand that your code is fast. The user experience of your applications will increase, mostly because people are able to access your information as soon as they want it, because it's closest to them. And you might be thinking, Obina, it's not just enough to have your function closer to like the user. Like, what about the data, right? What about so if you're fetching something, yeah, cool, it's closer to the user, but yeah, also needs to go get that information. And we hear you. At Cloudflare, we use workers for like different things. We have like workers KV, which is our low latency key value data store, and that supports like high read volume and at low latency. So for example, you want to use KV for stuff that will need writing infrequently and maybe reading frequently. So think of like Twitter, for example. More people post than they actually download stuff. That would be a good use case for KV, right? So if you're going to like, maybe you want to store forms and what's it called? Like you want to store like forms and more data, you can also like check out KV. And also we have like durable objects, Cloudflare stream, images, and pages. And I want to speak specifically to pages, because you're running your serverless technology on workers. That's fine. It's closer to your users on the edge network. It's originless. That's amazing. But with pages as well, Cloudflare pages is a way to deploy your front-end code to the edge as well. So imagine like instead of having your front-end code deployed to like a CDN that has like a couple of nodes, you can also deploy your front-end code to Cloudflare's network. and have that seamless integration with pages, your functions, and everything else. So literally, you're living life on the edge. You're living life like faster, closer to your users, with user experience in mind, and at very low cost. And at Cloudflare, we build everything with workers. We test our products. We use it. I use workers every day with pages and sometimes KV, durable objects as well. Durable objects is our low latency, like consistent data storage. So for example, the use case I have for it is if you're trying to run information in a specific location as it is, you would want to use durable objects. And I don't know if you've seen, but we're always iterating on this. We're testing our products, we're using, and we're trying to improve the user experience. And I believe that this is a way to make sure that people are having the best experience while using our products. Oh, laptop's about to die. Sorry about that. But yeah, this is the best way for people to experience our products. If we're testing it, we know the pain points. So as we're solving this for ourselves, we're solving this as well for our users. And if you live life on the edge, like I've said, if you build your front ends with like pages and integrate workers, you would see that like at some point you would feel like anywhere you would have the confidence that anywhere you deploy your applications to, your users are getting the best experience. And because like Cloudflare is also like a CDN company, an internet security company, there are also other services that you can leverage on. There's like security services with Cloudflare Access. You can also think of like of using like Cloudflare themes for the services of your teams. You can, the point is there's an endless possibilities of things that you can do within the Cloudflare network, and all of this is secure and stable, and it will improve your user experience. Like I keep hammering on, because that's the most important thing to me, and that's the most important information I want to pass across to you. And you can I just want to say thank you so much for listening. You can reach out to me on Twitter at Obina Speaks. I'm always happy to answer any questions on how you can integrate. I'm always happy. And I am sending you all the force, and thank you so much for listening. May the force be with you.
That was beautiful, Obina, and it was so insightful. Like I learned a lot from this talk. Guys, he will be available in the launch, and you have any questions, go reach out to him, talk to him, and he's a really nice person to talk with. Yeah. And yeah, see you. Thanks for coming and talking, and see you soon.
All right. Bye.
Developers. At least that's what he says. And he spent 12 years of his careers in design infrastructure. And in the last 4 years, he's working as a front-end architect. He's also part of this React working group. And today, he's going to teach us how to write effective React components and not to make it expensive. Also, one important thing about him, if you like cheeseburgers, you got your man. He makes the best cheeseburgers in San Diego. And when he's away from his computers, you can either see him traveling, cycling, or just eating and relaxing. So that's Michael Chan, and let's begin with this talk.
Hello, React India. Thank you so much for having me today. Today, we're going to talk about an expensive React component, but probably not the type of expensive that you're accustomed to hearing about. I like code. And then finally, we're going to cover some takeaways together. So first, a little bit about who I am. My name is Michael Chan. I go by Chantastic most places on the internet. I've been doing some form of design infrastructure for the last 12 years and have been acting as a front-end architect for the last 4. I'm also the host of a show called React Podcast. It's been on hiatus for a year, but we're going to be starting up again soon. I'm part of the React working group to get React 18 working and just really get a nice migration path for y'all going. And then I'm building this community at Lunch Dev. You can find it at chan.dev/discord. And I've recently joined Chromatic to improve the UX of the web. You might know Chromatic for Storybook, the open source product that we support. And if you want to work with me and the awesome team over there, you should visit chan.dev/chromatic. Finally, one other housekeeping thing. If you want to follow along with any of the slides or notes or whatever about this talk, I'll have those up at chan.dev/. So why am I here? Well, that story started kind of a while ago. I gave a talk about, I think, 3 years ago now called Hot Garbage, Clean Code is Dead. If you like this talk, you'll probably like that one as well. If you hate this talk, then you'll probably hate that one as well. That talk was about me kind of wrestling with my sense of belonging and overcoming imposter syndrome and working with my own personal demons. And that talk acknowledges at the end of it that, maybe there's more than just my demons to confront. And unfortunately, I had to cut out a lot of the code part from that. And this is kind of like a follow-up to that talk where we talk specifically about code and why coordination is costly. So that's going to be the main crux of today's talk. And specifically, we'll talk about the discipline of component API design. Now, let's dive into a story. This is one of my favorite stories that's kind of incidentally about development. So let's dive into it. The book is called The Lady Who Put Salt in Her Coffee. But it's super old-timey and distractingly gendered, which makes me feel uncomfortable sharing it. So with that and the desire not to violate any copyright laws, I've decided to kind of make my own version and interpretation of this story called The Personified Cat That Put Salt in Its Coffee. And we'll use emojis to kind of carry on the arc of this story. So it starts with a cat, and it's making its morning cup of coffee, and right about the time that it's about to put the cream in, it realizes, you know what, I didn't put sugar in my coffee, I put salt in my coffee instead. So it consults with all of its kittens. They gather around to try to figure out what they can do to salvage this cup of coffee that has been salted instead of sugared. Well, the kitten that went to college, presumably the smartest of the bunch, raises its paw because it has an idea. It says, I went to college, I'm a very smart kitten, and coffee is just chemistry, so we should consult a chemist. Of course, the kitten had gone to college, that's true, and they all assumed it was very smart. So they agreed, why not? Let's consult a chemist. So they found a nearby chemist. Unfortunately, this chemist was not a very good chemist. They had spent the majority of their career trying to turn items into gold. They're a very greedy chemist. But all they'd accomplished up to this point was turning gold into almost gold. So not great, very great. Now, at first, the chemist said no. They knew that this was an impossible task, and they were very dedicated to their the task at hand of turning things into gold. But these cats were very aristocratic, and they had plenty of gold to share. So they said, well, we have gold. Does that change the equation? And of course it did. The greedy chemist then says, yes, So the chemist does a lot of science to this coffee. It takes all the things that it knows about chemistry and tries to manipulate this coffee to not taste like salt anymore. And in that, it succeeded. It succeeded to take the salty coffee and make it not taste like salt, but it also made it not taste like coffee anymore either. Of course, the chemist is actually fine without this outcome and demands its payment in gold, and then they leave. So the cat, still sad, trying to figure out how to salvage this cup of coffee that has now been salted and done science to, consults with the kittens again. The educated kitten of them speaks up again and says, I have a brilliant idea. Let's consult an herbologist. So they consult an herbologist. Now, unlike the chemist, the herbologist didn't care about money. They were prideful and felt misunderstood in their endeavor. They had a great interest in sharing their passion and evangelizing the discipline that they have come to love. The herbologist went to task and committed lots of exotic herbs to this cup of coffee, plants the family, even in all of their privilege, had never heard of. Now, when the herbologist was through, they had a cup of coffee that didn't taste like coffee, it didn't taste like salt, it just tasted disgusting. So, what were they to do? Well, of course, the arrogant herbologist blamed the coffee, saying that it was bewitched, and moved on to share her good news with others who were less cursed. The kittens are now at their wits' end, and the cat, getting cranky because it was late in the day and it hadn't had its cup of coffee, they were very desperate to try to find some type of solution. So the kittens, now disregarding the wisdom of their most educated kitten counterparts, they decided to just reach out to a wise and experienced neighbor. This wise and experienced neighbor asked one simple question: can you make another cup of coffee? Now, this actually blew the mind of the cat and the kittens, and they said, why didn't we think of that? So obsessed with trying to salvage the cup of coffee that they'd made with the salt in it, they'd totally overlooked the very obvious solution to just make a new cup of coffee. So they made a new cup of coffee, and it was great. The end. I want you to hold that thought for a second. You might be screaming at me saying that this is a terrible story, that this is completely detached from reality, unrealistic, that nobody is so daft as to not realize that you fix a salted cup of coffee by making a new cup of coffee. Hold that thought. So for the next 17 minutes or so, we're going to talk about code. That's what you came here for, talking about code. So let's dive in. Because it's time that I reveal to you what I see as the billion-dollar component, a component that has been disproportionately expensive to our industry. And here it is, right there on the front page of reactjs.org. It's the greet message or hello message component. Now, let me show you with some examples why I think this component has really taught an entire era of front-end developers how to program wrong. So we start with greet message. This is exactly the way that it looks on reactjs.org, except that it uses hooks for simplicity instead of the class that there. So this is where we go. We have this in production, and then we get a ticket for it. Let's read it. It says, hey there, we'd like to improve the friendly factor of our greeting with customizable punctuation. Note, our team tried just using punctuation after the component, but the resulting formatting was off. Not sure why. Well, let's look into this. Oh, it's right there. It's because we're using a div. If we put a period after a div, it's going to go to the next line. So, what's the solution? Well, the solution right now that we have this component already, is to use a new prop with ideally a default. So that's what that looks like. So we kind of take a name, or we update our component to take trailing punctuation. And we use the trailing punctuation by default. We have no punctuation, which preserves all of our previous use cases. And then it can be added optionally anywhere that we want. Go us, we were able to do this without affecting any of the previous uses. And also, shout out to anyone who knows why I use trailing punctuation and not just punctuation, because, you know, we probably have experienced the same pain in our lives. Okay, so that's great. But, you know, we deploy that and then we get another ticket. Howdy, UX team here again. Great work on the last feature. Teams have already begun using trailing punctuation to improve UX. We're even using it with custom emoji. That's great. We'd like to further customize message with a cute greeting like, yo, howdy, or what's good? See cuteness above. Hello is still a great backup. Can you keep that existing message? Okay, so we know what to do with this. This is the component that we have right now. And then our solution would be very similar. We're just going to add a new prop. And then in order to keep compatibility with what we've done before, we will add a default. Okay, so we go from what we have on the left here to what we have on the right. We add a salutation. It's kind of the best name that I could think of for this. And we add it to our component. Cool, not too bad. And once again, everyone's grateful because we were able to get out of a difficult situation and not introduce a breaking change. Yes. Okay, so doesn't last too long, the successes, before we get another ticket. Fortunately, we've already solved for this in the other solutions, and so we can just kind of like carry on. Hey, our marketing team is creating videos, and the content reviewer is concerned about the punctuation of the greeting in the dashboard. Instead of hey John, they'd like hey comma John. What's the best way to fix this? Well, this is actually already fine because, you know, we can just put a comma in our salutation. So we just kind of like, you know what, we're good on this. Just put a comma there, you know, record your video and then move on. That's great. Cool. Everyone's happy. But it's not long before we get a ticket from design. We're collaborating with UX on a project birthday bonanza. Our goal is the one-time birthday balloons animation over the user's name. Happy birthday, Aaron, with balloons floating all over the place. They have a new birthday balloons class selector that does the trick. Our prototype is approved with wrapping element, but we'd like to keep the number of extraneous divs to a minimum for future styling efforts. Could create message accept a class name prop? Well, yeah, we should be able to do that, right? So we look at our code, and what's the solution? What's the pattern that we could use here? Well, the pattern is going to be object rest properties and JSX spread attributes. We've seen that a handful of times. So we take this, what we have on the left here, we just replace, instead of just taking the div, we're going to take all of the remaining props and then spread those out over the div. Now, honestly, this is maybe something that we should have done before, but it was just an oversight. So now we have it, and it should be good. You know, it looks good in development. Let's ship it. Okay, well, now we introduced we get another ticket from someone looking at this from an accessibility perspective. We've concluded our pre-launch accessibility audit, and there are some low-hanging fruit that we can solve with semantic markup. Target of interest is great message. We have a few teams on this effort right now. Should we move away from that component or keep it or can we adapt it to different markup? H1, strong, M, etc. We want to get this out as soon as possible, so let us know if there's a quick fix. So we look at our code, and then what kind of pattern could we use to solve this? Well, the pattern that we'll use is a component prop, also known as prop or a polymorphic as prop. This has so many names at this point because it is used in so many libraries everywhere. A big styling thing that people use. So as we look at this, this is the right answer to this. But how do we do it in a way that we kind of preserve all of the existing code? No problem. We go in here, we look at our code, we say, okay, so we want to change out the div. We're going to take an as prop. We do some funky JavaScript to make sure that it has the right capitalization to trigger the heuristics for JSX. It's going to be, you know, a div by default, but anything that gets passed in here as a prop is going to take precedence. And hooray, we did it. And we didn't introduce any breakages. Or so we thought. So here we are. We're seeing layout issues in several places where greet message is used. Can you help us diagnose this? There are cross-team efforts to unify styling practices across the product suite. It's a mess right now, but I hear everything's going to be amazing once everything is converted. So we'll circle back to that later. How many times have you heard that? Let's get a quick fix in, but make sure that this is both backwards compatible and forwards compatible. Should be easy, right? Okay, so we look at our code here and try to figure out how we can solve this. Now, we know that we have solved something similar in the past because we've used default props, so we could probably do similar. If someone passes in an element that is not display block, well, we could just use default props to change it to display block, right? Well, we have a little bit of problem with that because sometimes, you know, because that's such a high precedence, it also breaks some of the classes that we've allowed people to apply. So we have, you know, if they were specifically making a display flex or display inline block, now all that is broken because of this high specificity of style. So that's not going to work. But we can also solve for this problem with delegation or inversion of control. So we take this, we look at this, we set a default block. Our style is going to be no style by default. And then we do a little ternary there. So style, if it's a function, we're going to call the function that's provided to us with the default styles. That would then allow the person who's consuming this component to decide to, you know, cast that value off or merge it in with values of their own. And then if they don't give us a function, then we're going to just kind of merge the styles that style object that they provide with the default styles that we have. And that'll be overridden based on the order of this merge here. Now, this is actually like a really interesting try for the existing API. We can merge styles with our default, and we provide an opt-out mechanism without having like this. And I'm actually like patting myself on the back. Like, this is a very creative solution if not changing things and supporting new ways of working is prized. So, final issue that we're going to cover is we have another request. This is from our friends doing an internationalization effort. So, what do they have to say? We're almost over the finish line. One of the our biggest customers is overseas. We've been kicking the can down the road with greetings for a while, but we need to support right to left in our dashboard messaging. Think we can get this new internationalized message onto staging this week? Okay, so we think about this, and what would be the best solution for this? Well, in my estimation, it would be a function that takes the name and is able to internationalize the message based on the name and environment. Now, this, in reality, this function would probably take, you know, a function for actually internationalizing that local to the environment, but I didn't want the, you know, code highlighting to be all funky. So it would usually take like 2 arguments or something like that. And this is great. This is awesome. We've made a component that is really ultimately flexible and reusable and extensible in ways that we didn't anticipate that we would need before we started. But I can't help but remember our kittens when I'm looking at this component. Specifically, I can't help but wonder if we're being the clever kitten who had all of these ideas, these academic ideas, rethinking about what this component needed to be in the first place. You know, we had just made it taste different. You know, we also have the herbologist who added but didn't fix the problem. They only made the coffee intolerable. But what was it that the wise neighbor kitten said to do? Maybe we should just start over. Maybe what we needed all along in an attempt to salvage our mistake was just to be honest and not continue to double down on our solution. What if the components that we've made are the ones with the salt and the chemicals and the herbs in them? And all along, we've been wanting the clarity and convenience of this thing that we've kind of left in the dust, which is just a function. And I'm making this cup of this cup, realizing that like I never actually needed props, and I didn't need a component, and everything we've done only served to negate the inconvenient effects of encapsulation. So with our remaining 5 or so minutes, I do want to talk about a handful of takeaways, and how as React developers, there's a failing in our programming that needs to be fixed or addressed. So I don't have some big solution, but I do want to throw an error and raise a question that you can add to your arsenal as you're developing components and extensible APIs. I believe that this is broken. It's not the hello world of React. And this thinking is costing us way too much. This component, this tiny, subversive, too insignificant to be questioned component has really infected the way that we think about JavaScript markup and composition in React. And it has a cost. And it's cost our industry so much to work around. And so I want to throw an error, but like, what are some of the reasons that we don't throw the error? Why we don't ask the questions that may allow us to get beyond just adding and adding and adding and adding to double down on props in React? So I asked around on Discord and on Twitter, and I asked for reasons that people don't raise this question more often. So here are a few of them. Well, I'm just doing what the linter tells me. It's safer that way. Refactoring is an acceptable form of procrastination. Demonstrating mastery of the patterns proves I'm competent. The tech lead wrote a blog post on a pattern and won't merge a PR without it. More complexity makes me feel more clever. Fast fixes are rewarded and slow solutions aren't. I don't get paid for more collaboration. If I can't fix it, comes down, it doesn't go up. Now, the interesting thing is that these are all problems in communication, not code. And I think that one of the problems that we experience is that we want people to see us as the smart little collegiate kitten, the one who had all of these brilliant academic ideas on how to solve the problem with code. There was really a problem with our communication and understanding the problems that we're trying to solve in the first place. And through this process, we've just served to make our components worse and worse and harder to use over time. Now, the rise of components has forced us closer and closer together than we've ever been in the past. And it has become like really difficult to work in a space where like design and UX and accessibility and front-end development are all colliding together for the first time. And I believe this problem is costing you, it's costing me, it's costing the companies that we work for and the companies that we support. Honestly, the only people that I think benefit from this complexity are consultants and educators. So we need to start asking a better question. Is the work we're doing the work that needs to be done? Does your company need the world's most composable, polymorphic, extensible, and customizable multi-billion-dollar button component? Or could a button with a class selector or two do? Driving it home for React devs, are props and components the right tool for the job when we have children and functions? The basic building blocks that we've already had in HTML and JavaScript for as long as the web has been around. This is the question that I want you to start asking so that you can stop making and remaking the most expensive component in the world. Thank you so much for listening. Thanks for your time. I hope that you enjoyed this talk. I'm Chantastic. Have an awesome conference.
So that was beautiful talk and so deep and makes a lot of sense to us. I really loved the way how he explained things. Yep. So see you all in the next talk. And yeah. Yeah, so next I would like to welcome Siddharth to talk with us. Siddharth likes to sit at the intersection of designers and developers. He is currently working in design systems team at GitHub, and he also has a really cool project called UI DevTools. It's a design tool for developers where you can actually design and get the code directly in your editor. He have been in the design system space for 4 years now, and he's gonna talk about the work he's doing right now. This makes him the best person to talk about component APIs. When he doesn't code, he loves to play football, and he usually spends time with nature. Like, who follows him on Twitter knows that he always comes live when he's out in nature. He is also learning how to play the drums now, so I'm waiting for him to make something with music soon. One interesting thing is he has a master in physics, and he says he doesn't use it anywhere. It's not much useful for him, but when he makes animations in UI, it helps him a lot to make realistic animations. Over to you, Siddharth.
Sorry, I had to get water. So, I'm Siddharth. I'm going to talk to you about design systems, and particularly, I want to talk to you about walking the fine line between flexibility and consistency in component APIs. So, let's dive straight into code. So, what I tried to do is I was looking at a bunch of other component libraries for inspiration, and I looked at this library, which is Polaris by Shopify. I was trying to build this alert that they have. So the way it looks in their code base is they have a banner, and they don't call it an alert, they call it a banner, same thing. And you give it the status, so status critical, and you give it a title as a string. And then they decide where does the title go. Makes sense? And then if you want to add an action, what you do is you add action config, right? So it's the object, and then you give it content, and you give it what is the action. So it's pretty tightly controlled. You don't see many stylistic options here other than what the status is, and they decide where the button is, what the button looks like. Now compare that to Material UI. They call it an alert. It's severity instead of status, same thing though. And then you can give it an icon of your choice and some CSS of your choice. So I can actually control the border and the icon both, which is interesting. And then instead of giving title as a string, what we do here is that we give an alert title, which we import from the library and use that over here. We could have used something else as well, which is interesting, but they do have a preferred way, which is this. And then to this action, I basically get a button and I style it. I'm using the outline variant. It's inheriting the color. I decide what the margin is over here. So to get the same output, I'm writing a lot more code, but I have a lot more control over exactly what I get. So interesting differentiation. So compare these two. You can see that the Shopify one is way more tightly controlled, and that's by design. So given you have a spectrum of how flexible a component API is, I put Shopify's Polaris somewhere over here because it's very opinionated. I'll put this somewhere else. It's very opinionated and it has strict API, and this leads to predictable and consistent outcomes, and that's what they're going for. They're going for like very tightly controlled outcomes. Of course, this can become rigid because if you're trying to do something which is not in their system or not in their style, then it's very hard to do with their components. Compare that to Material UI, which I put all the way on the right side here. It's open source. It has to have a very flexible API because they have no context of which application or which brand is this going into. So it has to be very, like the components themselves are very independent, and you can build things which are very flexible and dependent on your own context. You can pass your own styles. And of course, if you're not careful, that level of customization can become very messy and fragmented. It's hard to do a good job at it. So if you're building a component library and you're trying to figure out where on the spectrum should we lie? The answer is, it depends. But I'll tell you what it depends on. So it depends on the context. Is it a brand's component library, or is it an open source library? Open source library, by definition, have to be much more flexible and less opinionated, because you don't know who's going to use it. Then even if it's a brand component library, what's the design culture at your company? Is it consolidated into one team that decides all the patterns, or each product gets their own independent decisions and they can't deviate from the common brand? And then what's the maturity level of the design? So do you already know established patterns that have emerged, or is it still experimental? Maybe it's a new startup that's still trying to figure out what exactly our patterns are going to be based on user feedback. So all of these kind of decide how flexible do you want to be. I'm going to take the example of this one component that I've been working on. So you might have seen this on GitHub. It's the thing that you use to assign folks to a pull request. And the same component is actually used in a bunch of places. So we call it the action list, and it can be used to put some actions in the sidebar, or it can be used in a small menu, or it could be all the way in this selection with avatars and description kind of in the UI. So you can see that it's very, very flexible. But we still have like a very strong design guideline for it. So I thought, let me try to build this. And that's exactly what I've tried. I've tried to build it in a way that enforces our style. So API. So this menu that I have here, I'm going to import action list, and I'm passing all of these items as an array, right? So there's strings. This populates the menu. You don't really get to decide what the spacing, what the highlight, all of that is done by the component itself. Design decisions are baked in. And you get an on select, right? So, but to do something with this on select, like if I select quote reply, you'd probably have to do something with this string, which feels very odd. So I'm going to go back on that and make this text and on select. So text gets rendered. On select gets fired when you click it or when you select it with the keyboard. Pretty solid. Now, let's move on, and then I want to add these dividers and to break down the content in different parts. So to add these dividers, we could go with an API which looks something like this, which is like there's a secret key called dividers. If you know it, then you know how to put a divider. Feels a bit icky, so maybe go with type divider, where everything is type row or item by default, and then there is the type divider, which knows how to render this divider. Or, if you're already exporting something, then maybe it's just action list dot divider, and internally that's an object which ships type divider or text divider, something that the action list component can understand, but the user doesn't have to. The user of the component can just say action list divider. Feels all right. Moving on, let's make it more complicated. So the labels on the right side, this is also a list, much like this one, but it renders this circle with the labels color on the left. So it starts the same. We probably not have these hard-coded, but we get them from the repository. So I'm going to say repo.labels.map, map through them and pass the object, which is text as label, and the on select. And then to put this circle of hex color, I'm saying give me a field called label color. And when you give me label color, which is a hex code, label color is smart enough to know that it will render a circle here and put the right amount of space between these, right? So it understands. There's other like there's this assignee, right? So we just map over repo.collaborators and we pass the text and on select, same as before. But instead of label, we pass avatar. And the avatar key is smart enough to know that it has to render a circle here of the right size and put the image, right? So the user's avatar with the right border radius, and it's a different margin, but avatar is smart enough to know what the margin is. So that kind of works out. Now, it's fine, right? If we have, this could be, you could pass avatar or you could pass label color, and they both know how to implement this. Seems safe. But of course, there's more. So there's milestones, which renders this icon, and there's projects, which renders a different icon. In fact, if I show you all of these samples, there's a bunch going on. So there's some icons. These are colored icons, but they're still icons. and then there's the avatar and the labels that I showed you. So maybe we can't get away with just these. So there's three. There's the avatar, there's label color, and this icon. And if we just do these three, maybe it's fine. Like the API is not too bad. Of course, there's like the icon milestone. And of course, this gets interesting because there is this UI where, can I show you? You have the selection state or the ability to select users. And it's fair to assume that you can implement it by you use the avatar and then you pass the icon as the check icon. So if the user is selected, then you pass the check icon. But this is what it renders. Like it renders the check icon and the avatar, but it overlaps, right? So you're like, okay, how do I fix this margin? How do I override the style so that there's more space between these? What we've kind of done here is we've made an API choice where you can pass the avatar and icon together and it will render this. And even though this is not the right result and nobody is trying to break the API, but we've kind of pushed people in the direction that this is a valid choice, even though this is not how we want people to add selection. We want them to give selected equal to true so that it can render a check or a checkbox depending on the context. So again, I don't think people are trying to screw up the API. It's just more like this seems like a very valid choice, even though it's not. So we're sending them in the wrong direction. Okay, so that's not going to work. We need to make sure that we convey that there is just one element that can go into the initial slot. So I'm creating a prefix element, right? Prefix element is avatar, or it could be something else. And then, of course, I need some props to give it to. So I say prefix element avatar, prefix props, give it the source. And anytime you see like this element and props both, this is a component, isn't it? So I just say prefix is a component, and you can render an avatar if you want. You can render the label color, an icon. You get to decide. We call this leading visual instead of prefix. That's just what we call it internally. You can call it whatever you want. That's not important. And it kind of works. So you have an avatar. You can do the label here, or you could do the milestone icon. It's basically an empty slot, which knows where to render and how much margin to put here. It kind of works. It's more flexible. You can put whatever you want there. But honestly, that's what we want from this initial slot, isn't it? Okay. So now moving on to this thing, which you probably already saw. So there's this description, and it has a certain style to it. It's slightly dimmer, has more margin here. And the way to add this could probably just look like this, where we say description, pass the description, and we'll put it here, because we already know the margin and everything. And if you look at label also has a description, but it's actually the next line because these descriptions can be really long. So we put them in a block. And to do this, I guess you could say description variant is block. So description variant could be inline or block, which decides does it render in the same row or does it render in a row of its own. This looks like the same where you have some component and this too. So I'm going to keep them locked. And oops, sorry, I'm not going to create a component or control it. Okay, moving on. So this is the hardest component here, which is this grouped by list. So in reviewers, you'll notice that you have suggestions and then you have everyone else. These two people are suggested because they have recently edited these files. So how do we do groups in this API? So I'm going to try this where I pass the group, and I'm saying if the user has recently edited, then the group is suggestions. Otherwise, it's the everyone else group. And this doesn't really say which one should come first, right? It's kind of dependent on whichever user came first. That doesn't sound right. So we need some way of declaring this. One way to declare this could be, let's put group metadata, where the order of this decides where does it grow. But then you also have this where we want this to be filled sometimes and not inline. So I need more. Just going to make it an object and say this is the group. It has an ID, it has a title, and it has a variant. So variant could be inline or filled, and this title goes here. And the good thing about having an ID now is that instead of just passing a group by text, I can say group ID is 1, which goes to suggestions, or group ID is 2, which goes to everyone else. So the API is getting a bit dense, but we need another way of defining this group metadata or group definition. It can't really be inside items. It's a different hierarchy, so makes sense. Finally, check this change out, that we were dealing with inline suggestions, inline descriptions, or block descriptions. But now we actually have both, because we have inline to show the name, and then we have the block description to say they recently edited these files. And how do we do that? Like, how do we have two descriptions? I guess we have to make this an array, right? So you can pass either one description with a description variant, or maybe we should just scrap that and have descriptions as an array, where you can pass one as inline and one as block. And if you do a third one, maybe it just gets ignored. Overall, all this to say that this API is getting a bit stretched. Like, this is a very tricky API. You have to know exactly how the action list component expects these keys to be able to render what you want. If you do anything wrong, then you don't really get the right result because the key doesn't match. So maybe we try to simplify this and say, you know what, this is a very weird case. We don't really support descriptions, multiple descriptions in many places other than this one. So maybe we don't put that in the component. And instead, this is a very app-specific thing or a product-specific thing. So we just give you a render function, and it's a render prop. So you get the internal props, and then you can build your own custom component, but please pass the internal props to that element so that, like, we still have the styles and we still have keyboard navigation and all of that. The accessibility doesn't break. Sorry. And I think half of that part is really fair, that not everything can go inside the component library. There will be things that are very custom to a project. Just yesterday, I was looking at something where it's a different menu, but that the items in that menu are sortable. And that's not something that this component does, but the app needs it. So they should be able to do that, and they should not be bound by the component itself. So, you need some escape hatches. But the only danger is that whenever you escape, whenever you eject, it's the right word, whenever you eject from a component pattern, you're kind of taking on the responsibility of, you understand what these internal props are, where exactly to put them. Do they all go on the root? Do some of them go on the nested element? You kind of have to decide that. And by ejecting, you kind of lose all of that glue code and pass on the responsibility of doing it right on the user of the component instead of the folks who build the action list, which is like us. Okay, so there has to be a better way, and there is. So we have an action list.item component, and you can put it inside action list and it knows how to render it. We can do something like this because components in React are basically JavaScript objects. And to the action list component just by doing like a key and value, and you export the root and you get all of this. So this pattern is usually called the compound component pattern. And you basically get the action list and you get action list.item together because you always use them together. You don't really want to use one without the other. So we pass it the onSelect like we were doing earlier, and you get kind of this action list item inside action list kind of an API. So renders pretty nicely. Let's try to build all of our examples to see if this really scales well. So dividers. We were trying to do dividers like this. There's like a secret text or a secret type or just action list or divider type. Over here, this could just be a component, right? You render an item, then you render a divider, then you render an item. And the divider is just a React component attached to the action list like a key value. So pretty simple, kind of just works. And the good part is that divider internally knows all of the right semantics. So it's a aesthetic value. It's not part of a list. So if a screen reader reads this, it shouldn't count divider as an item. The divider is only for aesthetics, not for semantics. All right, so let's try to do these labels. Oh, ran out of space. Let's try to do these labels now. This is how we did it earlier. We mapped through the elements and passed down this object with a leading visual component. It's not too different. We would need to map through all of this, but instead of passing this object, we're now passing actionList.item. And you need the key because it's a map, and you have an onSelect, you get this. Now to add the color, to add this leading visual or prefix, kind of have another component, which is actionList.leadingVisual, and you can put whatever you want inside it. So inside it, I'm putting the label color component, which is like a circle, renders this color. And the actionList.leadingVisual knows what size it should be, knows what the margin is, the vertical centering, all of that. And you control what goes inside it. Seems to make sense. Let's try with repo collaborators. So this list, remember we need the avatar. Again, we get the actionList.leadingVisual, and inside it, we can put the avatar. So the action list kind of, again, centers, take the same space, has the mark. The avatar can take more space. So it works out. Let's see this case. To add the description, we were trying to pass it a key. This time we pass it a component, same as before. And then we say this action list.description, and then you pass a string inside it. Now it might feel weird that even though here we could type this, like description can only be a string, here it feels like it's more open. Like what if somebody gives an avatar and, something else inside it? That would be weird. Something else. So that's not necessarily true. I think we can still type this. And I skipped the slide, didn't I? So, okay, we will talk about typing it, but let's also not forget we have another kind of description here. And in the previous approach, we added description variant as another key. And you have to remember that these two keys are related. In this case, we can pass a variant right on the component. So they're more collocated, feels like nicer and more tightly knit API. So action list can be variant inline, or it can be variant block, and that will decide if it renders on the same line or next line. Sweet. Now let's go back to the thing I was saying about typing these. You can actually type these by just saying the variant is inline or block, as we said, and the children are of type string. So usually we're used to saying children could be anything. Children is any React node or any JSX element. But in this case, we could actually say, give me a string. So if somebody tries to put something else here, you actually they would get the red squiggly lines in their editor and warn them that, nope, action list.description only accepts strings. And I think that's a pretty good way of hinting when somebody is trying to do something else that the component doesn't support natively, or the component isn't really designed for. How does all of this work? So very quickly, it's something that I call the slot implementation. It's not new. It's been around in different frameworks, at different times. And how you do this is, so we have these components, right? The action list.leadingVisual, action list.description. Inside the item, which is this whole container, what we do is we define these slots, that these are the 4 kind of slots that we support. And then we map through the children. So when you're mapping through each child, you get something called child.type. And this child.type is basically the name of the function that was called to create this. So the name of the function is the name that we gave it here, action list.description. So if it's a child that we understand, like the leading visual, then we fill that slot. We say slots.leadingVisual, put it here. If it's the description, we figure out what variant is it and put it in the right one. And then everything else that we don't understand goes in the free form. The free form is this, which is the main text field. So that's how this works. And then after we fill our slots, basically render this. So this is a list item. We have, I use Flexbox to use these. You can use CSS Grid, all the same. And each one of these you see has a place. So the block description goes here in its own row. The inline description goes next to the free form, and the leading visual has its own place here. And all of these styles are kind of baked into the component. So this is one way of doing a slot-based API. This has its trade-off. This is not the one that we actually use, but this is the first implementation that gives a good idea of what we're going for. That each one of these names has their own slot, their own space already inside the component that they can fit. So let's see if that works. So we have labels, milestones, projects, all of those. And these are our slots, leading visual, description, and this is the middle free form. So if I try to put milestone, I actually just change the on select, I change the icon, right? I change the text, and I change the what's inside the description. Same goes for project. I'm actually just changing the slots, what goes inside the slot, while the slot definitions kind of remain the same. So this is a pretty cool way of making a layout component. This essentially becomes a layout component where it has its place. Everything has a place in the component, and then depending on what you pass, it gets rendered in that slot. Perfect. Let's move on to the big component, which is this group and header kind of thing. So I have the action list again. Instead of just putting items, I'm actually going to wrap them in a group. So I have a new component here called action list.group, which accepts a title and a variant. So title goes here. Variant can be inline. I can put my items. So I'm mapping through suggestions, rendering an action list.item. So instead of putting an item inside the list, I've nested it with a group. So there's list, group, item is the new hierarchy. And inside the item, it's pretty much what we've been doing. So like there's a leading visual with the avatar, there's the login, there's the description. And yeah, everything else kind of just composes naturally. Remember this description? We had two descriptions, and we're doing some voodoo, shouldn't say voodoo, we were doing some strange API things to make it an array. In this case, it can just be a description again. We could put two descriptions side by side and say, this is the inline variant, this is the block variant. And because, remember, slots, this one goes into the inline slot, this one goes into the block slot. And we can just put two of these next to each other. They know where to go. Of course, if we put a third one and we say another variant inline block, I imagine one of them will override the other. But again, folks are not trying to break the API. Folks are just trying to build their API and get their work done. And the more obvious the API is, the faster they can get it done. So we've solved that problem as well. Now let's see. Okay, till now we've been only talking about the list, right? Everything inside this modal. Everything inside this menu. What about the actual menu itself? So the menu is called action menu. It's a thing that composes action list. So very creative. It's called action menu. And now using the same philosophy, we have something called action menu.anchor. Compound component, anchor is what you click. It's the trigger that you click. And over here, I can put anything. So I can put text, I can put the gear icon. And when I click this, it opens the menu. So this also uses a slot-based API where anything that you put inside the anchor gets rendered and gets clicked to open the menu. And anything else that you give is actually a free form inside the modal. So that's what gets rendered over here. It's not a modal, it's a menu. Everything else goes inside the menu. So I can actually just use everything I learned with the action list and render action list with all the items, leading visual, everything, and compose them together to get this action menu API. And the menu is kind of responsible for all of the keyboard accessibility, which doesn't work here, but all the keyboard accessibility, all the, you click outside to close it, all of that behavior. So we're basically composing action list inside of action menu to get this new combined paradigm, which all sounds good. But what happens when, you kind of take it further and the product, the page where this is used, not the component library, they want to extend it and add something as well. For example, they wanted to add this find a user, a search bar, because the list was getting long. How do you do that? So this would be pretty tricky to do in a config API because, you'll have to introduce extra fields. Where you say, do you want an input? What should happen when you change something in the input? All of that. With a composable API, remember, like all of this is slot. So this is the anchor slot, and then anything you put after that goes inside the menu. So we can actually just add a text input with a placeholder and a divider, action menu divider or action this divider. They're kind of the same, and you get this kind of an API. Now you could add an on change here, add a function, and then instead of passing all collaborators, pass the filtered list. And so when I search for PK, I get PK. I can search for Mike, I get Mike, and it kind of just works. So what we've done here is we've taken one component from the component library, and inside that we've used custom components from the application and composed them all together to again change the results of another component, library component. So basically what I'm trying to say is with an API like this, you can compose parts of the application along with parts of the component library, and you can kind of mix them. This is you can kind of mix them in ways that ensure that you're not escaping. You don't have to eject out of the component. Because in this case, what we've done is we basically still have all the accessibility features. We still have the design baked in. We still have the responsiveness. We haven't broken out of it to make sure that we haven't missed anything, right? So that's kind of the big thing. So in summary, what I'm trying to say is experiment to find your spot on the flexibility, consistency spectrum, that line. I thought we're more on the consistent side, but in a lot of components, we're actually on the flexible side. Like the component that I just showed you, we had to be more on like the right flexible side of it, because honestly, we can't really control all the context in which something like a menu or a list like this could be used. So that component has to be more flexible. That's something I learned, and that's something where the composable API is a lot better than a strict config-based API, because it gave us more flexibility without the need to eject from the components and lose all of those features. Of course, there are other components where we keep it way more on the strict side because it makes sense. They're not as composable. Finally, and probably the most important thing, you got to remember that design systems and component libraries are built for people. So none of this is about letting people do what they want or stopping them from doing, not policing them. It's more about people have to build the products that they have to build. And as folks who build the component library for them, it's our job to make sure they're able to achieve their deadlines, they're able to achieve good UX on the components that they are building without having to opt out of accessibility or become accessibility experts or design experts to be able to get good outputs. So that's kind of my talk. I think that's all I have. If you want to look at some of this code, it's there on Primer, github.com/primer, and that's my Twitter handle for more design system stuff. Peace.
That was a wonderful talk and awesome live coding as usual, Sid. It was recorded a bit, but it's beautiful.
Thanks.
Yeah. So Sid will be available in the launch for any more questions, guys. Go catch him up, and also do visit the booths of our sponsors. And then we'll see you in the next talk. So guys, now we will have a small video. We would like to thank our sponsor Salon, who is our gold sponsor, and we have a small talk.
We use technologies like Ruby on Rails, React Native, React.js to develop the applications. Ours is a distributed team of software developers who help small and large teams to develop applications and achieve their milestones. A lot of our team members have a lot of experience in development, and they've also made contribution to the React and Rails communities. Our clients are from various sectors like healthcare, e-commerce, and others. Talking about Salon, so Salon is an employee-owned company. For employees to have ownership in the company, what we do is every year we divide the profit, 25% of our profit, equitably among all its employees. And in fact, we announce the profits through various channels for transparency, which is one of our founding principles as well. We believe in a very open and transparent communication. Also, we promote employee wellness. We provide flexible working hours. We have remote working. Last year, a lot of the companies started doing remote working during the pandemic. However, we had remote working since our inception in 2019. Most of our team members are settled in the whole remote working culture. It was very easy for us to transition to this remote working culture last year. A lot of our team members prefer working remote because it allows them to free up their time, and in this free time they pursue their hobbies, or they travel, they work while traveling, and they can spend time with their families, which all this allows them to have a better work-life balance. With that said, I think what also has happened last year, along with remote working, a boom in the software development industry. With that, the demand for the software developers has increased. We are in fact looking to add a significant number of developers, React and Ruby developers, to our team. Talking a little about our interview process. So our interview process is very relaxed. We do not have a very traditional interview process, which is where you give one interview after the other. What we do is we provide an assessment to the person, which he or she can do at their own time. A few times also we provide, we pay them for the time they spent on this assessment. With that said, I would like to thank Gigabytes for providing Salon this opportunity to talk here, and I would pass on the mic to the next speaker. Thank you.
Awesome. Thank you for being a good sponsor for us as well. And the last speaker of the day is from Team Dark. Hassan is our last speaker, and he's a full stack software developer. He's currently working as a developer advocate with Vercel. But he's not just that, he also founded a Ultrashock Gaming, a company, a gaming marketing startup with a community of 5 lakh members. It's a very member community on Steam. And he ran it for around 5 years and he sold it. So he's also an entrepreneur. He's passionate about startups and solving problems using software. And apart from the work thing, he loves to read, play basketball and soccer. And also there's one very interesting thing about him. He have never spent more than 3 years in a single school throughout his life. And he has lived in 4 different countries across 3 different continents. This means he has a lot of friends around the globe. So don't be surprised if you see him in a year or 2 in your country. Honor to have him, and the stage is yours, Hassan.
Hello everybody, and thank you so much for coming to my talk on how to build serverless applications using Next.js and Prisma. My name is Hassan. I'm a developer advocate at Vercel, and I'm so excited to talk to you about this topic because honestly, databases are difficult, and I want to show you how easy Prisma makes them. I'm going to break it down from scratch, explaining Next.js and Prisma, then go into some live coding to build out a full stack contacts application, so let's get right into it. In this talk, we'll briefly discuss Next.js and some of its main features, then introduce Prisma, and then finally, we'll be doing some live coding, which will be the majority of the talk. So why would you use Next.js? Well, Next.js, the SDK of the web, is the easiest and most popular way to build production-ready React applications. It's been growing at an incredible rate the past few years, and there are many, many companies from startups to enterprise level using and loving Next.js. So let's talk about some Next.js features and how they can help you become a more effective developer. First off, Next.js provides you with pre-rendering and several data fetching techniques, including server-side rendering and what you're typically familiar with, client-side rendering. This is so you can build any application you want, from a static landing page to a large production web application with many moving parts. You can choose what works best for your use case on a per-page level to optimize your app's performance and delight your users. Two other cool features that Next.js gives us are file-based routing and API routes. With file-based routing, you can simply create a file in the pages directory and it'll become a route, as I'll demonstrate shortly. With API routes, Next.js blurs the intersection of frontend and backend by giving us the ability to write serverless functions right from within our Next.js repo. In terms of support and optimizations, Next.js comes with built-in support for your favorite developer tools, including TypeScript, CSS and JS libraries, and CSS utility frameworks like Tailwind. It also gives us an image component that does image optimization and lazy loading right out of the box. And finally, with automatic code splitting and bundling, Next.js only loads the JavaScript for the current page that you're on. And this is great because less JavaScript is shipped to the browser, making your application more performant. And with the newest release of Next.js 12, there is now support for middleware, which allows you to run code closer to your users at the edge and enables things like A/B testing and feature flags. There's also a brand new Rust compiler that gives us 3 to 5 times faster refresh and builds, and React 18 support for things like Suspense and React server components. All in all, we get an extensible framework with great defaults that takes care of many things we would have to do manually out of the box, and ultimately allows developers to be as productive as possible. So as I mentioned before, I work for Vercel, which is a front-end cloud platform. We have this mantra called develop, preview, ship that I want to mention real quick. We enable developers to develop applications using whatever tools they're most comfortable with, then enable them to collaborate with others through tools like Next.js Live and preview URLs that you can share with your team and collaborate on until you're happy with the final result. And then finally, you can ship it by committing to your main branch and letting Vercel handle the rest. It'll immediately be available on Vercel's global edge network, and it takes care of a lot of the hard and boring parts for you, like setting up domains, DNS, SSL encryption, caching and validation, and so on. And we're also the creators of Next.js here at Vercel. So now that we've talked about Next.js and Vercel, let's talk about Prisma. So Prisma essentially makes databases easy and allows us to talk to and perform actions on our SQL databases directly from our JavaScript code. So before Prisma and tools like it, if you wanted to use a SQL database, you needed to learn and then write raw SQL. But with Prisma, you can use their API to interact with your database in 2 easy steps. First, you need to create your schema, and then you can use Prisma's API within your code. So let's take a look at how that works. Here is a sample schema. We first define the type of database on line 6, then we include the database URL on line 7 that we provision on Railway or Heroku. After this is set up, we define our database schema on line 10. Here, we're telling Prisma that we want a SQL database with the name user that contains an ID field, which is of type integer and auto increments, a first name and email fields, which are both strings, and finally an active field, which is of type Boolean. After we've defined our schema, we can simply use Prisma's API to query it from our newly created SQL table. After we've defined our schema, we can simply use Prisma's API to query our newly created SQL table. We use prisma.users.create to create a new row in our users table, passing in an object with the field name and values that we want to use. So in this case, we're passing in Alice as the first name, alice@prisma.io as the email, and true as the active field, and this will create a row in our table, just like that. So now that we've talked about Next.js and Prisma, let's dive right into the code. This is the demo that we're going to be building. It's called Contacts with a Z, and essentially you can add a contact using this form to the left. You can add a first name, a last name, an email address, and an avatar, and then when you press submit, it adds a contact to the right here with this specific card. So let's dive right into the code for this. I have a typical Next.js project structure here, and I'm going to be going over it. So we have a components folder, which is where all of your React components go, and then they get imported into a pages folder in Next.js. So this pages folder, it has the typical app.js, and then it has an index.js, which is actually the root, the home. So this is where all of the code in localhost 3000 is going to be, and then if we have any other routes, they would show up here. Because of the file-based routing system that Next.js gives us, to add a new route, instead of, in a typical React application, we would create a component. If we wanted to add an about page, for example, we would have to create an about.js component and then import it into app.js or whatever component is going to be rendered, and then use a bunch of switch statements from React Router. With Next.js, it's as simple as creating a new file called about.js, and then we can define a component here. So we're going to do export default function about, and we're simply going to return a div with this is the about page. And all we have to do is save. We go back over here, we go to slash out, and there we go. Our about page is live, and it's really that easy. I'm going to go ahead and delete this for now. You may notice we have an API folder in here as well, and this is where Next.js allows us to define and add serverless functions and use it within and outside of our application, as we'll see shortly. We also have a public folder where we drop all of our assets. For now, we just have our favicon. And then finally, we have a styles folder, which contains all of our CSS. Next.js ships with CSS modules by default, which, if you haven't heard of, is a way to locally scope CSS. So for example, we have a user.module.css folder, which is just a regular CSS folder, but specifically for the user component. So if we go to the user component, we'll see that we import the CSS modules folder in this specific way. We use import styles from whatever it is, and then we invoke these styles using styles.container, for example, and styles.name. And so if we go to the CSS file, these are just, these class names that we're using. So now that we've talked about the overall structure for our application, let's dive into the homepage code a little more. So I'm going to open up pages and then index.js, and we're going to talk a little bit about this. So I'm going to scroll down to the JSX for now. And so essentially we have a head component that Next.js gives us, and it's a way to define meta tags. We're using it for the contact's title as well. And then we have an H2 over here with our header. So let's actually go back to our main localhost 3000. We have our, and then essentially we have a left and then a right if we go down here, right? So we have up our page to the left and to the right. Right here we have our form, and here is where we're displaying our contacts. So we have a typical form here. We have a form, and then we have all of our inputs for first name, last name, email address, and avatar on the left-hand side. And then on the right-hand side, we are simply showing all of our users. So for right now, I hard-coded this data in, so it's just essentially me and then a few of my teammates from Vercel. And this is coming from the user component over here that we defined in components. So if you go to it, it just takes those four things. As soon as the user submits their form, the submit handler is going to run. And what we want to do is we want to send a post request to an API endpoint that we're going to create for it to query our database and actually add, the user there. To-do number 3 is simply going to query our database and get all of our users so that we can then display it in our application, and that's to-do number 4, just, mapping over the data that we get and rendering it below as opposed to hard coding this. So let's get right into to-do number 1. To add Prisma to our application, the first thing we're going to do is open up the terminal. We're going to open up a new terminal, and we're going to run npm install Prisma as a dev dependency. We're going to wait for this to run, and right after, now we're going to do npm install Prisma at Prisma/client. So this essentially helps us create an instance of Prisma to use in our application. So now that both of those are created, we're going to go ahead and run our first Prisma command, and that's going to be Prisma init. So as soon as we ran this, we saw that a Prisma file was generated, and then we have this .env folder as well. So I'm going to go ahead and minimize all of these other folders, and we're going to explore these two things. Let me minimize our terminal, and we're going to go into this Prisma folder. So this Prisma folder has our schema. As we talked about before, it is saying that we're going to be using Postgres, and this is where we can change it if we were using another database. And then it has an environment variable here with our database URL, and that's going to be in this .env file right here. So what we're going to be doing is, let's actually go create our database in Railway. So I'm going to go to Google Chrome, I'm going to go to railway.app. And you can see I'm not logged in at all. We're going to click Start a New Project, and then we're going to click Provision Postgres. We'll, see how easy it is to use .env file, because that's the database we're going to want to use. So it looks like Railway is done. Again, we can claim this project if we want to log in, but for now I'm just going to grab our database URL. I'm going to go to Postgres and then connect, and then we can grab this Postgres connection URL. I'm going to copy it, go back to our VS Code, paste it right here, and hit save, and that's about it. I've just connected our database URL to Prisma. We still have to run a command, but I'm going to hold off until we finish our schema to do that. Let's finish our schema by defining the model that we want our database to use. So this is going to be user, and we're essentially going to have it have the unique field. We're going to call that we want to auto increment, and we're also saying that this is the ID, this is the unique field that we're using. After that, we can add in the rest. So we have our first name, which is of type string. I'm actually just going to copy paste this down. We have our last name, which is also of type string, our email, and our avatar. And the last thing we want to do here is we want to map this to our database and tell our database to create a table called users as opposed to user. So we do that with map name users, because that just makes more sense. And that's it. We've just defined our schema in Prisma, and we've just connected our database. If we go to npx prisma db push, and what this will do is this will push the changes to our actual Postgres database, and we'll be able to look at it in a second. Okay, so it says your database is now in sync with our schema. That's wonderful. We can run this command called npx prisma studio, so we can actually see our database. So you can see that we have a user model over here, and if I click on it, it shows us that there's no rows in this table, but it shows us all of the things that we defined in our schema, right? Our ID, our first name, our last name, our email, and our avatars. So that is wonderful. Now that we've connected Prisma in our Postgres database with Railway, we can get rid of to-do number 1 and move on to our second to-do. For this to-do, we're going to be creating an API endpoint to create a new user and then send it a post request in our submit handler. So essentially, when the user fills out our add a contact form and presses submit, we want to send a post request to an API endpoint or a serverless function that interacts with Prisma and adds the new user to our database. So we're going to start out right here by preventing the page from reloading, so prevent default, and then we're going to wrap everything in a try catch statement. So we're going to grab all of the first name, last name, avatar, and email, and assign it into an object called body. So let me go ahead and do that. And as soon as we've done this, now we can use the native fetch API to send a post request to our API endpoint, which we're going to create in a second. But for right now, we're going to be calling it create, so we can fetch API/create, and then we pass in an object telling it that this is a, first and foremost, a post request. We're going to pass in a header that's going to tell it that this is of JSON type. So the content type is application/JSON, and then finally we're just going to pass in the body as stringified JSON. And there we go. And then we can finish this up with a catch statement that takes in an error and console.logs it if there is an error. And that's about it. We are, again, grabbing these four fields from the form, and we're sending it to this serverless function right here. Let's now create our API endpoint. We're going to go to our API folder, new file, and we're going to be calling it create.js. And the first thing we want to do here is import Prisma. We have this lib folder that we haven't talked about, but you're going to want to create a lib folder with the Prisma.js, and I just grabbed this from the documentation. This essentially just spins up a new Prisma instance for us to use. So going back to our API endpoint or serverless function, we're going to import Prisma folder, so lib/Prisma, and then we're going to start our serverless function. So it's going to be export default async function called handle that takes a request and a response. And essentially we're going to be destructuring all of that information that we're getting from our index.js file. So our first name, last name, our avatar, and our email, we're going to be grabbing it from request body, because that's what we sent in. And then we're going to create an avatar from our form, and we send it to this serverless function here called create that we just made. And what this does is it uses Prisma to add this to our data. We're going to type npx Prisma. So right now there's nothing in here. We're going to go back to our contact app. Going to just add a user with my information. We're going to see how this works. So this is going to be the avatar, which, fun fact, you can go to github.com/whatever username you're at and do .png, and then you get an image. So we can go back to our code. And the other thing we want to do is add a little toast to our application so that when the user clicks submit, we get a notification saying that a user has been created. So we're going to be using the React Hot Toast library for this. So we're going to import toast and toaster from React Hot Toast. You're going to want to npm install this. I just did that. And then we can, at the end of our try statement, we can do toast.success and pass in whatever message we want here. So like contact added. And then we have to add this toaster component at the end. So we're going to do that here. And that should be it. If we go back to our form now and we populate it again with some dummy data, hello world, Hassan at world.com, and then I grab that same avatar. So over here, .png, and I press submit, you can see we get this contact added toast at the top, so that's exactly what we wanted. Now that we can add contacts to our application using our newly created API endpoint, we finished to do number 2. That we can move on to number 3. So for this to do, so we're going to be using a library called SWR, which is a fantastic library for data fetching. So we're going to do import use SWR from SWR, and then we're 1 second. So let's go ahead and create this API endpoint. So we're going to go to our API folder that has our create.js, and we're going to create getAll.js. And in here, we're going to import Prisma again, like we did. So import Prisma from lib/Prisma. And then we're going to create a request and a response. And this is actually going to be super quick. We're going to be creating our result variable again, and we're going to be using Prisma with await prisma.user find many. So that's the Prisma command to actually return everything in your database. And then we're just going to back as JSON, and that's it. So now we can go back to our application. We've used SWR to send get request to our get all serverless function over here, and it should return everything and store it in data. And then if there's any errors, it'll do that as well. We're missing a comma over here. So let's actually just console log this data to visualize it. So data is data from our database, which is fantastic. You can see we have our ID, our first name, our last name, our avatar. So we have all of that information as an array of objects. So now that we have that, to-do number 3 is done already, and we can move on to our final to-do, which is to actually map over this data from our Postgres database and render it below. So we have this information stored in this data variable here from our SWR, and we can just map over it down here. So the first thing we want to do is delete the static data so that we can map over our actual data from Postgres. So I'm going to delete everything except one, or we can just comment it out for now. And then we're going to say, if data exists, we want to map through data, and we're going to destructure the first name, last name, avatar, email, and ID. And then we're going to be returning this. So we're going to be returning all of this, and it's going to have this same format, right? Of user first name is equal to going to be first name. So we're going to do that. First name is equal to first name. Last name is equal to last name. We can have this avatar over here and our email over here, and then we just have to add an ID prop so React doesn't yell at us. So ID equals ID. And that's pretty much it from over here. We are mapping over our data. We're grabbing our first name, last name, avatar, email, and ID. And we're essentially returning this user over here. So I forgot a parentheses over here. We're going to save. And this should work. So now that we mapped over our data, let's go back to our application and see if that was reflected. So going back, we see that we do show those 2 contacts that are in our database. I'm going to go over to Prisma Studio, and we see that these 2 rows, Hassan and Hello, are both displayed here. So now let's add a contact and watch it persist over here to the right. So I'm going to add my coworker Steven. So Steven Tay, .com, and then we'll add his avatar. We'll press submit. It says contact is added, and we can see him here in real time. And the great thing about this, this isn't in React state, right? So if we reload, we have the same information that's still there. And this is because this information is stored in our Postgres database. So if I go back to our Prisma Studio and I'll reload, the database information is right here. To recap, we've just built a full stack application using Next.js, serverless functions, Prisma, and a Postgres database hosted on Railway. If you want to take a look at the code for this repository, it's available at github.com/netlope/nextjs-prisma-demo. And I'm available on Twitter at netlope. If you have any questions, my DMs are wide open. Thanks so much for coming to my talk, and have a great day.
Hello, Hassan. That's a brilliant talk. And I guess all the attendees are already happy with how smooth the setup can be and how fast Prisma and Next.js can make you productive and work together.
Thank you so much.
We have Rajat as well here. Hi, Rajat.
Hi, Hassan. Thank you for joining us all the way from US. It must be really late, right?
It's actually pretty early here.
Oh, yeah.
7 a.m. So.
So one question, Hassan, since you work with Vercel itself, we could see a lot of things being supported by Next.js. You guys are already moved to this module federation with the website performances, with integrations with things like Prisma. So what is your motivation, or like how are you planning to? What is the main focus area for you guys?
Much as possible. We just want to make it, as easy as possible for developers to create these, great full stack applications. And, just be able to not necessarily like go and have to configure a ton of things or go and need to put in a ton of work. We just want to make it as easy as possible. And so we're just constantly iterating on that and trying to improve the developer experience and with new releases.
Amazing. So yeah, that's a good thing, because even I'm a fan of things like Redwood.js, but I feel they're more opinionated and everything is pre-configured. Whereas with Next.js, you still do a lot of work for us, but still everything is like individual pieces where we can, as developers, we can control and decide. That's a beautiful thing you guys are doing.
Thank you. Yeah, we like to pride ourselves that we're like a zero config framework where you can just install Next.js and use it right out of the box. You don't have to do any configurations. But at the same time, like you said, it's really extensible where, you can connect it to a variety of tools and you can customize it as much as you want and do server-side rendering here and client-side rendering here and use ISR and a bunch of different things. So.
Yeah, perfect. Exactly. There's one audience question. Does Prisma supports MongoDB?
That is a good question. I saw that on the website. So it's either supported now or they're working on support. I think they might still be working on it. Let me actually check. MongoDB. No, it looks like it's supported.
Oh wow. Yeah, that's a good news. Cool. So I really enjoyed this talk and the way you presented and things. Happy to have you here, and we really are honored to have you here.
I really appreciate that. Thank
just
you
a sec. I think we have another question. What about GraphQL? Cool. Okay.
Awesome.
So Hassan, if you are still available, you can head over to the lounge area, and guys, if you have any questions, if you're feeling shy about asking here, you can head over there and you can personally connect with them and clear all your doubts about Next.js and how to build serverless apps.
For sure. Yeah.
Cool. Yeah.
I know.
Okay.
Sure.
Oh, well, guys, that brings us to the end of day one. So, Vilva, what was your favorite talk?
I had multiple. Almost I loved every talk, but my most favorite was story of Michael Chang.
Yes, that was a very good talk. Yeah.
Yeah, it was very deep. And next, I'll say Siddharth's live coding was also really good.
Yes.
Yeah.
Well, guys, thank you so much for sticking with us through the entire day. I know in the beginning we had some technical issues. It was a big roller coaster. Some talks did not go through properly, but we are going to make sure that the recordings are shared properly with you. I'm sure we are. So stick around, please come back tomorrow. We have great talks for you tomorrow as well. And we have a really great panel discussion as well and few other amazing things. Also, Vilva, do you have anything to add?
Tomorrow will be a better day.
Yes. Okay. If that is all, we will see you tomorrow. Thank you, guys. And thank you for joining us. Bye.
See you guys.
Previously at React India.
React India.
Previously at React India.